Integrated Circuits Division. Fast Track to SCSI. Product Guide. Fujitsu Microelectronics Incorporated. Copyright registered 1989 Fujitsu Microelectronics LNC, San Jose, California. All rights reserved. Circuit diagrams utilizing Fujitsu products are included as a means of illustrating typical semiconductor applications. Complete. Information sufficient for construction purposes is not necessarily given. The information contained in this document has been carefully checked and is believed to be reliable. However, Fujitsu Microelectronics LNC assumes no responsibility for inaccuracies. The information conveyed in this document does not convey any license under the copyrights, patent rights or trademarks claimed and owned by Fujitsu Limited, its subsidiaries, or Fujitsu Microelectronics Incorporated. Fujitsu Microelectronics Incorporated reserves the right to change products or specifications without notice. No part of this publication may be copied or reproduced in any form or by any means, or transferred to any third party without prior written consent of Fujitsu Microelectronics, Inc. This document is published by the Publications Department, Fujitsu Microelectronics Incorporated. 3545 North 1st Street, San Jose, California, 95134 to 1804, USA. Application notes are provided by the Applications Engineering Department of Fujitsu Microelectronics Incorporated. Printed in the USA. Edition 1.0. 11. Notice to the reader. In response to your request for literature on our SCSI product line, please find enclosed a preliminary copy of our SCSI user manual. We apologize for not being able to supply you with a final printed version of the document and hope this interim copy is temporarily acceptable. The technical contents are correct and future versions will simply include additions such as background information, table of content, and an index. The final version will be completed by the end of September. Thank you for your understanding. Chapter 1. Product Overview. The following section is a detailed description of the SCSI Protocol Controller, SPC. Registers. Please note the SPC's individual bit functions within the registers use positive logic, i.e., to turn a function on or assert a condition, write a 1 to the respective bit location within the register. To turn a condition off or to deassert, write a 0 to the bit location. Fujitsu SPCs share a common architecture consisting of 16 directly addressable registers. All products are 100% software compatible with one another, making migration within the product line a relatively simple process. Accessed via a unique 4-bit address, A3. AO, the register set is laid out in a logical and straightforward manner to simplify the job of firmware design. Many critical functions such as arbitration, phase sensing, handshake, and data transfer count are all handled in hardware, thus reducing software overhead and development time while increasing performance. All products feature an 8-byte first in first out, FIFO, to ease timing requirements between the system bus and the SCSI bus. Fujitsu SPCs can be driven using hardware interrupts, or they may operate in a polled mode with interrupts disabled. An implementation requiring a combination of polled and hardware interrupts can also be accommodated. The 3 operating modes of the Fujitsu SPCs include a manual transfer mode, where total control of the SCSI bus signals is possible, i.e., direct control of the REQI handshake. The designer will find this operating condition useful for testing and debugging software and hardware. The other two operating modes are designed for automated data transfers. The program transfer mode is designed for non-direct memory access, DMA, transfers with complete hardware handshake. This mode is useful for short data transfers. The DMA mode is used for large block transfers. On-chip DMA interface logic simplifies hardware connection to commercially available DMA controllers. 1. Product overview. Fast track to SCSI. In addition to the aforementioned transfer modes, Fujitsu SBCs also feature a diagnostic mode for simulating events on the SCSI bus. This mode can be used to check the software and the SBC hardware interface without actually connecting it to the SCSI bus. The Fujitsu SBC family consists of general-purpose controllers. The four products can be grouped into two product categories: asynchronous and synchronous data transfer method. Within each of these groups we offer a version with on-chip single-ended drivers and a version optimized for differential drive, to be used with off-chip drivers. The optimization for differential drive consists of the separation of SCSI out and SCSI in ports, see figure 1:1. If these buses were combined, 3-state logic would be required between the driver/receiver and the SBC to support the arbitration feature of SCSI. The following explanation is offered to help clarify this point. According to the ANSI X.131-1986 document defining SCSI, when SCSI devices arbitrate for control of the SCSI bus, each must assert their individual ID bit. Bits 0 through 7 are available, with bit 7 awarded the highest priority. While asserting 1 bit, the SBC must concurrently read the other 7 lines to determine if arbitration was won or lost. Simultaneous assertion of 1 bit while reading others necessitates the use of 3-state logic. The complexity and added connections required for differential drivers makes the addition of 3-state logic significant. Fujitsu SBCs eliminate the need by allowing the SBC to read incoming IDs on the SCSI in bus while asserting the ID bit on the SCSI out bus. In a single-ended environment the number of connections is relatively low, so using 3-state logic does not add a significant amount of logic to the board. Those SBCs that contain on-chip single-ended drivers feature a single SCSI I/O port and on-chip 3-state circuitry. As stated earlier, the Fujitsu SBCs are based on a common architecture, so the functional and operational descriptions found in chapters 3 and 4 respectively apply to all products, except where noted. The following descriptions and tables are provided as a means of highlighting the distinguishing features of each SBC. 2. Fast track to SCSI product overview. S. Y. N. C. H. 0. N. 0. U. S. A. S. Y. N. C. H. 0. N. 0. U. S. Accommodate differential or single-ended SCSI out. MB89351. 64-pin DIP. 64-pin flat pack. On-chip open collector drivers. MB87033 star. BO PLN FLAL pack. 84 PLN PLCC. Under development. MB89352. 48-pin DIP. 48-pin flat CK. Figure 1:1. Bus structures in relation to chip features. Asynchronous vs synchronous and on-chip driver versus off-chip drivers. This matrix illustrates the various bus structures and how they relate to the chip features. MB8730CR and MB873031PF. These designs are best suited for high-performance applications requiring differential drivers and synchronous transfer capability. Separate control and data buses allow uninterrupted access to the SBC. This is particularly critical during synchronous data transfer operations. A combined bus structure would require the transfer to stop while the MPU is accessing the chip. MB873033B. The MB873033B is also intended for high-performance systems requiring synchronous data transfer. However, the MB873033B includes on-chip single-ended drivers allowing direct connection to a single-ended SCSI bus. Separate control and data buses permit the central processing unit, CPU, to monitor the SBC during high-speed synchronous burst data transfers. 3. Product Overview Fast Track to SCSI. MB89351. The MB89351 is based on the MB87030 except the synchronous logic has been removed. Intended for lower-cost applications, the MB89351 combines the data and control buses as a means of reducing pin count, external parts count, and cost. The MB89351 features separate SCSI in and out buses similar to the MB87030/31. This configuration simplifies the interface to differential drivers by eliminating the need for three-state logic. MB89352. This device is functionally the same as the MB89351 except the single-ended drivers are on-chip. Because the device is used only in single-ended applications, the SCSI in and SCSI out buses are combined. Table 1:1 highlights the salient features of each device. Table 1:1. Device features. MB7033, MB7030, MBs9352, MBs9351. MB7031. Single-ended driver /RCVR on-chip no. Differential driver /RCVR no external. Synchronous transfer yes no. Transfer byte counter 2s bit 24 bit. Arbitration fail interrupt yes no. ATN condition. Detect interrupt yes no. FIFO full/empty interrupt no yes. Interrupt signal line count 2111. MPU bus parity generator yes no yes. DMA bus separate common. From CPU to CPU. Bus. Process CMOS. Package OFP SOP PGA8 SC DIP4 SP SDIP 64P. LCC S4P OFP 100P OFP 48P OFP 64P. 4. Chapter 2. Architecture. Addressing. A unique address is assigned to each internal register, and a particular register is identified by address bits A0 to A3. Table 2:1 shows internal register addressing. Internal register assignments. Table 2:2 shows the bit assignment to each internal register. When accessing an internal register, in read/write, remember the following. 1. The internal register block includes read-only/write-only registers. 2. Some registers serve two functions depending on whether the register is being written to or read. 3. A write to a read-only register is ignored. 4. If a write-only register is read out, the data and parity bit are undefined. 5. At bit positions indicating -4 a write in tables 2:1 and 2:2 indicate either 1 or 0, and may be written. 5. Functions fast track to SCSI. Table 2 to 1. Internal register addressing. CSA3A2 LAD op register name ABBR 00000 R. Bus device ID BDID W 00001 RSBC control SCTL W 00010 R command SCMD W 00011 R transfer mode TMOD W 00100 R interrupt sense INS W reset interrupt 00101 R phase sense PSNS WSBC diagnostic control SDGC 00110 RSBC status SSTS W 00111 RSBC error status SER W 01000 R phase control PCTL W 01001 R modified byte counter MBC W 01010 R data register DREG W 01011 R temporary register temp W 01100 R transfer counter high TCH W 01101 R transfer counter middle TCM W 01110 R transfer counter low TCL W 01111 R external buffer EXBF underscore W 6 fast track to SCSI functions. Table 2 to 2 internal register bit assignment hex name op765432210p address ABBR 0 bus device RSSI bus dries 10 bold number 7 I number 6 I number 5 number 4 number 3 number 21 number 11 number 00 W SCSI bus device 10 104 102 101 1 SBCR reset control diagram Arbit parity select reselect int P control RN reset mode enable N SCTL W disable able 2 command R transfer modifier P SCMD R command code RST inter WI outcept PRG0 term SFR mode 3 transfer rsync max transfer min transfer 00p mode isFR offset period TMOD W 42121 4 interrupt R selected resol disconcom service time SBC reset P sense acted nect MAND required out hard con INS com error addition plit reset W reset interrupt 5 phase R Rio AKDN cell BSY message C/0110p sense W PSNS 5 SBCR diagnostic diagram 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 control W SDGC Rio AC BSY message C/0110 6 SBCR connected SBC SFR in SCSI DC equals ODREG status P status ineditarg busy pro RST full I empty SSTS gress W 7 SBC error R date error 00 TCP phase short offset P. Status SCS SBC error period error. SIR. W. 8 phase R bus. Transfer phase. P. Control I free. PCTL, W omter message C/0110. Write 0 we out. Enable. 9 modified RI. 2 MB1C. Byte 0 bit 31 I0P. Counter. W. MBC. 7. Functions fast track to SCSI. Table 2 Internal register bit assignment, continued. Hex name op7 I6 I5 I4 I3. 1. 21 1. I0P. Address, ABBR. A data R internal data register, 8 byte FIFO. Register. P. DREG, W. Bit 7 I6 I5 I4 I3 I2 J1 I0. Temporary data input from SCSI, P. B temporary R. Bit 7 I6 I5 I4 I3 I2 I1 I0. Register. I. Temp. Temporary data, output from SCSI. P. W bit 7 I6 I5 I4 I3 I2 J1 I0. C temporary RIIIIIIIP. Counter transfer counter high, MSB. High. Bit 23 I22 21 20 19 18 17 16. TCH, WIIJIII. D temporary R. IIIIIIIP. Counter. Transfer counter middle, second byte. Mid W. Bit 15 I14 13 12 11 10 17 8. TCM, III. E temporary R. IIIIIIP. Counter F transfer counter low, LSB. Low W bit 76543210. TCL, IIIIIJI. E temporary R. IIIIIIP. Counter I external buffer. Low W. Bit 7 I6 I5 I4 I3 I2. I1. I0. TCL. 8. Fast track to SCSI functions. Functional blocks. Figure 2:1 shows the SBC functional block diagram. SBC mainly consists of the following. Functional blocks. 1. Internal register block. 2. MPU interface control block. 3. Bus phase control block. 4. Arbitration/selection sequence control block. 5. Transfer sequence control block. 6. Transfer byte counter block. 7. Data buffer register block. 9. Functions fast track to SCSI. 2. D7-P equals B. TCH R dash R : TCM I W REOI REAO F A DREQ transfer R ACKI control I dash equals LDRISP ACKO I LHIN ATNI dot MSGI I dash MBC HDBI equals J 7 dash PC slash DL : I minus 1 ATNO MSGO dot A C slash do vol phase DREG VU control 0 RSTIR RSTO I A 1. B. Dash. SDBE, dash 7, P2. Dash dash. SDBQ, dash 7. I. 3. TL, O. Comma. LJ. 4. R. SDBI, dash 7, X. 5. HHY dash. Dash dash. 6. CellOJ, IL7. Cell. BSYOR arbitration. RM. BSYI. And selection CRX. Logic. Init, out, RST. J1 temp. Targ. INTR. RA3AO. R. Ints F equals, J dash equals, J. Address. CS. Decode. Interrupt vSphere. Equals colon. And MPUME, MJG. And status interface. RWTWTG. FSSTS equals colon. Dash. Figure 2:1. SBC functional block diagram. 10. Fast track to SCSI functions. Operation or block diagram description. MPU interface control block. The MPU interface control block selects a specified internal register and controls a read/write operation. This is done to report the result status of the SBC internal operation, and the detection of an error, if encountered. Bus phase control block. The bus phase control block generates a specified bus phase for SCSI and controls its sequence of execution. Also, this block supervises SCSI status, and responds to the bus phase being executed if necessary. Arbitration/selection sequence control block. The sequence control block executes the ARBI1 ration phase with the SCSI specified timing and obtains permission to use the SCSI bus. Then, it carries out the SELECFION/reselection phase and checks the response from the selected/reselect device. Also, this block detects the selection/reselection phase on SCSI, and checks the bus device ID specified in the internal register against that specified on the SCSI data bus. Then, if this block finds that SBC has been selected by another SCSI bus device, it executes the response sequence for the SELECFION/reselection phase. Transfer sequence control block MB87030/1/3. This sequence control block controls the data in /out, command, status, and message in /out phases to be executed in SCSI. The following two modes are available for execution of these transfer phases. 1. Manual transfer mode. In manual transfer mode, the MPU interface is used for transferring data and sending/receiving/checking the REQ/ACK signals on SCSI. 11. Functions fast track to SCSI. 2. Hardware transfer mode. In hardware transfer mode, SBC controls the SCSI transfer sequence according to the transfer mode and transfer byte count specified in the internal registers, and reports the end result of transfer. In the asynchronous mode transfer operation, the REQ and ACK signals are controlled by the interlock protocol. In the synchronous mode transfer operation, a maximum of 8-byte offset is available for the data transfer phases. The hardware transfer mode is subdivided into two modes, according to the data routing. A. Program transfer mode. Data is routed via MPU interface in the following data paths: SCSI H data buffer register H data bus lines D7 to DO and DP. B. DMA mode. Data is routed using DREQ and DRISP signals for DMA control in the following data paths. SCSI H data buffer register H data bus lines HDB7 to hobo and HDBP. Transfer sequence control block MB89351 and MB89352. This sequence control block controls the data in /out, command, status, and message in /out phases to be executed in SCSI. The following two modes are available for execution of these transfer phases. 1. Manual transfer mode. In manual transfer mode, the MPU interface is used for transferring data and sending / receiving / checking the REQ / ACK signals on SCSI. 2. Hardware transfer mode. 12. In hardware transfer mode, SBC controls the SCSI transfer sequence according to the transfer mode and transfer byte count specified in the internal registers, and reports the end result of transfer. In the asynchronous mode transfer operation, the REQ and ACK signals are controlled by the interlock protocol. The hardware transfer mode is subdivided into two parts according to the following data routing. Fast track to SCSI functions. A. Program transfer. Data transfer between the MPU and SCSI is executed using DREG. The DREG status is acknowledged by the MPU with one of the following methods. The MPU reads the SSTS register at any time and controls data transfer. According to the results, INTR, interrupt signal, is sent to the MPU to acknowledge the DREG needs data or has data as a result of reading from or writing in SCSI. B. DMA transfer. In this mode, the SBC executes data transfer with the MPU via DMAC by sending the DREQ signal. When requesting memory access, the SBC makes the DREQ signal active. During an input operation, DREQ is sent when the SBC internal data buffer register contains data received from SCSI. During an output operation, DREQ is sent when all bytes specified by the transfer byte counter have not yet been fetched and the internal data buffer contains empty bytes. DREQ is not a L byte transfer request. DREQ is kept active while the SBC is in the conditions explained above. Also, the JACK signal may be kept active if the response can be continuously issued. It does not have to be pulsed for each byte. Transfer byte counter block. The transfer byte counter indicates the number of bytes to transfer from SCSI for hardware transfer mode operation. It is 24 bits long. MB87033B transfer byte counter is 28 bits. Except for execution of a special transfer operation, padding, the transfer byte counter is decreased by 1 each time 1 byte of data is transferred on SCSI. The transfer byte counter is also used as a timer for supervising the waiting time for a response to be returned from the selected SCSI bus device during execution of the selection/reselection phase. The three 8-bit registers, TCH, TCM, and TCL, make up the 24-bit counter. 13. Functions fast track to SCSI. Data buffer register block. The data buffer register block is used in execution of a hardware transfer mode operation in SBC. It has a capacity of 8 bytes, and operates on the FIFO principle for each byte. In an input operation, from SCSI to SBC, data received from SCSI is loaded into the buffer register. In DMA mode, transfer request signal DREQ is generated to the external buffer memory. Also, in program transfer mode, data can be read out from this buffer register. In an output operation, From SBC to SCSD, data supplied from the MPU interface, program transfer mode, or external buffer memory, DMA mode, is loaded into the buffer register and then sent to SCSI. In this case, a maximum of 8 bytes of data is prefetched into the SBC. The 8-byte FIFO appears as a single register, DREG, to the MPU interface. In an input operation, the byte locations holding valid data are selected in succession for reading out. In an output operation, the empty byte locations are selected in succession for writing in. 14. Chapter 3. Operational description. 15. Operational description fast track to SCSI. 16. Fast track to SCSI operational description. BDID. Address. Number 0. Bold register, bus device identifier register. OP765432210P. Bit significant bus device ID. R. I. Number 7, number 6, number 5, number 4, number 3, number 2, number 1, number 00. W. SCSI bus device ID. ID 4. I. ID 2, ID 1. 17. Operational description fast track to SCSI. Write operation, bits 2 to 0. The bold register specifies the SCSI bus device identifier of the SBC, ID, as a 3-bit binary number. This setting must be completed before resetting the SCTL register's bit 7. Reset and disable. Bits 2 to 0 are cleared during a power-on reset only. Read operation. The bold register indicates the SCSI physical device ID of the SBC. The SCSI physical device address is decoded from the values of bits 2 to 0 as specified in a write operation to the bold register described above. One of the bits is 1, the others are all zeros. The SCSI bus usage priority is assigned in descending order from bit 7 to bit 0. Using a bus device ID indicated in this register, the SBC executes the arbitration phase. Also, if a selection/reselection phase condition occurs in SCSI, the value of the SCSI data bus is checked against the contents of this register to see whether the SBC has been selected/reselect or not. Examples: writing hex 03 to this register will result in hex 08 being read. Writing hex 07 to this register will result in hex 80 being read. 18. Fast track to SCSI operational description. SCTL. Address. Number 1. SCTL register, SBC control register. OP765432210P. R reset. Control diagram arbit parity select reselect int. P. And W disable. Reset mode enable. Bit 7, reset and disable. Bit 7 generates a reset instruction to the internal registers and control circuits in the SBC. When this bit is 1, the SBC is reset and logically disconnected from SCSI, put in the disable state. Execution of the hardware reset, RST input equals L, causes this bit to be 1. To enable the SCSI operation, bit 7 must be made 0 to enable SBC operation. 19. Operational description fast track to SCSI. Bit 6, control reset. The data transfer control circuit is reset when this bit is 1. Even if the control reset is execute by this bit while the SBC is connected to the SCSI bus, the SBC maintains the connection with SCSI. This bit should be used for resetting the data transfer control circuit while it is connected with SCSI. More specifically, it should be used when an error is indicated by bit 1, SBC hardware error, of the INS register during execution of the SCSI transfer phase or when a timeout occurs before completion of transfer command execution, supervised by the MPU program. Bit 1, SBC hardware error, of the INS register and the SER register are cleared by this bit. Note, this reset function initializes the SBC transfer control circuits. So, when the SBC serves as an initiator, the following consideration is required. Since the REQ signal may be active during control reset, the first byte should be transferred in manual mode after resetting. Bit 5, diagnostic mode. When bit 5 is 1, the SBC enters a diagnostic mode and is disconnected from SCSI. The diagnostic mode allows pseudo execution of the SCSI operation using the SDGC register, to be explained later. Bit 4, arbitration enable. Bit 4 indicates whether the arbitration phase is executable in SCSI or not. 1. Arbitration phase executable. O. Arbitration phase non-executable. With this bit set to 1, the select command causes the SBC to execute the arbitration phase. If the SBC wins the arbitration, it executes the selection/reselection phase. With this bit set to 0, the select command causes the SBC to execute the selection phase without the arbitration phase. As long as bit 4 is 0, the SBC will not respond to a reselection request from other SCSI bus devices. No response is made even if bit 1, reselect enable, of this register is set to 1. Remember that bit 4 must be set correctly before clearing bit 7, reset and disable, of the SCTL register. Note also that this bit should not be changed in other than a diagnostic mode after clearing bit 7 of the SCTL register. 20. Fast track to SCSI operational description. Bit 3, parity enable. Bit 3 indicates whether the parity of data received from the SCSI data bus is to be checked or not. 1. Parity of the data received from the SCSI data bus is checked. Degree. Parity of the data received from the SCSI data bus is not checked. Regardless of the value of this bit, the parity of the data to be sent to the SCSI data bus is ensured. Also, the parity of the data on the SBC internal data bus is always checked. Note, while the SBC is connected with SCSI, this bit should not be changed. A parity check is carried out in the following cases. 1. When checking an ID value placed on the data bus upon detection of the selection/reselection phase in SCSI, detection of a parity error causes no response to the selection/reselection phase even if the SCSI bus device ID has been matched. 2. If a parity error is detected in a data byte, when receiving data from SCSI in an input transfer sequence, the relevant parity bit value is corrected and the data byte with the corrected parity is sent to the MPU/DMA data bus. Bit 2, select enable. 1. The SBC responds as a target device to the selection phase in SCSI. Degree. The SBC does not respond to the selection phase in SCSI. Note, if the SBC has already detected the selection phase during an attempt to set this bit to 0, the SBC responds to the selection phase as a target device. In this case, the degree setting is effective for the subsequent selection phase, with no response. Bit 1, reselect enable. 1. SBC responds as an initiator to the reselection phase in SCSI. Degree. SBC does not respond to the reselection phase in SCSI. Note, if SBC has already detected the reselection phase during an attempt to set this bit to 0, SBC responds to the reselection phase as an initiator. in. 21. Operational description fast track to SCSI. This case, the 0 setting is effective for the subsequent RESELECFION phase. With no response. Bit 0, interrupt enable. Bit 0 serves as a mask for enabling/disabling the hardware interrupt, INTR, output from the SPC. 1. Interrupt enabled. A. Interrupt disabled. A hardware interrupt due to a reset condition detected in SCSI cannot be masked. Regardless of the value of this bit, an interrupt event is always indicated in the INSREG. ISTER. This allows poll mode operation when the hardware interrupt, INTR, is disabled. 22. Fast track to SCSI operational description. SCMD. Address. Number 2. SCMD register, SBC command register. OP765432210P. R. RST. Inter. TNSE, Madre, P. Command code. Out. Sept PRG0 term. vSphere mode. Register functions. The SCMD register is used for issuing a command to the SBC. Writing into this register causes the SBC to initiate the command specified with bit 7 to 5. 23. Operational description fast track to SCSI. Bit 7 to 5, command code. Bit 765 command. 000 bus release. 00 select. 010 reset ATN. 01 set ATN. 100 transfer. 01 transfer pause. 0 reset Acurio. 1 set Acurio. Bit 4, RST out. If bit 7, reset and disable, of the SCTL register is 0, setting bit 4 to 1 asserts the SCSI rest. Signal. When bit 4 is set to 1, a command being executed or waiting for execution in the SBC is cleared and all signals to SCSI other than RST are deactivated. To ensure for the SCSI timing requirements, the MPU must maintain this bit at 1 for more than 25 microsec. ONS. Note, if the RST signal is received from the SCSI bus with this bit set to 0, the operation sequence is as follows. 1. A command being executed or waiting for execution in the SBC is cleared. 2. All signals to the SCSI bus are deactivated. 3. An interrupt condition, non-maskable, is generated. Whenever bit 7, reset and disable, of the SCTL register is 0, the SBC always accepts the RST signal from the SCSI bus. Bit 3, intercept transfer. Bit 3 specifies the special data transfer mode. It is valid only when SBC serves as an initiator. This bit should be set to 1 together with the set ATN. Set ACK/REQ or bus release comm. MAND, bus release command has no effect when the SBC has been connected with SCSI. As an INMATOR, this bit should be reset together with the reset ACK/REQ command. When 2 or more bytes are transferred using the set ACK/REQ and reset ACK/REQ commands, this bit must be reset on issuance of the reset ACK/REQ command for the 24. Fast track to SCSI operational description. Last byte. With bit 3 of SCMD register set to 1, executing manual transfer, MPU controlled transfer using the set ACK/REQ and reset ACK/REQ commands, does not change the contents of the 8-byte data buffer register in the SBC. Therefore, if a target changes bus phase, i.e., it changes to message in during execution of the data out phase, This intercept transfer mode makes it possible to optionally restart the data. Out phase at the end of the interrupting phase. The phase change during transfer execution is reported by a service required interrupt. To execute this intercept transfer mode, bit 3 of SCMD register must be set to 1 prior to the resetting of an interrupt. An interrupt must be reset after bit is set to 1. Even when not using the intercept transfer mode, bit 3 may be specified for resetting a service required interrupt. In this case, bit 3 must be set /reset together with the bus release command. For more details, see the description of bit 3, service required, of the INS register. Bits 2 to 0, transfer modifier. Bits 2 to 0 are used as a field for specifying the execution mode of the information transfer phase. A value must be set in this field when the transfer command is issued. If any of the following commands are issued during execution of the transfer command, this field's value must not be changed. Set ATN. Transfer pause. Reset x/req. Bit 2, program transfer. 1. Data are transferred between the MPU and the data buffer register in SBC. 0. Data are transferred in the DMA mode in which the SBC signals a transfer request to the external buffer memory. Bit 1, unused. Bit 1 must always be set to a. Bit 0, termination mode. Bit 0 provides different functions depending on the SBC operating mode. When SBC serves as an initiator, bit 0 specifies the following operations. 25. Operational discretion fast track to SCSI. 1. Even after the transfer byte counter reaches a during execution of the transfer command, data transfer will continue if the REQ signal arrives from a target within the same phase. If an output operation is in progress, all A bits, with a parity bit set to 1, are transmitted as data. During an input operation, the received data is ignored. But parity is checked if it is enabled, parity enable. The above data transfer is referred to as padding transfer, which is effective only when the data in or data out phase is executed. Padding transfer is executed only within SBC, and a transfer request is not signaled to the external buffer memory even if the DMA transfer mode is specified. Padding transfer is maintained until a target changes the bus phase. In the padding transfer mode, if the transfer command is issued with the initial value of the transfer byte counter set to 0, execution of padding transfer is started with the first byte. To carry out an output operation in this case, the temp register must be set to X00 prior to issuance of the transfer command. One transfer command execution terminates when the transfer byte counter reaches 0. The transfer command must be reissued to receive the next REQ signal from a target. When the SBC serves as a target, bit A specifies the following operations. 1. If a parity error is detected in the received data during execution of the transfer command for input, the current transfer sequence is immediately stopped to terminate transfer command execution. Even if a parity error is detected in the received data during execution of the transfer command for input, the current transfer sequence continues until the transfer byte counter reaches 0. Command functions. Bus release command. 26. When the SBC acts as a target, the bus release command instructs a transition to the bus free phase. During execution of the information transfer phase, the transfer pause command must be issued to halt the data transfer operation prior to this command. Otherwise, the SCSI bus sequence is not ensured. The bus release command may also be used to cancel the select command waiting for the bus to fast track to SCSI operational description. Become free. Note that the bus release command is ignored if the SBC has already started the arbitration or selection phase. Select command. The select command requests the selection/reselection phase to be started. It shall be issued only when the SBC is not connected with SCSI. When the SBC receives this command, it carries out the following operation upon detection of the bus free phase is SCSI. 1. When bit 4, arbitration enable, of the SCTL register is set to 1. After the bus free phase has been detected, the SBC executes the arbitration phase to try to obtain bus usage permission. If the SBC has lost the arbitration, the select command terminates its execution. If the SBC has won the arbitration, the SBC executes the selection or reselection phase. The selection phase is executed when bit 0, IO, out, of the PCTL register is set to 0, and the reselection phase is executed when it is set to 1. 2. When bit 4, arbitration enable, of the SCTL register is set to 0. After the bus free phase has been detected, the SBC executes the selection phase. Before the select command is issued, the following settings must be made in either of the above cases. 1. PCTL register. Specify the phase to be executed at bit 0, IO out. 0 selection phase to be executed. 1. Reselection phase to be executed. Note that whenever bit 4, arbitration enable, of the SCTL register is set to 0, the selection phase is executed regardless of the value of bit 0 in the PCTL register. 2. setADN command. Issue the setADN command if it is required to assert an ADN signal at the selection phase. 27. Operational description fast track to SCSI. 3. Temp register. In the temp register, specify a value to be sent to the SCSI data bus during execution of the selection/RESELECFION phase. 4. TCH and TCM register. Specify a response, BSY signal, waiting supervisory time for execution of the SELECFION/reselection phase. The supervisory time TSL should be calculated as follows. Assuming that the value of TCH and TCM is N, MSB, TCH, LSB, TCM. When N does not equal 0, TSL equals NX 256 plus 15, XTTCLFX2. When N equals 0, T equals infinite. Where TCLF is a cycle time of the clock signal supplied to the CRK pin of the SBC. 5. TCL register. Specify a period of time, TWAIT, from the moment when both BSY and CEL signals become inactive on SCSI, upon detection of the bus free phase, to the moment when the SBC initiates the arbitration/selection phase. Parameters, x/do, to, x/of, can be specified in the TCL register. The average value can be derived using the following equation, where TWAIT equals TCL plus 6x TCLF2, TCL plus 7x TCLF. TCL equals the value in the TCL register. TCLP equals the cycle time of the clock signal supplied to the CRK pin of the SPC. Table 3:1 lists the recommended values for the TCL register. Table 3:1. TCL register recommended values for use of select command. TCLF, NS, TCL-TWAIT, average, NS. 124 to 180, 04, 16 1250 minus 1980. 140 to 200, 03H6 1260 to 2000. 28. Fast track to SCSI operational description. In arbitration phase execution by the select command, the bus device identifier, ID, which is sent to the SCSI data bus is the value specified in the BDID register. The following equation can be used to obtain the period of time, TARB, required from the moment when the arbitration is started, BSY signal assertion, to the moment when the bus usage priority is examined. TARB equals 32x TCLF, where TCLF indicates a cycle time of the clock signal supplied to the AX pin of the SBC. After the selection/reselection phase execution is started, a timeout interrupt occurs if no response is acknowledged within the supervisory time specified in the TCH and TCM registers. When a timeout interrupt occurs, the SBC holds the current execution state of selection/reselection phase for SCSI. However, until the timeout interrupt condition is reset, the SBC executes no operation to the response from the bus device being selected. Either of the following procedures can be used for a timeout interrupt. Restart of selection/reselection phase. After specifying a new supervisory time in the TCH, TCM, and TCL registers, reset the timeout interrupt condition. Then, the SBC will restart the selection/reselection phase in progress. At this time, changing the temp register contents can alter the value being sent to the SCSI data bus. New supervisory time TSL is X. Pressed as follows. Assuming TCH, TCM, and TCL value to be N, MSB, TCH, LSB, TCL. TSL equals NX TCL FX2, NO. Where TCLF indicates a cycle time of the clock signal supplied to the CK pin of the SBC. Termination of selection/reselection phase. When a timeout interrupt occurs, the values of TCH, TCM, and TCL registers are O. Resetting the timeout interrupt condition in this state causes the SBC to deactivate all signals to SCSI and terminate the selection/reselection phase unless the BSY signal is returned. If the BSY signal is returned when the interrupt condition is being reset, then the SBC executes the normal sequence to complete the select command. To reset a timeout interrupt condition, set bit 2 of the INS register and TCM registers, and the timeout interrupt will not occur. However, the above timeout interrupt resetting procedure must be carried out to terminate the 29. Operational description fast track to SCSI. SELECTION/reselection phase in progress. If the SBC recognizes a response from the selected/reselect device during the selection/RESELECTION phase execution, the SBC executes an interface sequence to serve as an initiator at SELECTION phase, or target at RESELECTION phase. When the select command is issued, the SBC status is indicated in the SSTS register. Figure L shows the status. Transitions. SSTS register *1. Bit 65. Connected. Init targ. SBC. Busy. I unconnected. 000. Select. With SCSI. I command. I waiting for. 001 backslash bus free phase slash bus release command J underscore asterisk 2 arbitration backslash phase being I001 executed asterisk 3 no win selection backslash phase being I101 dash executed or timeout backslash residential election backslash interrupt I phase being 011 executed I selection 100 I phase completed slash amend complete reselection interrupt phase completed slash 010 figure 3 to 1 status transition in select command execution 30 fast track to SCSI operational description notes asterisk 1 check the SBC status after the elapsed time shown below following issuance of the select command 1. If arbitration enable bit is set to 0, the minimum waiting time is 22x clock cycle TCLF. 2. If arbitration enable bit is set to 1, the minimum waiting time is 55 plus set value in TCL x clock cycle TCLF. Asterisk 2. The select command waiting for bus free phase can be cancelled using the bus release command. However, if the bus becomes free simultaneously with issue of the bus release command, the select command remains valid to execute the arbitration and selection/reselection phases. The MPU program must make sure that the select command has been cancelled after more than 4 clock cycles pass from the time the bus release command, write to SCMD register, was issued. Asterisk 3, if the SBC lost the arbitration, the select command terminates automatically. A command complete interrupt does not occur. In this case, note that the register contents are unpredictable. When issuing the select command again, be sure to specify the relevant value, C2, E, TCL register. Note, the MB87033 can be configured to issue a command complete interrupt if the SBC loses the arbitration. setATN command. The setATN command is valid only when the SBC is acting as an initiator. If this command is issued prior to the select command, the ATN signal is sent to SCSI during the execution of the selection phase. If the setATN command is issued while the SBC is connected with SCSI as an initiator, the ATN signal is sent to SCSI immediately. When the parity checking for the SCSI data bus is enabled and the SBC detects a parity error in the data received from SCSI, during execution of the input transfer operation in hardware transfer mode, the ATN signal is sent automatically to SCSI regardless of the setATN command. See figure 3 to 2. The assertion of ATN signal is retained until the condition described in the following subsection, reset ATN command, is satisfied. However, the ATN signaling condition held in SBC by the setATN command issued prior to the select command is cleared if one of the following conditions is met. 31. Operational description fast track to SCSI. The select command is cancelled by the bus release command. A selected/reselect interrupt occurs before execution of the selection phase. Data bus invalid parity. REQ // AC // ATN / figure 3 to 2. ATN signal generation in data transfer. Reset ATN command. 32. The reset A1N command is used to reset the A1N signal being sent to SCSI. If the SBC generates an A1N signal, due to a parity error in the received data, during execution of the hardware transfer mode operation, do not issue this command to reset the A1N signal until execution of the current transfer command is complete. Also, to reset the A1N signal in manual transfer mode, execute the reset A1N command before the X signal is sent to SCSI. In the following cases, the SBC will automatically reset the A1N signal without the reset ATN command. On occurrence of a disconnected interrupt. On sending the last byte during execution of the message out phase in hardware transfer mode, see Figure 3. Fast track to SCSI operational description. Data bus. Last byte. Rio. //. // ATN. / Figure 3-3. ATN signal resetting in message out phase. Transfer command. The transfer command executes the following information transfer phases in SCSI. Daton/OUT phase. Status phase. Command phase. Message in/out phase. The transfer operation initiated by this command is referred to as a hardware transfer operation, the sequence of which is controlled by the SBC. Before issuing the transfer command, be sure to set up the following. 1. Transfer byte counter, TCH, TCM, TCL. Set the byte count of the data to be transferred, MSB, TCH, LSB, TCL. 2. Bits 2 to 0 of the PCFL register. Set a pattern indicating the phase to be executed. 3. TMOD register. Set detailed transfer mode. 33. Operational description fast track to SCSI. When the SBC serves as a target, it executes the information transfer phase specified in the PCTL register and terminates the transfer command when any of the following conditions is encountered. The number of bytes specified in the transfer counter have been transferred. Receipt of the transfer pause command. Detection of a parity error in the received data during an input operation with bit O, termination mode, of the SCMD register set to 1, when the parity checking is enabled. When the SBC serves as an initiator, it starts the transfer operation as follows. 1. If the REQ signal is received before the transfer command is issued, the SBC compares the phase requested by the SCSI with that specified in the PCTL register at receipt of this command. Then, if they march, the SBC starts the transfer operation. 2. If the REQ signal has not been received when the transfer command is issued, the SBC will wait to execute this command. When the phase specified in the PCTL register matches that requested by SCSI on receipt of the REQ signal, the SBC will start the transfer operation. In the above phase comparison, if a phase mismatch occurs, the transfer command is nullified, and the SBC generates a service required interrupt. On occurrence of this interrupt, check the PSNS register for the phase requested by the SCSI bus, and issue the transfer command again or carry out manual transfer. When the SBC serves as an initiator, transfer command execution terminates when any of the following conditions is encountered. 34. In other than the padding transfer mode, transfer command execution terminates when the transfer of data of the byte count specified in the transfer byte counter is completed. When another information transfer phase is requested by the target. In the padding transfer mode, transfer command execution terminates when an other information transfer phase is requested by the target. Transfer command execution terminates when disconnected interrupt occurs. Fast track to SCSI operational description. Transfer pause command. The transfer pause command prematurely halts a hardware transfer operation initiated by the transfer command when the SBC serves as a target. Note that the transfer pause command cannot be used when the SBC serves as an initiator. On receipt of this command, the SBC performs the following. 1. Stops sending another REQ signal to SCSI, in an input operation. 2. Stops sending a transfer request, DREQ, signal to the external buffer memory, in a DMA mode output operation. Note, for an output operation in program transfer mode, a write to the data buffer register is not allowed after this command has been issued. Finally, the hardware transfer operation terminates when the internal data buffer register in the SBC becomes empty. Set ACKLREQ command. The set ACK/REQ command is used to set ACK or REQ signals for SCSI during execution of manual transfer. When the SBC acts as an initiator, this command causes the ACK signal to be sent. When SBC acts as a target, it causes the REQ signal to be sent. In manual transfer mode, data is transferred via the temp register. In this case, the pattern type of the information transfer phase to be executed must be preset in bits 2 to 0 of the PCTL register. During execution of manual transfer, the transfer byte counter remains unchanged. Figures 3 to 4 and 3 to 5 show the manual transfer procedures. Reset ACKLREQ command. The reset ACK/REQ command is used to reset the ACK or REQ signals to the SCSI bus. When the SBC acts as an initiator, this command resets the ACK signal \. When the SBC acts as a target, it resets the REQ signal. Use this command for execution of manual transfer. See figure 3 to 4 and 3 to 5 for the manual transfer procedures. Also, reset the ACK signal for the last byte in the message in phase of the hardware transfer mode. In the message in phase, the end of the transfer command is reported with the ACK signal for the last byte being asserted. The MPU program checks the validity of the received message first, then issues this command. In this case, the ATN signal, if necessary, may be sent out using the set ATN command prior to this command. 35. Operational description. Fast track to SCSI. REQJ \ACK/ SCSI temp. Figure 3 to 4. Manual transfer procedure, SBC serving as a target. 36. Fast track to SCSI operational description. RECJ \____ ACK ___ SCSI temp. Figure 3 to 5. Manual transfer procedure, SBC serving as an initiator. 37. Operational description. Fast track to SCSI. Command termination report. 1. Immediate commands. The following are immediate type commands which terminate operations immediately after being issued. For these commands, the SBC does not report termination. Set ATN. Reset ATN. Set ACK/REQ. Reset ACK/REQ. 2. Interrupt commands. For the following commands, an interrupt occurs at the end of execution. The interrupt cause is indicated in the INS register. Select. Transfer. 3. Non-interrupt commands. The following commands terminate with different timings depending on the SBC operation being executed. Check the termination status according to the status information in the SSTS register. Termination status, SSTS register. Bit 7654. Init targ SBC vSphere in PRG. Transfer pos 0100. Bus release. Asterisk. 0000. Note, if a selected /reselect interrupt condition is detected immediately after termination of the bus release command, an interrupt occurs and either the init or targ bit is set. 38. Fast track to SCSI operational description. Command issuance timing. Issuance of a command requires a write to the SCMD register. The SBC synchronizes a write to the SCMD register with the clock supplied from the CIK pin, and then starts executing the command specified at bit 7 to 5. Figure 3 to 6 shows the command execution timing. When issuing commands successively, leave an interval between them for more than the sync loss period, 4 clock cycles, in the SBC. A 3 AOV 0010 VA __ D7 do DPR WT. Synchronization. Command received. Start 01 command execution. Figure 3 to 6. Command execution timing. 39. Operational description fast track to SCSI. 40. Fast track to SCSI operational description. Op 7. rsync /sphere w tmod register MB87030/31133 only. Transfer mode register 654321. Max. Transfer offset min. Transfer 0. 4. I. 2. I. 1. Period. 21. TMOD. 0. 0. Address. Number 3. P. P. Register functions. Bit 7, synchronous transfer. 1. Indicates that the data in /out phase is executed in synchronous transfer mode. The command, status, and message in /out phases are executed in asynchronous transfer mode regardless of this bit value. 41. Operational description fast track to SCSI. O. Indicates that the data in /out phase is executed in asynchronous transfer mode. Bit 6 to 4, maximum transfer offset. Bit 6 to 4 indicate a maximum value of the REQ/ACK offset to be used in synchronous transfer mode. Bit 6 bit 7 bit 4 maximum offset value. 0008. 0 to 1 0 to 1 1 minus 1 1 to 7. When the SBC serves as a target, it sends the REQ signal in advance within the specified maximum offset value. When the SBC serves as an initiator, it can receive the REQ signal and input data within the specified maximum offset value. If the maximum offset value is exceeded in reception of the REQ signal, an error condition is detected at bit 0, transfer offset error, of the SER register. Bit 3 and 2, transfer period. Bits 3 and 2 indicate a parameter for determining the minimum repeat cycle of the REQ and ACK signals in synchronous transfer mode. Specify a period between the trailing edge of the REQ, ACK, signal and the leading edge of the next REQ, ACK, signal in multiples of a clock signal cycle, TCLP, supplied at the CK pin of the SBC. Figure 3 to 7 shows an example of a transfer period setting. In synchronous transfer mode, the REQ, ACK, signal pulse width, typical, equals a cycle of the clock signal, TCLF, supplied to the CIT pin. Transfer mode setting timing. The TMOD register value determines the way the data in /out phase is executed. When SBC serves as a target, specify the data in /out phase, C/D, message equals 00, in the PCFL register. And, before issuing the transfer command, be sure to complete the TMOD register setting. When the SBC acts as an initiator, be sure to specify a correct value before the target initiates the data in /out phase. A target's phase changing. 42. Fast track to SCSI operational description. Time and the period from it, until transmission of the first REQ signal, are unpredictable. Therefore, set the transfer mode with the following timing. 1. After completion of selection phase. A. Before issuing the transfer command for execution of the command phase. B. Before resetting the ACK signal for the last byte in the message in phase. Before issuing the reset ACK command, if a synchronous data transfer request message is transmitted at the end of the command phase. 2. After reselect interrupt. Before issuing the reset ACK command in the message in phase, identify message I REQ ACK FTT NXTCLF / Figure 3 to 7. Transfer period setting. 43. Operational description fast track to SCSI. 44. Fast track to SCSI operational description. Ints. Address. Number 4. Ints register, interrupt status register. OP765432210P. RSEAL RESEAL DIS command service lime SBC reset P. TID connected complete required out hardware Kindi. Errortion. W reset interrupt. Register functions. The LNTS register is used to indicate the cause of an interrupt and reset it. An interrupt issued by the SBC, INTR pin, can be masked by bit 0, anti-enable, of the SCTL register. Except an interrupt whose cause is indicated at bit 0 reset condition. To clear an interrupt, set 1 at the corresponding bit position in this register. Note that only the interrupt condition specified by 1 is reset. The bit positions having OS remain unchanged, corresponding interrupt conditions are maintained. In this register, 2 or more interrupts may be reset at the same time. 45. Operational description fast track to SCSI. Interrupt processing. 1. Selected interrupt, bit 7. Bit 7 indicates that the selection phase in SCSI has resulted in the SBC being selected from another bus device, initiator. When the SCSI on phase is detected, the SBC checks the contents of the SCSI data bus. If the following conditions are satisfied, the SBC executes a response sequence on SCSI, then generates a selected interrupt. A. The ID specified in the bold register is selected. B. Not more than 2 bits are set on the SCSI data bus, excluding the parity bit. C. When parity checking is enabled, the parity bit value is correct. In the selection phase, the temp register holds the value of SCSI data bus. The SBC serves as a target from the occurrence of this interrupt until the bus release command is issued or the reset condition is detected in SCSI. During this period the SBC asserts the BSY signal to SCSI. Before issuing the bus release command, be sure to reset the cause of this interrupt. 2. Reselect interrupt, bit 6. 46. Bit 6 indicates that the reselect ion phase in SCSI has resulted in the SBC being reselect from another bus device, target. When the reselect ion phase is detected, the SBC checks the contents of the SCSI data bus. If the following conditions are satisfied, the SBC executes a response sequence on SCSI, then generates a reselect interrupt. A. The ID specified in the bold register is selected. B. Not more than 2 bits are set on the SCSI data bus, excluding the parity bit. C. When parity checking is enabled, a parity bit value is correct. In the reselection phase, the temp register holds the value of the SCSI data bus. The SBC serves as an initiator from when this interrupt occurs until when the disconnected interrupt occurs or the reset condition is detected in SCSI. Before starting the transfer operation in SCSI, be sure to reset the cause of this interrupt. If the disconnected interrupt is indicated together with the reselect interrupt, reset both of these interrupts simultaneously. Fast track to SCSI operational description. 3. Disconnected interrupt, bit 5. Bit 5 indicates that the bus free phase has been detected in SCSI when bit 7, bus free interrupt enable, of the PCTL register is set to 1. Also, when the SBC serves as an initiator, bit 5 indicates transition to the bus free phase in SCSI. After this interrupt condition has occurred, the next selection/reselection phase may be executed in SCSI. However, the SBC does not respond to SCSI until this interrupt condition is reset. If the disconnected interrupt condition is detected during hardware transfer command, execution with the SBC serving as an initiator, the SCSI operation stops, but the SBC internal transfer sequence continues until one of the following events is encountered. The internal data buffer register becomes empty in an input operation. The data prefetch sequence to the internal data buffer register is completed in an output operation. When a disconnected interrupt occurs, check the SSTS register to confirm if the transfer operation has been completed. 4. Command complete interrupt, bit 4. Bit 4 indicates that the select command/transfer command operation has been completed. Completion of select command. This interrupt indicates that the SBC has acknowledged a response, BSY signal, from the selected bus device in selection/reselection phase execution. It indicates that the selection/reselection phase has completed in SCSI. The SBC serves as an initiator after the selection phase has been executed, and it serves as a target after the reselection phase has been executed. Completion of transfer command, when the SBC serves as a target. This interrupt indicates that the number of bytes transferred equals the byte count specified in the transfer byte counter, or, in an input operation with bit 0. Termination mode, of the SCMD register set to 1, this interrupt indicates transfer stop due to parity error being detected in the data received from SCSI. In either case, this interrupt occurs after checking that the ACK signal for the REQ signal of the last byte is inactive on SCSI during asynchronous mode transfer. This interrupt also occurs after checking that the number of ACK signals received. 47. Operational description fast track to SCSI matches the number of REQ signals transmitted during synchronous mode transfer. Completion of transfer command, when the SBC serves as an initiator. When padded transfer mode is not specified, this interrupt indicates the byte count specified in the transfer byte counter has been completed. When padding mode transfer is performed, This interrupt indicates that the current transfer operation has been terminated due to another transfer phase requested in SCSI. In this case, the service required interrupt occurs at the same time. In the message in phase, this interrupt occurs while the ACK signal to the last byte is held active. Before resetting this interrupt, be sure to issue the reset ACKJREQ command. 5. Service required interrupt, bit 3. 48. This interrupt indicates a request for MPU program intervention and only occurs if the SPC serving as an initiator is put in either of the following conditions. SPC has received the transfer command, but cannot start the transfer operation. Because the transfer phase specified by bits 2 to 0 of the PCTL register does not match that requested in SCSI. The SPC has stopped the current hardware transfer operation, transfer command, because of a request for another transfer phase in SCSI. In this case, the transfer operation in SCSI stops immediately, but the SPC internal transfer sequence continues until one of the following events is encountered. Input operation. The internal data buffer register becomes empty. Output operation. The data prefetch sequence to the internal data buffer register is completed. Fast track to SCSI operational description. Therefore, when this interrupt occurs, read out the SSTS register and check if the SPC internal transfer operation is completed. If the service required interrupt occurs during an output operation, the data prefetched in the SPC internal data buffer register may remain not sent to SCSI. To determine how to handle the remaining data, up to 8 bytes, see the interrupt processing procedure described below. When the service required interrupt occurs, the MPU program examines a transfer phase request from SCSI and proceeds to execute the transfer operation using one of the following procedures. Figures 3s and 3 to 9 show examples of interrupt processing procedure. Hardware transfer. The MPU program specifies the transfer phase pattern requested by SCSI as bit 2 to 0 of the PCTL register, and reissues the transfer command. Manual transfer. If this interrupt occurs during an output operation, the remaining data in the SPC internal data buffer register may have to be preserved. In this case, with bit 3, intercept transfer of the SCMD register set to 1, perform manual transfer and interrupt resetting. When the interrupted original transfer phase, output, is requested again after manual transfer by the above processing procedure, the SUS pended transfer operation can be restarted using the remaining data held in the data buffer register. 49. Operational description. Lin output operation I. REO. ACK- REO plus X. R. Phase transmission. Reset interrupt. SSTS 1011XXXX. REQ. ACK. Reset interrupt. Without specifying. Intercepts for. Yes. Fast track to SCSI. No *1. R. Dash. I reset interrupt I. By specifying I intercepts for 1________.j. Yes. 1. An inlerp 1 need not always be reset. The interrupt is reset automatically when the transfer command starts hardware transfer. 1-2. Nth interrupt is R86T. The data prologed in the NTMAI data buffer register before a change of phase is detected is lost. Figure 3 to 8. Service required interrupt processing procedure, output. 50. Fast track to SCSI. In input operation. Reop. Ac. Reopi. No. Reset interrupt. Without specifying. Intercepts for. No. R. Underscore dot one underscore. I reset interrupt I. By specifying. I intercepts for I underscore 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 dot j. Yes. Operational description. Asterisk 1. R. Dash dash. I reset interrupt I. Without specifying I. I intercepts for underscore 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 dot j. 1. An interrupt need not always be reset. The interrupt, servlow CL8 required, is reset automatically when the tran.18r command starts. Hardware transfer. Figure 3 to 9. Service required interrupt processing procedure, input. Timeout interrupt, bit 2. This interrupt indicates that the selected bus device has not responded within the predetermined supervisory time after the SBC initiates the 51. Operational description fast track to SCSI. SELECFION/reselection phase. C3 to 2 select command for details of the supervisory time setting procedure and the interrupt processing procedure. 7. SBC hardware error interrupt, bit 1. This interrupt indicates that the SBC has detected one of the following error cations in the SER register. TC parity error. Phase error. Short transfer period. Transfer offset error. See the SER register for details of these errors. When this interrupt occurs, the SBC does not stop the operation being executed, for any error cause. Since the normal operational sequence and end report cannot always be guaranteed in this case, the MPU program must be used for SBC control and bus phase control of SCSI. Figures 3 to 10 to 3 to 12 show examples of error control processing. 52. Fast track to SCSI operational description. Lin execution of ARBITRNON/SELECNON/rel election phase I. Example 1, Example 2. No. SBC. Hardware error. MPU. No. Abort message. Forced. Termination. Yes. 1 plus. SCTL.BLT7. Reset and DIS. Bus free. 1 normal SBC timeout supervision cannot always be guaranteed. Be sure to perform time supervision using the MPU program. Figure 3 to 10. Example of control processing for SBC detected error, 1. 53. Operational description fast track to SCSI. In execution of manual transfer. Yes. Yes. Figure 3 to 11. Example of control processing for SBC detected error, 2. 54. Fast track to SCSI. I in execution of hardware transfer I. Control reset. 1. SCTL.BLT6. Control reset. SC1L1 at 6. Yes. Asterisk 1. Execute by manual transfer. Operational description. Figure 3 to 12. Example of control processing for SBC detected error, 3. 55. Operational description fast track to SCSI. 8. Reset condition interrupt, bit 0. 56. This interrupt indicates that the reset condition has been detected in SCSI. Note that this interrupt cannot be masked. The reset condition persists for an unpredictable period of time. After making sure that bit 3, reset in, of the SSTS register becomes 0, the MPU must reset this interrupt condition. The reset condition interrupt may occur regardless of whether the SBC is connected with SCSI or not. When the SBC is connected with SCSI, occurrence of this interrupt causes the SBC to immediately deactivate a signal being sent to SCSI. Then the SBC proceeds to the bus-free phase. When the SBC is executing a command, occurrence of this interrupt causes the SBC to terminate its operation and reset its internal state. However, the following internal registers hold the control information unchanged: bold register, SCMO register, PCTL register, SCTL register, TMOO register, transfer byte counter. Until this interrupt is reset, the SBC internal reset state is maintained even if the reset condition is released in SCSI. Therefore, the SBC does not respond even when a new bus phase, example selection, is executed in SCSI. Fast track to SCSI operational description. PSNS/SDGC. Address. Number 5. PSNS register, phase sense register. OP765432210P. REO AKDN cell BSY message C/01/0P. 57. Operational description fast track to SCSI. When bit 5, diagnostic mode, of the SCFL register is set to 0, the PSNS register indicates the control signal status on SCSI, input signals to the SBC. Bit signal SBC input pins. 7 REO I. 6 AKCKI. 5 ATN. 4 cell. 3 BSY. 2 message MSGI. 1 C/DC/DID. 01/01101. A read from this register is allowed at any time regardless of the SBC condition. Bit 5. A1N, of this register indicates the A1N signal status on SCSI. When the SBC serves as a target, receipt of the A1N signal is indicated in this register but does not have any effect on other operations. The MPU program examines the A1N signal status at the following times in sequence and responds to the attention condition from SCSI. 1. When a selected interrupt occurs. 2. When the RESELECRION phase has been completed. 3. When the transfer command has been completed. 4. During execution of the transfer command. When the A1N signal is detected, the transfer pause command can halt the transfer operation for transition to the message out phase. 5. During execution of manual transfer. When bit 5, diagnostic mode, of the SCRL register is set to 1, the PSNS register indicates the status of control signals sent from the SBC to SCSI. In the pseudo SCSI operation using the SDGC register, the PSNS register can be used to check the SCSI control signal status. 58. Fast track to SCSI operational description. PSNS/SDGC. Address. Number 5. SDGC register, SCSI diagnostic control register. OP765432210P. W diagram SPHERE, diagram. REO AC enable BSY message C/OVA. Note, this bit is valid only for the MB89351/352 parts. The SDGC register is used to operate the SBC in the diagnostic mode, with bit 5 diagnose. Take mode of the SCTL register set to 1. To simulate the SCSI operation, the SDGC register Bits are used as having alternative SCSI control signal lines. In diagnostic mode, the SDGC register is used to check SBC internal operation. The diagnostic mode stops signal ing to the physical SCSI bus and nullifies input signals from the SCSI bus except the data bus signals. The SBC internal operation can be performed in the ordinary manner. 2. Check SBC internal operation. The MPU can manipulate the SDGC register bits to generate input signals to and from SCSI. 59. Operational description. The following bus phases can be simulated. Bus free. Arbitration, always win. Selection, for initiate operation. RESLECTION, for target operation. Fast track to SCSI. Information transfer, input data manipulation not allowed in an input operation. Bit 5 is used as an enable bit for issuing interrupt signal, INTR, when the SBC FIFO needs servicing. Bit 5 is set to enable a hardware interrupt, INTR, when the SBC FIFO needs to be serviced. During an SCSI input operation, an interrupt will occur when the SBC has data to be read. During an SCSI output operation, an interrupt will occur when the SBC needs a byte to be written into the FIFO. Bit 5 can be set/reset during normal and diagnostic mode of SBC operation. This bit is write only, it will be read back as 0 regardless of its setting. Initialization. The SBC is in the reset state when the input to RST pin is low, hardware reset, or bit 7. Reset and disable of the SCTL register is set to 1. SBC SCSI operation is disabled until the SBC reset state is released. The MPU program shall release the reset state after initializing the SBC internal registers. The following SBC internal registers remain unchanged even in the SBC reset state. BDID register, TMOD register, transfer byte counter, SCMD register, PCTL register, temp register, for sending. At the moment power is turned on, the contents of these internal registers are unpredictable even though hardware reset, RST input equals low, is executed. After RST input is released, the MPU program shall initialize the SBC as shown in figure 3-13. 60. Fast track to SCSI operational description. Power up. RST input. R. SBC state after RST input is released. Bold, XX. STTL. 80. Bus device 10 SCMD XX. BDID TMOD XX. PCTL XX. PSNS. XX. DREG. XX. Initialization of TCH.XX. Internal register, TCMXX. XOOSCMD-TCL. XX. TMOD ins.00. PCTL. SSTS-OX-TCH. TCM-SIR. 00. TCL temp, XX. Temp MBC. AUX. SDRG SDGC MXX. SCSI operation. Mode setting. 100XXXXX. SCTL. Release reset. State. 0 SCTL bit 7. End. Figure 3-13. SBC initialization, at power up. 61. Operational description fast track to SCSI. 62. Fast track to SCSI operational description. SSTS. Address. Number 6. SSTS register, SBC status, register. OP 765432110P. R. Connected SBCs for in SCSI TC equals ODREG status. P. Init I targ I busy progress reset in full I empty. Register functions. The SSTS register indicates the SBC internal status, which can be read out at any time. Bit 7 and 6, connected, init, targ. These bits indicate the connecting status between the SBC and SCSI. 63. Operational description fast track to SCSI. Bit 7, init bit 6, targ state. 00 not connected with SCSI. 10 SBC serves as an initiator. During execution of the selection phase and after its completion. After a reselect interrupt. 01 SBC serves as a target. During execution of the RESELECFION phase and at its completion. After a selected interrupt. 11 undefined. Bit 5, SBC busy. Bit 5 indicates that a command is being executed or is waiting to be executed. Bit 4, transfer in progress. Bit 4 indicates that a hardware transfer operation is being executed or the SCSI is requesting an information transfer phase. Bit 3, SCSI reset in. Bit 3 indicates that the SCSI RST signal is active. Bit 2, TC equals 0, transfer counter 0. Bit 2 indicates that the transfer byte counter, TCH, TCM, TCL, has reached O. Bits 1 and 0, DREG status, full, empty. These bits indicate the status of the internal data buffer register. When executing a hardware transfer operation in program transfer mode, determine the data buffer register AC. SES timing by using these bit values. 64. Fast track to SCSI operational description. Bit 1, full bit 0, empty data buffer real stir status. 00 holds 1 to 7 bytes of data. 01 empty. 10 holds 8 bytes of data, leaving _ no free space. 11 undefined. SBC status. SBC status is represented by combinations of status bit 7 to 4 of this register. Table 3 to 4 lists the combination of these bits and SBC status. Table 3 to 4. SBC operating status indications. SSTS register. Bit 7, bits, BLT 5, bit 4. SBC operating status. Init targ SBCs for in. Busy progress. 0000. SBC is not connected with SCSI. SPEAK does not hold a command. Waiting to be executed. SBC is not connected with SCSI. But SBC holds the select COM 0010 MAND, which is waiting for bus free phase. Or it is executing. Arbitration phase. 0100. SBC serves as a target. No operation is being executed in SCSI. Manual transfer is not being executed. 0110 SBC is executing residential election phase on SCSI. 0111. SBC serves as a target. Hardware transfer operation. Transfer command is being executed. 1000. SBC serves as an initiator. No operation is being executed in SCSI. Manual transfer is not being executed. SBC serves as an initiator. Although SBC has received a 1001 RIO signal from SCSI, it is not ready to start transfer operation. Because no transfer command has been issued or transfer phase does not match. 1010 SBC is executing the selection phase on SCSI. 1011 SBC serves as an initiator. Hardware transfer operation. Transfer command is being executed. 65. Operational description fast track to SCSI. 66. Fast track to SCSI operational description. SIR. Address. Number 7. SIR register, SBC error status register. OP765432110P. R data error 00 DC phase shorts for P. SCSI. I. SBC. SFR parity errors for offset. Out error period error. Note, asterisk MB87030/31/33. MB89351/52. Note, MB89351/352. This bit can only be reset, including the INTR signal, by satisfying the data request. By writing or reading to the SBC FIFO, DREG. 67. Operational description fast track to SCSI. Register functions. The SIR register provides details of an error detected in the SBC. An SBC hardware ER. ROR interrupt occurs if an error is indicated at any of bits 3 to a. Bits 7 and 6, data error. These bits indicate that a parity error has been detected in the transferred data during transfer phase execution in SCSI. Table 3 to 5 lists the data error indication bit patterns and the relevant SBC operations. When changing the transfer phase in SCSI, these error indication bits must be reset. Table 3 to 5. Data error indication bit patterns in transfer phase. Bit 7 bit 6. Data error. SBC operations. SCSI SBC. 01 No parity error was detected in the transferred data. 01 During execution of an output operation in hardware transfer mode, a parity error was detected in the data to be sent to SCSI. The parity is checked regardless of the value of bit 3, parity enable, of the SCTL reg. ISTER. The erroneous data, parity bit value, is corrected and then sent to SCSI. 11 A parity error was detected in the data received from SCSI during an input operation. The parity is checked only when bit 3, parity enable, of the SCLL register is set to 1. After an error is detected, the parity bit is corrected. The SBC serving as an initiator detects this error during hardware transfer execution. It generates an ADN signal to SCSI. See Figure 3-2. In this case, the MPU program must reset this error condition before the ADN signal is reset. If the SBC serving as a target detects this error during hardware transfer execution, it follows the specify cation at bit 0, termination mode, of the SCMD register. See SCMD reg. ISTER for details. 10 Undefined. Bit 5, SFR out. When bit 5 of SOGC is 1, 1, in program transfer mode, interrupt signal, INTR, is output for a data request. This bit is a flag indicating the data request. 68. Fast track to SCSI operational description. In the MPU, this bit is referenced in the interrupt routine to perform data transfer according to the data requests. Bit 3, TC parity error. Bit 3 indicates that a parity error occurred while the transfer byte counter, TCH, TCM, TCL, was being decremented. Bit 2, phase error. When the SBC serves as an initiator, the transfer phase has been changed in SCSI dir. Ing hardware transfer mode operation, service required interrupt occurs. In this case, bit 2 indicates that the new phase is a synchronous transfer mode data in phase. The REQ signal has been received 2 or more times before the MPU program completed interrupt processing and issued the transfer command for the new phase. In this case, the SBC cannot receive data and return the X signal normally. Bit 1, short transfer period. Bit 1 indicates that the REQ/X signal, input signal to REQI/ACKI pin, has a cycle X, exceeding the specified input range, see figure 3 to 14. If this error occurs, the transfer sequence executed by the SBC is not guaranteed. Min. TCLF. If REO or X signal, REOI or ACKI pin. Min. TCLF X3. TCLF, a cycle of the clock signal supplied to SBC. Figure 3 to 14. Specified input cycle of REQ/X signal. 69. Operational description fast track to SCSI. Bit 0, transfer offset error. Bit 0 indicates that one of the following errors has been detected during synchronous transfer mode. The offset value referred to below denotes the REQI maximum offset value specified in the TMOD register. When SBC serves as a target, the number of X signals received exceeds that of REQ signals transmitted. The number of REQ signals transmitted exceeds the offset value, SBC malfunction. When SBC serves as an initiator, the number of REQ signals received exceeds the offset value. The number of X signals transmitted exceeds that of REQ signals received, SBC malfunction. If this error occurs, the transfer sequence executed by the SBC is not guaranteed. Error reset. To reset an error indication in the SER register, do one of the following. Generate SCSI reset condition, 11.0 SCMD. Reset and disable, bit 7 of SCTL register. Control reset, bit 6 of SCTL register. Interrupt, SBC hardware error, reset, X02 ints. 70. Bit 7 and 6, data error, of this register do not cause an interrupt, but can be reset by. This means fast track to SCSI operational description. PCTL. Address. Number 8. PCTL register, phase control register. OP765432210P. R bus free 0 message C/0110P. /interrupt out. W enable. Bit 7, bus free interrupt enable. With bit 7 set to I, detection of the bus free phase on the SCSI causes a disconnected interrupt to occur. To prevent an undesired interrupt from occurring, be sure to set bit 7 to O in the following cases. When issuing the select command. When resetting a disconnected interrupt. 70. Operational description fast track to SCSI. Bit 2, message out. Bit 1, CIO out. Bit 0, 1/0 out. When the SBC serves as a target, specify the information transfer phase to be executed. In SCSI, these bit values are sent to SCSI as message, C/D and IO signals. When the SBC acts as an initiator, specify the pattern indicating the transfer phase to be executed. Before executing the transfer operation, the specified transfer phase pattern is compared with the bus phase actually requested by the target. If they match, the transfer operation is initiated. Table 3 to 6 shows how to set a transfer command. Also, use bit 0, IOOut, to specify select or reselect operation when the select command is issued to the SBC. See select command for details. Table 3 to 6. Transfer phase setting. Bit 2 bit 1 BLTO. SCSI transfer phase. MSG out C/D out 110 out. 000 data out. 001 data in. 010 command. 011 status. 100 unused. 101 unused. 110 message out. 111 message in. 72. Fast track to SCSI operational description. MBC. Address. Number 9. MBC register, modified byte control register. OP 765432210P. R0. Bit 3. I. MJC1. I. 20P. The MBC register controls the data count during transfer between the SBC internal data buffer register and the MPU, program transfer mode, or external buffer memory, DMA mode. When data are written into the TCL register, its 4 low-order bits are set as an initial value for the MBC register. In an output operation, data are prefetched into the SBC internal data buffer register. Each time 1 byte is prefetched, the MBC register is decreased by 1. 73. Operational description fast track to SCSI. Data prefetch stops when the transfer byte counter is decreased below 15 and the MBC register reaches 0. In an input operation, data received from SCSI is stored in the internal data buffer register. Each time data is sent to the MPU or external buffer memory, the MBC register is decreased. The difference between the transfer byte counter and the MBC register corresponds to the byte count of data remaining in the internal data buffer register. While the SBC is executing a DMA mode transfer operation, this register must not be read. 74. Fast track to SCSI operational description. DREG. Address. IDA. DREG data buffer register. OP 765432210P. R/. Internal data register, 8 bytes FIFO. W bit 7. I. 6. I. 5. I. 4. I. 3. I. 2. I. 1. I. 0P. The SPEC internal data buffer register consists of 8 bytes and operates on the FIFO principle. When executing the transfer command in program transfer mode, MPU trans FERS data using this register. Figure 3 to 15 shows the DREG access procedure to be taken in program transfer mode. Therefore, never repeat accessing more than the number of times required. 75. Operational description. Yes. No. Issue transfer command. In program transfer mode. Yes. No. SSTS equals 45, 16 or 85, 16. Or ints, 4 equals L. Fast track to SCSI. No. Figure 3 to 15. DREG access procedure in program transfer mode. 76. Fast track to SCSI operational description. Temp. Address. Lob. Temp register, temporary register. OP 70P. R. Bit 70P. W. Bit 70P. The temp register is used for controlling the SCSI data bus except when hardware transfer is executed. It consists of 2 bytes, each of which is dedicated exclusively to receiving/sending data. Data receiving element, read only. A. When a SELECFION/RESELECFION phase is detected in SCSI, the contents on the SCSI data bus are saved in the temp register. If a selected/reselect interrupt occurs, a bus device can be identified by the temp register. N. Operational description fast track to SCSI. Contents. Read this register before resetting the selection or reselection. Interrupt status bit. B. For a manual transfer input operation, the contents on the SCSI data bus are saved in the timing sequence shown in figure 3-16. In SBC serving. As a target. In SBC serving. As an initiator. Data bus. Rio. AC. Sampling period. Temp. Figure 3-16. Data bus save in manual transfer input operation. 2. Data sending element, write only. 78. A. Before issuing the select command, set the contents to be sent to the SCSI data bus in the SELECFION/RESELECFION phase. B. For a manual transfer output operation, set the data to be sent out. Fast track to SCSI operational description. TCH, TCM, TCL. Address. IOC, OD, DE. TCH, TCM, TCL, transfer byte counter, high, middle, and low. Op70p. R/W. Bit 2316p. R/W. Bit 158p. R/W. Bit 7p0. The transfer byte counter consists of 3 bytes and functions as a down counter. In exe execution of a hardware transfer operation, it is decreased by 1 each time 1 byte of data is transferred over SCSI. It indicates the remaining byte count of data to be transferred. In the select command execution, this counter operates as a response waiting time superv. Sorry timer and sequence control counter. See select command and transfer command for transfer byte counter initialization. While the transfer byte counter is operating, do not carry out a read/write. Note, do not read/write these registers while a transfer operation is occurring. If necessary, use the light equals 0 bit in the SSTS register to determine when the transfer count has reached 0. 79. Operational description fast track to SCSI. 80. Fast track to SCSI operational description. EXBF. Address. Hashtag of EXBF, external buffer register MB87030, 31, 33 only. Op76543210p. R/I. External J of III. P. W. Bit 7. I. 65210. This register's address is reserved for access from the MPU data bus, D7 to DO, DP, to the DMA data bus, HDB7 to Hobo, HDBP. It does not exist as an internal register in SBC but provides a pathway between buses. As shown in figure 3-17, the MPU program can execute a write/read to/ from the external buffer memory by using this virtual regis. Ter. 81. Operational description fast track to SCSI. SBC. MPU V 07-00 op A3AO ROMM WT WRN Access HIN Timing Control Circuit 110 XTML Hop 7 0 HOBP buffer Memory Figure 3 to 17 Access from MPU to external buffer memory. Devices without a separate DMA data bus do not have this register, MB89351/2. This register is normally used by the MPU to load/unload an external memory buffer. Before/after, write to SCSI/read from SCSI, a DMA transfer. 82. Chapter 4. Examples of external circuit connections. Figure 4:1 shows the external circuit blocks that can be connected with this LSI circuit. The external circuit configuration depends on the application environment, intended purpose, and required performance. Application examples for this circuit are given below. 83. Examples of external circuit connections fast track to SCSI. RNR SOBI 7-0 PSBC /RSI /L MPU 8085 J SOB 07-0 P A3 8086 8088 A2 SOB 7-0 PA1 AO Cell CS Cello Ruru BSYI WTWTG BSYO DV/RV 07-0 P REOI- REOOINTR ACKI ACKO MSGI MSGO ARIA CIOI Orispoma CIOOHFN Control 1/01 1/00I ATNI ATNOV Hop 7-0 P buffer Memory RSTI ATNO Targ Init IVU IVSS Figure 4:1 Examples of external circuit connections. 84. Fast track to SCSI examples of external circuit connections. SCSI driver/receiver circuits. Single-ended type. Table 4:1 lists the major components of the SCSI driver/receiver circuit. Figure 4:2 shows an example of a connection of the SBC and the SCSI single-ended type. Driver/receiver circuits. Table 4:1 Major components of single-ended type SCSI driver/receiver circuit. Example. Component part No. Manufacturer characteristics Qt. Rio/ACK-signal MB412 Fujitsu 3-state buffer circuit, 1. Driver 2 circuits low DLP14. Rio/ACK-signal MB413 Fujitsu 4 circuits low DLP16 1. Receiver resistor, 390W plus 2% 1/4 W1. Resistor, 200W, /0 W1. Capacitor, 0.1 MFJ50V ceramic 1. Other signal MB463 Fujitsu, open collector Butler 4. Driver circuit, 4 circuits/DIP14. Other signal 74 LS240 Fujitsu, Schmidt trigger inverter, 2. Receiver TI8 circuits low DLP20. Terminator, +518. Required only when 220 WELE. The driver/receiver MENS is located at 330 W. Either end of SCSI. Notes: the MB412 is compatible with the SN7519. The MB413 is compatible with the AM26LS32. The MB463 is compatible with the SN7438. 85. Examples of external circuit connections fast track to SCSI. SCSI. SDBI 720, P. DB7. 4. SBC SDBI 7 LS240. SBIP/ P. LS240. 1 IBP. IT. SDB0720, PT. SDB07DB7 LTN. 463T. 463. SBOP/I. 463. 463. 1 IBP. Cell. BSYI. 4. 1101 LS240. ATNI. RSTII, P. Cello. 463. BSYO. 1100. ATNO. 463/ BSTO/ PowerReady *1. Figure 422. Example of single-ended type SCSI driver/receiver CLRQH. 86. Fast track to SCSI examples of external circuit connections. _/. SCSI _/ dash. MB413. SBCA. Dash plus. Real L. ACKIR1. MSGI. Slash. ACR. Slash C slash OI. RP. L. L. TR. H. R1, 390W plus 2. ILS 240%. L. R2, 200W plus 2. Junior, percent. C1, 0.1 MF. R. MB412. R. REOOR. LTN. ACKOHJ. R. R. MSGO. R. C/OO/ W. R. Targ. Init. I. ACKO. MSGO. 1463. CYOO. 1463100. / PowerAO. *1, recommended to protect against noise generated at power on/off. Figure 422. Example of single-ended type SCSI driver/receiver circuit, continued. 87. Examples of external circuit connections fast track to SCSI. Differential type. Table 422 lists the major components of the SCSI driver/receiver. Figure 423 shows a example of the connection of the SBC and the SCSI differential type driver/receiver circuit. Table 422. Major components of differential type SCSI driver/receiver circuit. Example. Component part No. Manufacturer characteristics Qt. Driver/receiver SN75176Ti, differential transceiver 18. Common to all 1DV plus 1 RV/DIP8. Signals. Terminator. +5. 18. Required only when 33QQ. ELE. The driver/receiver, positive signal. MENT. Is located at either end of SCSI, 15QQ. negative signal, underscore. 33QQ. J. 88. Fast track to SCSI examples of external circuit connections. Backslash. SCSI. SDB07-0, P. SBC. D. DB7, plus. SDB07. NI equals, 71-1. D:, R. I. STBOP. I. SDBI7I. I. 11. DBP1 plus. STBIPL.FDBPI. SDBE7. I. JLI. I. II. SDBI70, P. STBEEP. 1J. SDBE7-0, P. I. Cell, plus. Cell. HC:"L. BSYI. 1/01. ATNIT. I. RSTI. I. IRSTIT.L. -.IRSB:1. Cello LF. BSYO. JLI. 1/00. ANTOT. RSTO. I.L. Dash. Figure 4-3. Example of differential type SCSI driver/receiver circuit. 89. Examples of external circuit connections fast track to SCSI. Backslash. SCS. SBC. REO, plus. REOIJ. H. ACKI11. REOO cent. ACKO. 2. AC, plus. I. LF. H. Dash. 1/R. MSGI. I. CIOI. Message 1 plus. HL.FH. MSGO. CIOO. C/O, plus. I. JJ. I. JR. Init LTN. Targ 1.7. Figure 4-3. Example of differential type SCSI driver/receiver circuit, continued. 90. Fast track to SCSI examples of external circuit connections. External data buffer. To provide a buffer area for high-speed data transfer or a temporary storage for data to be transferred, the external data buffer memory can be connected to the SBC as shown in Figure 4-1. In this case, a buffer control circuit is required to control the timing of data transfer between the SBC and external buffer memory. To execute the transfer phase on SCSI, specify DMA transfer mode for the SBC. The SBC accesses the external buffer memory with the timing sequences shown in figures 4-4 and 4-5. Data is transferred via the DMA data bus lines HDB7 to HDBO, HDBP. The transfer direction must be specified externally using the HIN signal. When requesting access to the external buffer memory, the SBC makes the DREQ signal active. In an input operation, the DREQ signal is sent out when the SBC internal data buffer register holds data received from SCSI. In an output operation, the DREQ signal is sent out when data corresponding to the byte count SBC FID in the transfer byte counter is not all prefetched, and when the internal data buffer register has free byte locations available. The external buffer control circuit must return the DRISP signal in response to the DREQ signal on completion of transferring each byte. DRISP is a pulse signal whose trailing edge is used to indicate the end of transfer. The DREQ signal is held active as long as the above conditions exist in the SBC. This signal is not a transfer request signal for each byte. The access interface signals, DREQ, DRISP, HIN, HDB7 to HDBO, HDBP, to the external memory are asynchronous with an SBC. Clock signal supplied to the AX pin. 91. Examples of external circuit connections fast track to SCSI. DREQ/0/0/0/0/0 DRISP /0/0/0/0 HIN 0 Hop 7 to 0 P Unpre OATA1 OATA2 Unpre Data 3 Unpre Dictable Notes 1. HIN signal puts the DMA data bus, HDB7 to 0, P, in an output mode. However, the value on the DMA data bus is unpredictable until data is loaded into the SBC internal data buffer register from SCSI. 2. After receiving data from SCSI, the SBC issues the DREQ signal, transfer request, to the external buffer memory. At this time, valid data is placed on the DMA data bus. 3. Data on the DMA data bus is held until the trailing edge of the DRISP signal. 4. After the DRISP signal is received, valid data is unloaded from the SBC internal data buffer register. Then, the DREQ signal becomes inactive to stop transfer with the external buffer memory until the next data becomes available. Figure 4-4. Transfer with external data buffer, input operation. 92. Fast track to SCSI examples of external circuit connections. DREQ /0 at /0 DRISP HIN-I HDB7 to 0 P. Notes 1. As long as the HIN signal is low, the DMA data bus, HDB7 to 0 P, is in an input mode. 2. A transfer request, DREQ, signal is issued when the SBC internal data buffer register has free byte locations available for prefetching data. 3. The external buffer control circuit puts data onto the DMA data bus and also sends the DRISP signal. In response, on the trailing edge of the DRISP signal, the SBC loads data from the DMA bus into the internal data buffer register. 4. When no free location is available in the SBC internal data buffer register, the DREQ signal becomes inactive. Then, transfer from the external buffer memory is stopped until the next data prefetch becomes available. Figure 4-5. Transfer to external data buffer, output operation. 93. Examples of external circuit connections fast track to SCSI. 94. MB87030 MB87031 SCSI Protocol Controller, SBC. General description. The MB87030 and MB87031 SCSI Protocol Controller, SBC, are CMOS LSI circuits. Specifically designed to control a small computer system's interface, SCSI. In terms of features, functional operation, and electrical specifications, the two devices are identical. However, the MB87030 is housed in an 88-pin ceramic pin grid array package, whereas the MB87031 is designed for surface mounting and is housed in a 10-pin plastic flat package. To achieve optimum performance and interface flexibility, the SBC contains an 8-byte first-in, first-out, FIFO, data buffer register and a 24-bit transfer byte counter. Independent data. Buses for the CPU and the DMA controller plus separate input/output pins for all control. Signals greatly enhances performance. Data transfers can be executed in either the asynchronous or synchronous mode with a maximum offset of 8 bytes. SCSI compatibility. Supports all of SCSI specification. ANSI X 3.131/1986. Serves as either initiator or tar. Get. Both synchronous and asynchronous. Operation. Software compatible with MB87033. Data buses. Independent buses for CPU and DMA. Transfer. Transfer modes. Asynchronous data transfers with programmable offset of up to 8 bytes. Synchronous data transfers with programmable offset of up to 8 bytes. Data transfer speed. Up to a maximum of 4 megabytes per second, sustained. Operating modes. DMA transfer. Manual transfer. Program transfer. Diagnostic. Interface connections. Single-ended or differential options. TTL compatible 1/0. Clock requirements. 8 MHz clock with 33% to 66% duty cycle. Technology/power requirements. Silicon gate CMOS. Single plus 5V power supply. Available packaging. 88-pin ceramic repeated quad inline. 1 2-pin plastic flat package. 95. MB870303131 fast track to SCSI. Absolute maximum ratings 1. Values. Rating symbol min. Max. Unit. Supply voltage VU VSS 2.057.0 V. Input voltage 6 VSS 2.05 VU plus 0.05 V. Output voltage 2 VO VSS 2.05 VU plus 0.05 V. Storage temperature, ceramic, TSTG-65 plus 150 degrees C. Temperature under bias, ceramic, TLS-40 plus 125 degrees C. Output current 3 lay-40 plus 70 mA. Notes, 1. Permanent device damage may occur if the above absolute maximum ratings are exceeded. Functional operation should be restricted to the conditions as detailed in the operational sections of this datasheet. Exposure to absolute maximum rating conditions for extended periods may affect device reliability. 2 VSS equals OV. 3 Not more than one output may be shorted at a time for a maximum duration of 1 second. Recommended operating conditions. Parameter designator. Values. Unit. Min. Tip. Max. Supply voltage VU 4.755.05.25 V. Input high voltage VIH 2.2 V. Input low voltage V1L 0.8 V. Operating temperature Ta 070 degrees Celsius. 96. Fast track to SCSI. MB87030/87031 block. Diagram. 07-00 =::: DP. ATNI. MSGI. C/did. ATNO. Misgoy :::: C/do. 1101. 1100. RSTI. RSTO. SDBI 7. 2R equals G : ELSTBO. R: S : equals equals STBIP. M dash plus, RST dash plus, address, decode, and MPU, interface, interrupt, N, status, MB870303131, 97, MB870303131, pin assignments, PGA88CA01, pin 110 designator pin, no, 1 IHIM 23, 2 110 hobo 24, 3 110 hoboi 25, 4 110 hob 0226, 5 1/0 hob 0327, 6 1/0 hob 0428, 7 1/0 hob 0529, 8 110 hobos 30, 9 110 hob 0731, 10 110 hobop 32, 11 0 init 33, 12 0 targ 34, 13 0 1/00 35, 14 0 c/do 36, 15 0 cello 37, 16 0 msgo 38, 17 0 reo 39, 18 0 rsto 40, 19 0 acko 41, 20 0 bsyo 42, 21 0 atno 43, 22 0 sobeep 44, 98, 0 0 0 0 0 0 0 0 0 0 0 0, 34 33 32 31 30 29 28 27 26 25 24 23, 0 0 0 0 0 0 0 0 0 0 0 0, 35 72 71 70 69 68 67 66 65 64 63 22, 0 0 0 0 0 0, 36 73 86 85 62 21, ch 0 74 degree 61 degree 20, 0 0 0 0, 38 75 60 19, S907687, top view, degree 84 degree 59 degree 18. Kun 088 degree 83 degree 58 degree 17. 0000. 4178 index pin 5716. Q2079/056015. Q3080 CR degree 8P82 degree 55014. 000000000000. 44 45 46 47 48 49 50 51 52 53 54 13. 000000000000. 1 2 3 4 5 6 7 8 9 10 11 12. VO designator pin VO designator. No. 0 SOBOP 45 1 AI. 0 SOB 746 IA2. ISOBI 747 IA3. 0 SOB 648 110 D4. 0 SOB 0549 1/005. ISOBI 550 VOOS. 0 SOB 0451 VO07. 0 SOB 352 IOOP. ISOBI 353 0 INTR. 0 SOB 0254 IVOL. 0 SOB 255 IC/OL. ISOBI 56 ICEL. 0 SOBL 57 IMSGI. 0 S080058 IREAL. ICS 59 IRSTI. ICEK 60 IACKI. iFlow 61 IBSYI. IMM 62 IANTI. IORISP 63 ISOBIP. IODO 64 0 SOB 07. VO 0165 0 SOBOS. IAO 66 ISOBI 6. Fast track to SCSI. Pin IO Decil NATO. No. 670 SOB 5. 660 SOB 4. 69 ISOBI 4. 70 SOB 03. 71 ISOBI 2. 72 SOBL. 73 SOBIA. 74 ISOBIA. 75 IRST. 76 ARIA. 77 IWT. 78 IWTG. 79 IOD2. 80 VO03. 81 Power Supply. 82 Power Supply. 83 Power Supply. 64 Power Supply. 85 Power Supply. 86 Power Supply. 87 Power Supply. 88 Power Supply. Fast track to SCSI M887030131. Pin assignments, continued. FPT 100 PM01. OO. Pin 110 Designator VO Designator Pin. 110 Designator VO Designator. No. No. 1 IDRIS VOD 2510 TARG 760 SDBE 5. 20 DREQZ 7 VO 0352 INIT N0 SOB 05. 3 VU 2 B VU 53 VU 78 VU. 4 VSS 29 VSS 54 VSS 79 VSS. 5 HIN 3110 0455 ACKI 80 NIC. 6 110 Hobo 31 VO 0556 ACKO 81 SOBI 4. 7 110 HOBL 32 110 0657 N/C 820 SOB 4. 8 110 HOB 233 110 0758 N/C 830 SOB 04. 9 110 HOB 334 VO OP 59 BSYI 84 SOBI 3. 10 VO HOB 435 AO 60 BSYO 85 SOB 3. 11 110 HOBS 36 AL 61 IATN I 86 SOB 03. 12 VO HOB 637 A2 82 ATN 087 SDBI 2. 13 110 HDB 738 A363 IRSTI 66 SDBE 2. 14 110 HOBP 39 RST 64 RSTO 89 SOB 02. 15 VSS 40 VSS 65 VSS 90 VSS. 16 CLJ 41 I Real 66 ISOBIP 91 ISOBL. 17 CS 42 REOO 67 SOBIP 92 SOBL. 16 WT 43 IVOL 68 SOBOP 93 SOBL. 19 WTG 44 1169 ISOBI 794 ISOBIA. 20 Flow 45 CLOI 70 SOB 795 SOBIA. 21 IRU 46 CLOO 71 SOB 0786 SOBA. 22 INTR 47 Cell 72 SOBI 697 N/C. 23 NIC 46 Cello 73 SOB 698 N/C. 24 110 DO 49 IMUL 74 SOB 0699 NIC. 25 VO 0150 MO007 SOBI 5 100 NLC. 99. MB870303131 Fast Track to SCSI. Pin descriptions. Pin No. Designator MB87030 MB87031 function. Indicates direction of transmission along data bus lines Hobo Hop 7 and HOBP in the OMA transfer mode. To be executed, direction of transmission must be properly 15HN. coordinated with internal operation of the SBC. When HIN is low, the data bus lines are placed in the high impedance state, input mode. When HIN is high, all bus lines are switched to the output mode. 3-state bidirectional data bus for transferring data to or from the external buffer memory. In the OMA mode. As shown below, the direction of data transmission depends on the 2 to 9 6 to 13 hobo hop 7 HIN input signal. 1013 HOBP HIN HOBN operation. L input mode output. H output mode input. These two signals indicate operating state of SBC, they are also available as control signals for the SCSI driver receiver circuits. 1151 init initiator target status. 1251 targ LL SBC is not connected to SCSI. LH SBC is executing reselection phase or is operating as a target. HL SBC is executing selection phase or is operating as an initiator. 1344 1100. Used to output SCSI control signals. REOO, MSGO, CIDO, and 1/00 are active high only. 1446 CIOO. When the SBC serves as a target. ACKO and ATNO are active high only when the SBC. 1548 CELO. Services as an initiator. 1650 MSGO. 1742 REOO. 1864 RSTO. 1956 ACKO. 2060 BSYO. 2162 ATNO. 2267 SOBEEP drive enable signals, corresponding to respective bit positions, when a 3-state buffer is 2470 SOB 7. Used for the SCSI data bus. SOB 7S0 BEO and SOBEEP correspond to 2673 SOB 6. SOB 07S0 BOO and SOBOP, respectively. Relationships with respect to the SCSI bus. 6776 SOB 5. Are shown below. 6882 SOB 4. SCSI bus status SOBO on SOBN. 3085 SOB 3. 10 feet 1 inch JD1 10 feet 1 inch JDI. 3388 SOB 2 bus free. LLLL. 3592 SOBL arbitration H. LHL. 7395 SOBIO selection IJLE selection 0 feet 2 inches 0 feet 2 inches HH. Information transfer. SBC- plus SCSI 0 feet 2 inches 0 feet 2 inches HH. SCSI- plus SBC LLLL. Knowles, 1. 10 indicates bit positions correspond in 9 to the SCSI bus. Device M indicates the other bit position. 20 indicates transfer of valid information. 100. Fast track to SCSI MB870303131. Pin descriptions, continued. Pin no. MB87031 MB87031 designator function. 2569 SOBI7 inputs for the SCSI data bus. Most significant bit, MSB, is SOBI7, least. 6672 SOBI6 significant bit, LSB, is SOBIO. SOBIP is an odd parity bit, parity check. 2875 SOBI5 INGLOR the SCSI data bus is programmable. 6981 SOBI4. 3184 SOBI3. 7187 SOBI2. 3491 SOBI1. 7494 SOBIO. 6366 SOBIP. 6471 SOB07 outputs for the SCSI data bus. MSB is SOB07, SOBOP. SOBOP is an 6574 SOB06 odd parity bit. 2777 SOB 05. 2. The bus driver is an open collector device, these signals should be 2983 SOB 04. 7085 SOB 03. Applied directly to the driver circuit. 2. The new bus driver is a 3-state. 3289 SOB 02. Device, these signals are used as data and SOB 07 SOBO and 7293 SOB 01. SOBOP are used as drive enable signals. 3696 SOBO. 2368 SOBOP. 3717 CS. Selection enable signal for accessing an intimal WICTR in SBC. When CSys active, input/output signals RD, RU, WR, OP, AOA3, and DO D7 are active. 3816M. Input clock lore controlling internal operation and data transfer speed 01. SBC. Input strobes used for reading out contents 01 internal register, strobes. Are effective only when CS is active low. 3920 RD when RU is active low, the contents 01 and internal register selected. 4021 RU by address inputs AOA3 are placed on data bus lines 00-07 and up. For a data transfer cycle in the program transfer mode, the trailing edge 010 is used as a timing signal to indicate the end 01 data read. 41.1 ORISP during a data transfer cycle in the DMA mode, DRISP is a response signal to the data transfer request signal DREQ. The DRISP pin must be refreshed with an applied pulse. After each byte of data is transferred to output operations. The falling edge of DRISP is used for sampling data on HDBO, HDB7 and HDBP bus lines. In input operations, the SBC holds data to be transferred onto HDBO hop 7 and HIDP until the falling edge of DRISP occurs. 101. MB87030131 Fast Track to SCSI. Pin descriptions, continued. Pin no. MB87031 MB87031 Designator function. 513307 used for writing or reading data into or from an internal. 503206 register in SBC, these bus lanes are 3-state and bidirect. 493105 channel. The MSB is 07, the LSB is 0. OP is an odd parity. 483004 bit. 802703. When the CS and RIM inputs are ACVE low, contents of the internal. 792602. 432501. Register are output to the data bus, read operation. In operations other. 4224 do. Then read, these bus lines are kept in a HGH impedance state. 5234 up. 44 to 47 35 to 38 80 to 83 address input signals for selecting an internal register in the SBC. The MSB is A3, the LSB is A0. When CS is active low, read-write is enabled and an inter NAL register is selected by these address inputs via data bus lines 00-07 and up. 5322 INTR requests an interrupt to indicate completion of an SBC. Internal operation or the occurrence of an error. Interrupt masking is allowed except for an interrupt caused by the RSTI input, reset condition of SCSI. When an interrupt is permitted, the INTR signal remains active until the interrupt is cleared. 5627 cell used for receiving SCSI control signals, outputs of the 6159 BSYI SCSI receiver can be directly connected. Waveform DIS. 5841 REOI torsion or any other disturbance should not occur in the 6055 ACKI REOI and ACKI signals which are used as timing control. 5749 MSGI signals for sequencing data transfers. 5545 CLDI. 5443 1101. 6261 ATNI. 5963 RSTI. 102. Fast track to SCSI MB870303131. Pin descriptions, continued. Pin no. MB87031 MB87031 designator function. 76.2 DREQ when executing a data transfer cycle in the DMA mode. DREO is used to indicate a request for data transfer between the SBC and external buffer memory. In the DMA mode, routing of data is as shown below. Output operations. From external buffer memory to HDBO HDB7/HDBBP2. SBC internal data buffer register, 8 bytes, to SBO SDB07/SBOP to SCSI. Input operations. From SCSI to SDBI9 SDBI7/SBIP to SBC internal data buffer register, 8 bytes, to HDBO HDB7/DHDBP to external buffer memory. In an output operation, DREO becomes active to request a data transfer from the external buffer memory when the SBC internal data buffer register has free space available. In an input operation, DREO becomes active to request a data transfer to the external buffer memory when the SBC internal buffer memory contains valid data. 7718 WT input strobe used for writing data into an SBC internal register. This signal is asserted only when CS is active low. On the trailing edge of WT, data placed on data bus lines. Do D7/DP is loaded into the internal register selected by address inputs AOA3, except when all address lines are high, AOA3 equals H. For a data transfer cycle in the program transfer mode, the trailing edge of WT is used as a timing signal to indicate a data ready state. 7819 WTG when WTG is active low, data appearing on data bus lines. Do D7/DP is output to HDBO HDB7/HDBP if the following input conditions are satisfied. CS equals L. AOA3 equals H. HIN equals H. 81, 84, 4, 15, 29 VSS power supply ground. 85, 88, 40, 54, 65. 79, 90. 82.833, 28 VU plus 5 V power supply. 86, 87, 53, 78. 23, 57, 58, not used. 80, 97, 98. 99, 100. 103. MB870303131 fast track to SCSI. Addressing of internal registers. Both the MB87030 and the MB87031 contain 16-byte wide registers that are externally accessible. These registers are used to control internal operations of the SBC and also to indicate processing/result status. A unique address, identified by address bits A3AO, is assigned to each of the 16 registers. These addresses are defined in Table 1. Note, the phase sense, PSNS, and SBC diagnostic, SDGC, registers have the same hexadecimal address. However, depending upon whether a read or write command is executed, the registers provide two separate functions. Table 1. Internal register addressing. Chip select, CS. Address bits. Register mnemonic operation A3 A2 A1 AD. R. Bus device ID BDID 00000. W. R. SBC control SCTL 00001. W. R. Command SCMD 00010. W. R. Transfer mode TMOD 00011. W. Interrupt sense R. Ints 00100. Reset interrupt W. Phase sense PSNSR 00101. SBC diagnostic control SDGCW. SBC status SSTSR 00110. W. SBC error status error 00111. W. R. Phase control PCTL 01000. W. Modified byte counter MBCR 01001. W. R. Data register DREG 01010. W. R. Temporary register temp 01011. W. 104. Fast track to SCSI MB87030J31. Table 1. Internal register addressing, continued. Address bits. Register mnemonic operation chip select, CS, A3 A2 A1 AO. R. Transfer counter high TCH 01100. W. R. Transfer counter middle TCM 01101. W. R. Transfer counter low TCL 01110. W. R. External buffer EXBF 01111. W. 105. MB870303131 fast track to SCSI. Bit assignments. Table 21 lists the bit assignments for the 17 InteMaJ registers defined in Table 1. During read-write access open. Internal register, the following rules are invoked. Internal registers include only those registers identified in Table 1. A write command to a read-only register is ignored. For write operations, all bit positions with a dash, blank, designator can be written as a 0 or as a 1. All bit positions with an assigned 0 are always read as a 0, 0. 106. Fast track to SCSI MB870303131. Table 2. Bit assignments for internal registers. Register RIW. Hex and OPER 765432110 parity. Address mnemonication, MSB, LSB. Bus R number 7. 1 hashtag 6 I number 5 I number 4 I number 3 I number 2 I number 1 I number 00. 0 device 10. Bold, WG, IBus, cell D1. SBCR reset con diagram R bit parity select reint. 1 control and distral select P. SCTL, W able reset mode enable. Command RRST intertransfer module term. SCMD, command code sept PRG mode P. 2. W outs for slur 0. Transfer rsync. Modes for max. Transfer min. Transfer 00p. 3. TMOD, W. Offset period. Command. SCMD, 42121. Interrupt rselic resol disconcom ser lime SBC reset. Sense tednect MAND vice re hard kindi. P. 4, ins, ected comp quired out errortion. Plit. W reset interrupt. Phase R Rio Acadien cell BSY message C/O110p. Sense. PSNS, W. 5. SBC diagram R. Control. SDGC, W diagram. Diagram. XFER diagram. OIG. Diagram. Diagram. Rio AC enable BSY message SID 1/0. SBCR connected SBC XFER SCSI TC equals ODREG tattoos. Status. Init LTARG. I. BSY. In Pro P. 6, SSTS, Gress RST full empty. W. SBC data error 00 DC phase short offset. 7 error R. SCSI ISBC IRII parity I. 3. P. Status error period error. SER. W. 107. MB870301331 fast track to SCSI. Table 2. Bit assignments for internal registers, continued. Register RIW. Hex and OPER 765432210 parity. Address mnemonication, MSB, LSB. Bus. Phase R free transfer phase. Control inter. 0. PCTL, W message. I. C/O. I/O. P. 8 rupt out. Enable. Modified R. I bit 2. MBC. I bit O. Byte 0 bit 3. I bit L. 9 counter. MBC, W. Data R internal data register, 8 byte FIFO. Register P. A. DREG, W bit 7. I6. I5 I. 4. I. 3 I2 I1 I0. Temporary R temporary data, input, from SCSI, P. B register bit 7 I6 I51 4 I3, 2 I1 I0. Temp, W temporary data, output, to SCSI, P. Bit 7 I6 I51 4 I3 I2 I1 I0. I. Transfer R. C counter transfer counter high, MSB, P. High W bit 23 22 21 20 19 18 17 16. TCH. IJJIIIJ. Transfer R. I. D counter transfer counter high, second byte, P. Mid. W bit 1s 14 13 12 11 10 9 8. TCM. IIIJJIJ. Transfer RIII. III. E counter transfer counter high, LSB, P. Low W bit 765432210. TCL. External R. F buffer Saint Tajay. 4 buffer. EXBF, W bit 7. J. 6. J. 3 I2 I1 I0. P. 108. Fast track to SCSI MBB 7030131. DC characteristics. Recommended operating conditions unless otherwise specified. Values. Parameter designator condition. Min tip max. Unit. Power supply current TOS steady state 100 mA. Power dissipation PO 300 MW. Output high voltage VOIOH equals -0.4 RNA 4.2 VV. Output low voltage VOL IOL equals 3.2 RNA VSS 0.4 V. Input high voltage VIH 2.2 V. Input low voltage VIL 0.8 V. Input leakage current 3 V equals O-1010 RNA. 3 state. Input leakage current ILZ 6 equals 0 VU 10 RNA. Note 1 VIH equals VU equals VIL equals VSS 109 MB870303131. AC characteristics. Recommended operating conditions unless otherwise noted. MPU interface. II 111 ITCLFT 1 CRK-2 // 111 T plus TCHCL underscore TCHC R TRSTW 1 Fast track to SCSI // 110 Fast track to SCSI MB870303131 w r.i.t e.c.v c.e.cr e.gt .e.colon.rs.o.t.t.r h.n v s I /colon comma comma lua.ca j dash tt values. Parameter designator unit. Min. Tip. Max. Address setup TAWS 40 NS. Address hold TAWH 5 NS. OS setup TCWS 25 NS. OS hold TCWH 10 NS. Data bus setup TOS 25 NS. Data bus hold TOWH 20 NS. WT pulse width. TWT 50 NS. Underscore T underscore 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 1 underscore 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 J4 TAWS dash IAWH dash dot dash R 1 1 I use ITWTITCWH a 3AO dash /J dot dash dash to WH lows dash 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 WT 07-00 op dash JRI dash 111 MB870303131 fast track to SCSI. AC characteristics, continued. Values. Unit parameter designator. Min. Tip. Max. Address setup TAWSE 40 NS. Address hold TIHE 5 NS. CS setup ICWSE 25 NS. CS Hoid ICWHE 10 NS. WM low to DMA data bus. TWLHO. HDB7 HDBO, HDBP. NS4060. WM high to DMA data bus TWHHO10. HDB7 HDBO, HDBP. NS30. MPU data bus 07-00 DP. DMA data bus Toho 5 NS 25 50. HDB7 HDBO, HDBP. HIN high to DMA data bus. INS, HDB7 HDBO, HDBP, 10NS40. HIN. V. A3AO. IP. X2. I. R. TAWSE. Plus. I away. III. CSII. J. ICWSE. T4 ICWHE. WMI. LTI, TWHHO. ITHINZRI14 TWLHO. D7 do DP. II. 1. I Toho II. Toho. -1. HDB7 HDBO, HDBP undefined. 112. Fast track to SCSI MB870303131. AC characteristics, continued. Values. Max. Unit parameter designator. Min. Tip. Address setup TARS 40 NS. Address hold TARH5 NS. CS setup, RD, TCRS 10 NS. CS Hoid TCRH5 NS. Mpulse with TRO 50 NS. RITG low to data output TRLNZ 1045 NS. RITG high to 07-00, DP. TRHHZ. High Z40 NS. M low to data established TRLO 85 NS. M high to data hold. TRO 10 NS. CS setup, RU, TCRGS 5 NS. A3AO. Dash comma dash dash IR underscore. Dash. Dash TARS I plus dash TARH. Y. D7 do DP. I. TCRS, dash. 4 TCRH. Backslash, 1. TCRGS, I. ITRO. Dash plus comma I comma dash underscore underscore underscore. 1. 1. TRHH. 1, RLRLL. TRLNZ01. 0. Valid dash. 113. MB87030, 31 fast track to SCSI. AC characteristics, continued. Values. Min. Max. Unit parameter designator. Tip. Address setup TARS 40 NS. Address hold TARHI 5 NS. CS setup TCRSE 10 NS. Cs hold TCRHE 10 NS. Rug low to OTA output TRLNZ 1045 NS. Rug high to 07-00, up. TRHHZ. High Z. 40 NS. OMA OTA bus, Hop 7 Hobo. HOBP, to MPU OTA bus though 550 NS. 07-00 op. HIN low to Hop 7 Hobo. HOBP high THINZ 40. HIN LR dash. A3AO. Rug, RO. Node. Underscore underscore T underscore 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 I TARSE plus TARHE dash dot backslash 1 dash 1C TCRSE dash plus I TCRH 111 dash 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 THNZ dash 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 II Hop 7 HDBO HDBP underscore 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 RL dash I dash comma dash I backslash comma comma dot I underscore underscore. I though I dot trhwi. 1 it hool 1. Underscore 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 I underscore tr underscore lnx equals colon dash 07 dash 00 dp. Note 1. These two signals may be applied simultaneously. 114. Fast track to SCSI. AC characteristics, continued. Designator IT-RI. TCHIR. TWHIR2 TCLF plus 80. TWRCY4 TCLF. 1. Refer to clock signal timing for definition of TCLF. 2. Cycle time for WT when interrupt is continuous. 1. JVVV1. M8870303131. Unit. NS. 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 I plus 1. Dash dash L dash. INTR. LJ1WT. 1. Dash dash TWRCYT. I. 115. MB87030131. AC characteristics, continued. DMA interface. Note. 1. Refer to clock signal timing for definition of ELF. Tolo H. DREQ. UTRPO. TORRF plus JL031-TRPC, I // I dash, dash, dash. DRISP. 1 plus TRPSW plus dash Louis I. ITRLRH dash comma. II. 116. Fast track to SCSI. Fast track to SCSI MB87030131. AC characteristics, continued. 1. When SBC receives RIO, initiator, or ACK, target, with an empty FIFO during DMA, hardware, transfer. 2. Refer to clock signal timing for definition OELF. Areola ACKI underscore 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 JV. Dash plus slash. TRAOR. Dash, dash I. DREO. RT. ORO. V1I. DRISP. IN. Underscore 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 on. Colon dash J dash. I. Dash 1I. TRPOVII. I. LTHINZ. 1I. II. Unpredictable. Data 1. I. Data 2. HIN. HDB7 HDBO, HDBP. 117. MB87030131 Fast track to SCSI. AC characteristics, continued. Unit parameter designator. Dash dot dash dash R dash 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 1. Min tip max. Values. HIN low to HDB7 HDBO. THIHZ. HDBP, high Z. 40 NS. Data bus setup THOBS 20 NS. Data bus hold THOBH 20 NS. DREQ low to DRISP, note, TOLRP. DRISP low to REQO or TORRA4 TCLF2 plus 115 NS. ACKO high 2. Notes. 1. Refer to clock signal timing for definition of TCLF. 2. The indicated timing is invoked if SBC receives DRISP when the internal data buffer is empty during a DMA. Hardware, transfer. The timing parameter is waived for ACKO and the last byte is transferred with the SBC. Serving as an initiator. REQ over ACKO DREQ DRISP HIN Note I 1 dash 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 1 TOLRP slash underscore 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 J slash backslash underscore 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 1 1 dash I1 dash dash I1 1 1 1 1 THIHZ plus THOBST dash plus plus THOB 1 HDB7 HDBO HDBPX data 1 dash 118. Note, in the following cases the DREQ signal becomes inactive asynchronously with the DRISP. Signal to stop refetching data during an output operation. The transfer pause command is issued when the SBC is serving as a target. The transfer phase is changed when the SBC is serving as an initiator. In these cases, the last DRISP signal response must not exceed TDLRP. Fast track to SCSI. AC characteristics, continued. SCSI interface, selection phase. 1. Refer to clock signal timing for definition of TCLF. 2. N equals TCL register set value. Tip. MB870303131. Unit. Max. 7 plus N, XNS. TCLF plus 65. NS. NS. 119. MB870303131 fast track to SCSI. AC characteristics, continued. BSYI. BSYO. Cell. Cello. SDBO, 10-bit. SDBE, 10-bit. TBFR. Slash comma, 1JH4IT7 dash comma dash dash comma dash backslash underscore, JJ. TBFBO. TSBCRTBOB dash. Slash. OJ. Dash dash, 1F. Dash dash. TPBCRTLDBL. Dash dash, RT comma dash dash. A, slash, backslash. I. TAWSO plus T, TBI.SO TARB comma dash underscore T comma dash dash dash. 1, underscore 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 dash I1 I1. 1 TSOIDII. II. TBIDH. TBHID, I or 10. I backslash J, underscore T, dash. II. SOBO, except 10-bit. SDBE, except 10-bit. Dash 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 RSDBI7S0 bio, SOBD. X. X colon. II. 1100. Init. TAIDV plus. I. 1. I plus story lot. Underscore 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 I underscore 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 R comma dash 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 104 plus 1 R dash ATNO underscore 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 TSCIRI dash Y INTR command complete colon 120. Fast track to SCSI MB870303131. AC characteristics continued. Parameter designator. Min. 2. Bus free to data bus, 10, TFRIO, 6 plus n, x. Send TCLF plus 5. 10 send to Celo high at TLOSO 11 TCU50. 10 send to init high. TLOIT 11 TCU50. Init high to ATNO high TLTAT minus 5. BSYI high to Celo low TBISO 2 TCLF plus 5. BSYI high to data bus, 10, hold TBIOH 2 TCLF plus 5. Celo low to INTR high TSCIR. Notes, 1. Refer to clock signal timing for definition of TCLF. 2 n equals TCL register set value. 1 I. Values. Unit. Tip. Max. 7 plus n, x. TCU plus 85. NS. 11 TCU 15 11 TCLF plus 25 NS. 11 TCLF 11 TCLF plus 40 NS. 525 NS. 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 035 NS. BSYI. L underscore 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 dash dash I BSYO cell cello dash 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 slash 1 1 1 backslash dash dash TBISO IJ1 underscore 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 JJ I 1 dash TFRID dash colon TLDSG dash plus II underscore I TBIDH SOB 07S0 boo so bop LR dash colon I colon O colon 2 T backslash dot underscore 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 111 11 I dash dash I soap 7S0 BEO so beep 19 I 1 slash 00 init ATNO 1 I lol 1 I TOIT dash dash plus L dash 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 II TLTAT II dash 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 I 14 TSOIR INTR command complete I 121 MB870301331 fast track to SCSI AC characteristics continued. Unit. Tip. Max. 5 TCLF plus 60 NS. 1. Refer to clock signal liming for definition of TCLF. 2. In case of bit 0, 1/0 out, a PCTL register is set in advance. 122. Fast track to SCSI MB870301331. AC characteristics, continued. BSYI. T slash. I. BSYO. 4. I. TSOSI. I. Cell. I. Dash 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 colon dash, dash backslash. TLDSII. ITSOID2. I. III. SDBI7 STBO, STBIP. Equals L underscore underscore I. Underscore underscore, ID, underscore 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 X. Underscore 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 underscore. K. Dash dot J14 try SI. I. Dash 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 dash. 1101. II. ATNI. TATS ITSLTG. I underscore 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 1 I targ dash dot ttgph 1 dash dash underscore 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 gmsgo I c slash do dash 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 a dash I underscore 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 L dot dash 1 TLODE IR dash plus dash 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 1100 SDB 07 boost bop I SDBE 7 SBO, SBEEP. Dash 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 dash. INTR, selected. TSLIR dash dot comma point 1. I. J dash. 123. MB 870301331 fast track to SCSI. AC characteristics, continued. Values. Unit parameter designator. Min. Tip. Max. Data bus, 10, valid to cell high TLDSI0NS. 1/01 low to cell high TRI-SI0NS. Cell high to BSYO high. TSLBO2 TCLF1 plus 5. Response time. 3 TCLF plus 65 NS. BSYO high to data bus, 10, hold TBOID 20 NS. BSYO high to cell low TBOSI 0 NS. ATNI high to cell low TATSL 0 NS. Cell low to targ high TSL TG 3 TCLF plus 5 4 TCLF plus 60 NS. Targ high to phase signal output 2 TTGPH minus 5 10 30 NS. 1/00 high to data bus enable TLODE 4 TCLR 304 TCLF plus 70 NS. Cell low to INTR high TSLIR 3 TCLF plus 65 NS. Notes. 1. Refer to clock signal timing for definition of ICLF. 2. In case bit 0, IO, a PCTL register is set in advance. 124. Fast track to SCSI M887030131. AC characteristics, continued. BSYI. / BSYO. Cell. Underscore TSLBO.L, dash underscore 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 I1 II underscore tau SI J 1 underscore 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 comma dash J 11 dash TIDSI dash dash TBOID 1 1111 SDBI 7 SBO SBIP equals J I 10 T dot comma dash X equals 1101 ATNI targ MSGO C/do 1100 underscore I11 dash plus TL1S1 underscore 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 dash underscore 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 I dash A 1 underscore 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 dash L TATSI dash 1 TSLTG 111 underscore 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 on dash plus colon underscore 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 JL dash 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 comma dash 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 dot ttgph underscore 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 L dash 1 dash 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 1 underscore 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 dash dash L TLODE SDB07 boost bop 1 comma dash dash plus dash 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 1 SDBE7 BO beep dash 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 INTR selected TSLIR dash 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 125 MB870303131 AC characteristics continued SCSI interface reselection phase notes 1. Refer to clock signal timing for definition of TCLF. 2. N equals TCL register set value. 126. Fast track to SCSI. Fast track to SCSI MB870303131. AC characteristics, continued. 1A TBOBI. TBLBO. TBFR-1. R. 2 TCLF plus 5, min. Slash, F slash dash 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 TSBCR plus II. T. 1 I backslash IY dash. Dash dash JL. Dash dot, TTPBCR2, dash, dash colon dash 4 comma 1. II1I. Comma point 11. 1 plus TCLF. BFBOR. Dash plus, underscore, 1 dash underscore dash plus. J slash J. TBISA dot J. FI, dash dash. Backslash dot dash. 1 TIDBL, I. TARB dash dash dot II. I1I. Dash colon dash dash, II plus dash. T plus TBHIDI plus TSOL. IITBIDH. 1I1I. Backslash backslash V. J, dash, backslash underscore T, underscore underscore dot L. Dot JJ underscore. LJJ dash. I. TAWSO. Underscore 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 dash plus I dash, dash RIT colon colon colon. I. TIII. Underscore underscore plus 1 dash dash 10 dash 1. Dash. Dash I dash dash yen. IY. I, JJTLOBL. SOBI7S0 Biosobo. IIX, dash, dash dash plus JX colon equals. J dash TADE I. TSOTI. Targ underscore 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 dot TT dash dash I dash dash I. MSGO underscore 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 dash dash I dot I BSYI backslash I BSYOI J cell cello SDBO 10-bit SOB 10-bit SOBO, except ID bit. SOB, except 10 bit. CIOO. Underscore 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 one underscore 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 one dash I underscore 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 on dash dash I TSCIR plus JT plus 1100 INTR command complete Y 127 MB870301331 fast track to SCSI. BSYI slash dash underscore 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 J I underscore 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 dash TSIB colon dash L4 colon ISLBO dash R backslash underscore 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 dash 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 IBOS dash 4 dash comma ISIB ILOB avoid J plus dash plus BSYO cell colon I asterisk I 4 ILIBI ITSIIH SDBI 7 STBO STBIP 1/01 underscore 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 comma T dot TSUT underscore 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 on colon dash JJ dash ITTDE I dash I init SDB07 STBO STBOP SDBE7 STBO STBEEP dash ISUR dash dot underscore 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 L dash INTR reselected 128 fast track to SCSI MB870303131 AC characteristics continued SCSI interface transfer phase IT backslash dash underscore 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 J dash 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 1 1 TAHRL1 TRLAL1 TRHAH IIIIIOIIIT I dash underscore II 1I11 REQOJ TALRH 1 ACKI underscore 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 comma 1 underscore 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 11 ITAHRH TDVRQ dash dash plus dash dot TAKDV SDB07 STBOSTBOP dash dash I dash dash MSGO C/do 1/00 I underscore 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 X underscore 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 on underscore 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 jx backslash dash underscore underscore dash underscore 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 1 L dash dash TLODEI SDBE 7st BOST beep 1 dash 129 M8870301331 fast track to SCSI. AC characteristics, continued. Values. Max. Parameter designator. Min. Tip. Unit. 1100 low to data bus disable TLO00 2055 NS. Data bus valid 10 ACKI high 10 IAVOC NS. REOO low 10 data bus hold TRLOV 25 NS. REOO high to ACKI high TRHAH 20 NS. ACKI high to REOO low TAHRL 1030 55 NS. REOO low to ACKI low TRLL 0 NS. ACKI low to REOO high TLRH 035 NS. ACKI high to REOO high TAHRH 2 TCLF plus 5 NS. Note 1. Refer to clock signal timing for definition of TCLF. Underscore 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 YIT dash 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 J IITAHRLITRLLITALRHI R T re1 at IIT II-111 TRLOV II TTOVAK REOO ACKI II SDBI 7-5 DBIO SBIP RXR MSGO underscore 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 X underscore 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 on C/do underscore 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 X underscore 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 on 1100 backslash I J4 dash I TLOOO I SDB07-5 DBOO SBOP underscore 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 dot JIL underscore 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 I SDBE 7-5 DBEOS beep dash 130 Fast track to SCSI M8B7030131 REOI ACKO 2 3 1 41 TRLNAT RTRLR colon dash 11 TAHRLLTRLALII1 TPHRQ IIITRHAH dash colon 44 TLRH underscore 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 I underscore 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 colon underscore 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 R underscore 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 I underscore underscore 111 1I11 1 TDVAK TRLDV TLPH 111I111 Sob 07S0 Boo, Sobo dash underscore 1 colon XR underscore 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 LR 1 I TRATL1 4T dash dash ILLA dash 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 I at no 11 MSGI dash dash asterisk dash I1 dash dash equals I. Asterisk R. 1, IT. 1. R. I colon dash dash dash. TLLDE. SOAP 7S0 BEO, SOBEEP 1, dash. C/OI. 1101. 131. MB870303131 Fast Track to SCSI. AC characteristics, continued. Values. Parameter designator. Min. Tip. Max. Unit. 1101 Hi-ATO data bus disable TLL do 4575 NS. Phase specify to REOI high TPHRO 100 NS. ACKO low to phase chine TLPH 10 NS. Data bus valid to REOI high TOVRO 10 NS. ACKO high to data bus hold TAKDV 15 NS. REOI high to ACKO high TRHAH 1540 70 NS. ACKO high to REOI low TAHRL 0 NS. REOI low to ACKO low TRLAL 1045 75 NS. TALRH 10 ACKO low to REOI high at NS. ATNO high to ACKO low to TATLBI equals 20 NS. Notes, 1. Refer to clock signal timing for definition of ELF. 2. With these timing parameters, the ATNO signal is sent only when parity checking is enabled and a parity error is detected in the input data. Joy 41 TRLNA. REOI --I -T -I TID ITITRLLITIIR PHRORHAH, AHRLC : LRH I, smiley face, K1 IGI. III. Plus TDVR TAKDV. Dash dash asterisk : TL : ACKO SDBI 7-8 DBI 0 STBIP 4 dot colon one dash plus colon dash IL TALPH III ATNO MSGI dash dash asterisk dash II C/OI equals dash II dash dot I1 TLLDO dash II 1101 SDB 07-8 DBOO SDBQLL I SDBE 7-80 BEO Sub 132 Fast Track to SCSI MB870303131 AC characteristics, continued. Notes, 1. Refer to clock signal timing for definition of TCLF. 2. N equals TMOO register set value. TROAP TRNAP. I4I. REOO ____G \1 F. TAKF2 II4 TRHA. IHTAKF1. TAKAP ELG. TDVROI. 1 dash dash point 1 I 1 dash TI 1 dash TRLDH ANAP ACKI SDB07 boost bop IIIR underscore 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 dash backslash R dash backslash RP XXX underscore MSGO dash backslash dash I C slash OO dash backslash dash I underscore 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 I TIOOE 1100 SOAP 7S0 BEO SBEEP 1 dash 133 MB870303131 AC characteristics continued. Notes 1. Refer 10 clock signal timing for definition of LELF. 2 N equals TMOO register set value. REAOJ ACKI TDVAK dot I dash SOBI7S0 bio SOBIP comma dash dot comma MSGO backslash C slash OO backslash 1 slash 00 TTODD fast track to SCSI backslash 1 backslash I TAKF2 I TL X equals SOB 07S0 busobop underscore 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 on SOAP 7S0 BEO SOBEEP dash 134 fast track to SCSI MB870303131 I TROF2 I TROF1 dash plus T I TROAP IRNAP II comma I real I Y backslash J backslash I plus TPHRO underscore I TRHAHTAKAPTANAP1 I ACKOII I backslash slash II I of row I TRODH I SDBI 7 STBO STBIP XX I L plus TRATH I ATNOII ITALPH I MSGI backslash I1 I C slash D backslash II 1101 LI I dash TLLDO C SDB07 boost bop I SDBE7 BO SDBE 135 MBB1030131 fast track to SCSI AC characteristics continued. 1. Refer to clock signal timing for definition of TCLF. 2. N equals TMOD register set value. 3. With these timing parameters, the ATNO signal is sent only when parity checking is enabled and a parity error is detected in the input data. 136. Fast track to SCSI MB870303131. AC characteristics, continued. 11. 14 TROF2I 11. TROF1 1 1 TROAPTRNAP11 14.1 I1 1111 Real RT1 /R /11I 1. II. 1. Straight face, TPHRAITRHAH. TAKAP. TANAP1. III11. ACKOII1. II. II. I1111. 1 TOVRO14. ITROOHI. 1111. SD617 SD610, SD61PXXI. 111. 1 plus TRATH plus JI. ATNO asterisk 1111. 111. 1. TALF. MSGI. Backslash, 1. 111. 1 IT equals. C/OI. Dash. 11. 1 I. 1101 I. Dot. Tnug. L. SDB07 SBOSOBOP. I. SDBE7 SD6EO SDBE. 137. MB870303131 Fast Track to SCSI. AC characteristics, continued. C/do 200 TPHCH 104065. I. WT backslash. TPHCH. I. 14. MSGO. Asterisk. C/do. I. 1/00x. Parameter designator. Values. Min to tip. Max. WT high to data bus valid trove 4060. Temp register output. WT high to REOO, ACKO high TSTRA2 TCLF plus 53 TCLF plus 80. Set Acurio command. WR high to REOO, ACKO low TRTRA2 TCLF plus 53 TCLF plus 80. Reset Acurio command. Notes, 1. Timing sequences not shown here conform to the asynchronous transfer timing sequence. To refer to clock signal timing for definition of TCLF. WT backslash Y, LT, comma dash dash Y. Temp, SCMD, IT, SCMD. ITSTRA. TRTRA, comma dot T. II1I. NS. Unit. NS. 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 REOO, target. ACKO, initiator. I backslash underscore underscore underscore. TWTOV. I. SDB07-8 DBOO, SBOP-: JJLOOLLX, dash. 138. Fast track to SCSI MB870303131. AC characteristics, continued. Values. Parameter designator, -R-T- unit. WT high to at no high/low. Set ATN command and reset TATNO. ATN command. Note. Min. Tip. Max. 2 TCLF plus 5. Note. 3 TCLF plus 90. 1 Refer to clock signal timing for definitive of, ELF. WT. -I. IL. TATNO. III underscore underscore, straight face, underscore underscore dash underscore. ATNO. NS. 139. MB870303131. AC characteristics, continued. SCSI interface, bus free. Parameter designator. Min. BSYI low to init low TBLIT. Init low to bus clear TLTCR. BSYI low to INTR high 9 HTBLIR. Note 1. Refer to clock signal timing for definition of TCLF. 1. BSYI / values tip 20 1 TBUTEJ init 1 TITCR 1 ATNO dash 1 1 ACKO dash 11 1 SDB07 boost bop X 1 1 1 I SDBE7 biost beep L IIBLLR INTR 140 Fast track to SCSI unit max 5 TCLF plus 70 NS note 50 NS STCLF plus 75 NS I T Fast track to SCSI MB870303131 AC characteristics continued parameter 3 TCLF plus 80 NS 1. Refer to clock signal timing for definitive of /elf WT targ BSYO MSGO C/00 1/00 REOO I \_L1 SCMO TWTGL plus 1 1 TWRLS plus dot dash 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 dot TTGCR dash dash dot colon dash 1 1 dash \_ 1 \_ dash 1 \_ 1 1 dash \_ dash 1 1 dash \_ 1 dash ISOB 07S0 boo so bop underscore 1 1 soap 7S0 BEO so beep underscore \_ dash 141 MB870303131 fast track to SCSI AC characteristics continued values parameter designator min tip WT high to cello low TWSL ints register WT high to data bus disable TWDBL ints register WT high to targ or init low TWTIL ints register targ low to 1100 low at Gaio 10 WT high to INTR low IWIRL ints register note 1. Refer to clock signal liming for definition of ELF WT IR underscore 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 underrun underscore 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 I dash LWSL I underscore 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 cello BSYI I 1 dash 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 TWDBL dot SOB 07 book STBOP IL underscore 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 I dash plus 1 dash 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 \_ soap 7 BO beep I dot dash idle I target init I \_ underscore 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 I I1 underscore I. ITTGIO dash plus I. II1100. L. Underscore 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 underscore. Twirl dash dash. I. INTR, TMUL, I. Underscore 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 underscore. 142. Fast track to SCSI MB870303131. AC characteristics, continued. SCSI interface, reset condition. WR. RSTO. Init. Targ. BSYO. Cello. REOO. ACKO. MSGO. C/do. 1/00. ATNO. Designator, dash, dash comma dash dash TI unit. NS. If, SCMD. Dash I, dash, dash. ITRs TO. TRs OD dot dash I1. Underscore 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 I dash backslash dash. I. Dash SDB07 STBO SDB underscore 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 run dash underscore dash SDBE7 STBO SDBF underscore 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 backslash underscore 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 underscore. 143. M887D30131 Fast Track to SCSI. AC characteristics, continued. 1. Refer 10 clock signal liming for definition of TCLF. RSTI. II. 14 IRA plus I. II. I dash I, dash. I. 1 dash dash IRGO I. Init. Targ. BSYO. Cello. REQO. ACKO. MSGO. C/do. 1/00. ATNO. Underscore dash I. Dash 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 1 dash 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 I. Underscore underscore I. SDB07 STBO SDB underscore 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 backslash dash. I. Underscore underscore I SDBE7 STBO, SDBE. Underscore 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 unl dot comma dot underscore 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 underscore. I. Capacitance, T equals 25 degrees CA, VDD equals OV, F1 equals 1 MHz. Values. Parameter designator unit. Min tip max. Input pin capacitance CTN9PF. Output pin capacitance CAT9PF. 110 pin capacitance QO11PF. 144. Fast track to SCSI MB870303131. Grid array. 88 lead ceramic pin grid array. PGA 88CA01. 88 lead ceramic pin grid array. Case no. PGA 88CA01. 1. 30.10, 1.185. 30.86, 1.215. In J. Dash. Dimensions in inches, millimeters. 27.94, 1.100. Ref. 2.54, 0.25. 0.100, 010. Slash 0.27, 0.050, tip dia. At ddddddddddda. dddddddddddd. dddddd. ddd. 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 ddd extra ddd. dd index pin dd. ddd. ddd 0 dd. ddddddddddd. 0 ddddddddd 0. R88002 SC3C. 145. MB870303131. Grid array, continued. 100 lead plastic flat package. 146. FPTL00P mole. 100 lead plastic flat package. Case no, FPTL00PM01. Fast track to SCSI. M88703338. SCSI Protocol Controller, SBC. With on-chip drivers/receivers. General description. The MB87033 SCSI Protocol Controller, SBC, is a CMOS LSI circuit specifically designed to control a small computer systems interface, SCSI. The MB87033 rounds out Fujitsu's SBC family of protocol controllers by providing software enhancements and other functional features that will meet all facets of the SCSI specification, ANSI X 3.131-1986. To achieve optimum performance and interface flexibility, the MB87033 provides an 8-byte first in first out, FIFO, data buffer register and a 28-bit transfer byte counter which allows burst transfers of up to 256 megabytes. To improve programming requirements. Attention! Detect and arbitration fail interrupts are provided and on-chip driver/receiver circuits. Simplify interface connections. Data transfers can be executed in either asynchronous or synchronous mode with a maximum offset of 8 bytes. SCSI compatibility. Supports all commands. Software compatible with MB87030/31. Serves as either initiator or tar. Get. Data bus. Independent buses for CPU and DMA. Controller. Transfer modes. Asynchronous. Synchronous mode transfers with programmable offset of up to 8 bytes. 8-byte FIFO. Data transfer speed. Up to a maximum of 5 megabytes/section. Selectable operating modes. DMA transfer. Program transfer. Manual transfer. Diagnostic. Interface. On-chip single-ended drivers/receive. ERS. Guaranteed to sync 48 MA regardless of the number of outputs simultaneously. Asserted. Enhancements. On-chip parity generation. Attention condition detect interrupt. Arbitration fail interrupt. 8-byte FIFO. 28-bit counter. Clock requirements. 10 MHz clock. Technology/power requirements. Silicon gate CMOS. Single plus 5V power supply. Available packaging. 84-pin plastic leadless chip carrier. 80-pin plastic flat package. 147. MB8703338 fast track to SCSI. Absolute maximum ratings. Values. Rating symbol unit. Min-max. Supply voltage VU VSS 20.36.0 V. Input voltage 6 VSS 20.3 VU plus 0.3 V. Output voltage 2 VO VSS 20.3 VU plus 0.3 V. Storage temperature, ceramic, TSTG-65 plus 125 degrees C. Notes. 1. Permanent device damage may occur if the above absolute maximum ratings are exceeded. Functional operation should be restricted to the conditions as detailed in the operational sections of this datasheet. Exposure to absolute maximum rating conditions for extended periods may affect device reliability. 2 VSS, OV. 3. Not more than one output may be shorted at a time for a maximum duration of 1 second. 148. Fast track to SCSI M88703338. MB87033 block diagram. I070.pi. 2. J::IE. I. R. TCE. I. : parity OPO. TCH genera. ITOR. R. IR. TCL. : equals. Dash, -1. MTU. Transfer DREO. Control. FTR ORISP. 2. JHIN. Dash. A. Dash equals. Comma, I, MBC hop 7 OP. Equals 7 IDJRF1 dash. RR. 170 underscore. Lim underscore .1. M underscore. Phase R. Control preg. : RL. C. 1. C. A. R. 2. MOI. LRBR. UILPCD. 3. Co. LE, 0 RO dash. I4. I. X. A5. YI. 6. I. 7. TRNI underscore. I. M underscore. IB.I pound. Arbitration W. And selection, OU. Logic. 1M. In. T. INTR in 2. Dash. A3.AQ. Bold R ints. 1. Address CS. Interrupt R. Serve. 1. Decode. M1.1100 and MPU. De. Status R. 1. Unterdis WT.WTG. 149. M88703338. Transfer pin assignments. So pin plastic flat package. 150. Reset. VSS. Open. NC. NC. DB. VSS. RNR. RNR. MR. VU. VSS. VSS. DB. OS. RNR. RNO. VSS. MR. NC. IO. Test. VSS. ORISP. I. /807978 N7675747271706968676665. 1. 64. 263. 3 pin 1 index 62. 461. 560. 659. 758. 857. 956, 1055, 1154, 1253, 1352, 1451, 1550, 1649, 1748, 1847, 1946, 2045, 2144, 2243, 2342, 2441. $. Fast track to SCSI. I. CS. VSS. Into. NC. NC. ATN. VSS. BSV. J. CR. Message. VSS. VSS. VU. SE. C70. Rio. VSS. 110. NC. NC. OPER. VSS. CCR. Fast track to SCSI MB87033B. Pin assignments. 84-pin plastic leadless chip carrier. Top view. NC74V88. VSS73 reset. DRISP72 OREQ71 CPO. HIN70 tip. Hobo69D7. Hob168 Hob267 DIS. HDB366D4. Hob465 VU. Hob564D3. VDO63D2. HDB6201. HDB761 DO. HOBP60 ROJ. AD59MJ. A 158 WRN. A 257 WT. A 356 CS. CIR 55 V88. VSS 54 INTZ. 33 34 35 36 37 36 39 40 41 42 43 44 454 647 4849 55152 53 55A55 F, 8CNCN, J 151 MB870338 Fast track to SCSI. Pin descriptions. Pin number. Designator function. FPTPLCC. 173 reset. When set to the active low state, an asynchro news reset signal that clears all internal circuits of the SBC. 2.7, 1,2 VSS power supply ground. 12,13 8,13. 18,23 32 36. 42,47 43 44. 52,53 50 55. 58,63 74 78. 3,43, open reserved. Note, do not make external connections to these pins. 4,5 4,10 NC no internal connection. Note, these pins must 20,21 11,12 be open connections at all times. 44,45 33 34. 60,61 39, 41. 46,52. 53,75. 76,81, 83. 879 UB7 inputs/outputs for the SCSI data bus. These I/O 980 UBS pins connect directly to the SCSI connector. 1082 UB5 UB7 is the MSB, AO is the LSB. OBP is an 14.3 UB4 odd parity bit. 15.5 ORO. 16.6. 17.7 MIT. 199 UBO. 677 OBP. 1133 2,21, 22, 42 VDD plus 5V power supply. 51, 73 44, 63, 65, 84. 22 test reserved for test functions. Note: do not make external connections to these pins. 2414 DRISP is a response signal to the data transfer request signal DREQ. The DRISP pin must be refreshed with an applied pulse after each byte of data is transferred. In the DMA mode, DRISP is used as a timing signal for completion of a data byte transfer. 152. Fast track to SCSI M8870338. Pin descriptions. Pin number. Designator function. FPTPLCC. 2515 OREQ. When executing a data transfer cycle in the OMA mode, OREQ is used to indicate a request for a data transfer between the SBC and external NAL buffer memory. In the DMA mode, routing of data is as shown below. Output operation, external buffer memory to SBC to SCSI bus. Input operation, SCSI bus to SBC to external buffer memory. In an output operation, DREQ becomes active to request a data transfer to the external buffer memory when the FIFO contains valid data. 2616 HIN indicates direction of transmission along data bus lines HOBO hop 7 and HOBP in the OMA transfer mode. To be executed, direction of transmission must be properly coordinated with internal operation of the SBC. When HIN is low, inactive, the data bus lines are placed in the high impedance state, input mode. When HIN is high, active, all bus lines are switched to the output mode. 3525 hop 7 3-state bidirectional data bus for transferring 3424 HDB6 data to or from the external buffer memory in the 3222 hop 5 OMA mode. As shown below, the direction of 3121 hop 4 data transmission depends on the HIN input sig. 3020 hop 3 NAL. 2919 hop 2. 2818 hop 1 HIN HDBN operation. 2717 HOBO L input mode output. 3626 HOBPH output mode input. 37 to 40 30 to 27 A3 AO address input signals for selecting an internal register in the SBC. The MSB is A3, the LSB is AO. When CS is active low, ready write is enabled and an internal register is selected by these address inputs via data bus lines 00-07 and up. 4131 CLK input clock for controlling internal operations and data transfer speeds of SBC. 153. M8870338 fast track to SCSI. Pin descriptions, continued. Pin number. Designator function. FPTPLCC. 5749 BSY input/output control signals for SCSI bus. 5040 SE. 4837 Rio. 5648 EC. 5445 MU. 4938 C70. 4635 L70. 5951 7 miles. 5547 RST. 6254 into a non-maskable interrupt request signal that indicates a reset condition on the SCSI bus. 6456 CS selection enable signal for accessing an NAL register in the SBC. When CS is active low, the following signals are valid: RIJ, WT, AOA3, 00-07 and up. 6557 WT input strobe used for writing data into an internal register of the SBC. This signal is asserted only if CS is active low. On the trailing edge of WT, data placed on data bus lines 00-07/0P is loaded into the internal register selected by address inputs AOA3, except when all address lines are high. AOA3 equals H. 6658 WRN. While the signal is active low, data placed on data bus lines 00-07/0P is output to hobohop7/HOBP provided the following input conditions are satisfied. CSEND HIN equals H. AOA3 equals H. 6759 RIJ input strobes used for reading out contents of 6860 RIM internal register. Strobes are effective only when CS is active low. When RUG is active low, the contents of an internal register selected by address inputs AOA3 are placed on data bus lines 0OD7/0P. For a data transfer cycle in the program transfer mode, the trailing edge of RO is used as a timing signal to indicate the end of data read. 154. Fast track to SCSI MB87033B. Pin descriptions, continued. Pin number. Designator function. FPTPLCC. 6961 do used for writing or reading data into or from an 706201 internal register of the SBC. These bus lines are 7163023 state and bidirectional. The MSB is 07, the 726403 LSB is due. OP is an odd parity bit. 746604. 756705. 766806. 776907. 7849 OP. When the CS and FLOG inputs are active low, contents of the internal register are output to the data bus, read operation. In operations other than read, these bus lines are kept in a high impedance state. 7950 OPO an odd parity output for data byte 07-00. OPO represents an output when 07-00/0P are placed in a high impedance state. OPO is in a high impedance state when 07D0/0P serve as outputs. If a parity bit is not generated for external memory, OPO can be used as an input. For OP 8051 INTR when active high, requests an interrupt to indicate completion of an SBC internal operation or the occurrence of an error. The INTR interrupt request can be masked by user software. When an interrupt request is honored, INTR remains in the active state until cause OT the interrupt is cleared. 155. M887033B fast track to SCSI. Addressing of internal registers. The MB87D33 SBC contains 16 byte wide registers that are externally accessible. These registers are used to control internal operations of the SBC and also to indicate processing/result status. A unique address, identified by address bits A3AD, is assigned to each of the 16 registers. These addresses are defined in Table 1. Table 1. Internal register addressing. Address bits. Register mnemonic operation chip select, CS, A3A2A1AD. Bus device 10 bold R00000. W. R. SPC control SCTL00001. W. R. Command SCMD00010. W. R. Transfer mode TMOD00011. W. Interrupt sense R. Inst 00100. Reset interrupt W. Phase sense PSNSR. 00101. SPC diagnostic control SDGCW. SPC status SSTSR00110. SPC error status ERR00111. R. Phase control PCTL01000. W. Modified byte count R. 01001. Extended transfer count MBCW. R. Data register DREG01010. W. 156. Fast track to SCSI MB87033B. Address bits. Register mnemonic operation chip select, CS, A3A2A1AO. Bus device ID BDIDR. 00000. W. R. SPC control SCTL00001. W. R. Command SCMD00010. W. R. Transfer mode TMOD00001. W. Interrupt sense R. Inst 00100. Reset interrupt W. Phase sense PSNSR. 00101. SPC diagnostic control SDGCW. SPC status SSTSR00110. SPC error status ERR00111. R. Phase control PCTL01000. W. Modified byte count R. MBC01001. Extended transfer count W. R. Data register DREG01010. W. 157. M8870338 fast track to SCSI. Table 1. Internal register addressing, continued. Address bits. Register mnemonic operation chip select, CS, A3A2A1AO. R. Temporary register temp 01011. W. R. Transfer counter, high, TCH01100. W. R. Transfer counter, middle, TCM01101. W. R. Transfer counter, low, TCL01110. W. R. External buffer EXBF01111. W. 158. Fast track to SCSI M8870338. Bit assignments for internal registers. Table 2 lists the bit assignments for the 16 internal registers defined in Table 1. In most cases, bit assignments for the MB87033 SBC are identical to those for the MB87030/31. However, in the MB87033, some features are expanded and others are added to improve overall performance. These modifications and additions are summarized in the following descriptions. MPU bus parity generator, an odd parity bit is output from OPO, pin 79 in FPT, pin 50 inches. PLCC, for each data byte, 07-00. DPO is a 3-state pin and is placed in a high impedance state when data from 07-00 is output to the MPU. If the MPU interface does not contain a parity generator, the output of OPO can be connected to the op input pin of the SBC, pin 78 inches. FPT, pin 49 in PLCC. Reset condition interrupt request signal. The INT2 output, pin 62 in FPT, pin 33 in PLCC, is a non-maskable interrupt request that, when driven high, notifies the SBC when a reset condition is detected on the SCSI bus. Bit 4. Reset condition interrupt mask enable, off phase control, PCTL, register does not affect the INT2 output pin. When a bus reset condition is detected, the INTR output, pin 80 in FPT, pin 51 in PLCC, also is driven to the high state. However, the state of INTR can be masked by bit 4 of the PCTL register. Bit 4 equals 0, INTR goes high when a reset condition is detected. Bit 4 equals 1, INTR does not go high when a reset condition is detected. Lost arbitration interrupt request. If bit 6, lost arbitration interrupt enable, of the phase control, PCTL, register is set to 1, a command complete interrupt is generated when the SBC, serving as initiator or target, loses in the arbitration process. To determine the cause of a command complete interrupt, completion of selection, reselection, or lost arbitration, refer to bits 6, target, and 7, initiator, of the SBC status, SSTS, register. If both bits are set to 0, the command complete interrupt is a result of lost arbitration. Attention condition interrupt. If bit 5, attention condition interrupt enable, of the phase control, PCTL, register is set to 1, and the SBC serves as a target, a service required interrupt occurs. To reset the service. 159. MB87033B fast track to SCSI. Required interrupt, set bit 3 of the interrupt sense, INS, register to 1 or revoke the current target role of the SBC. Expansion of transfer byte counter. If bit 0 of the transfer mode, TMOD, register is set to 1, the transfer byte counter is expanded to 28 bits. In the expanded mode, the high nibble, bits 24 through 27, are entered into the 4 most significant bit positions, 7 through 4, of the modified byte count, MBC, register. Note, when a hardware data transfer or execution of a select command is in process, access to the TMOD register is forbidden. Bit 0 of the TMOD register equals 1, to access the highest 4 bits, bits 27 through 24, of the transfer byte counter, data reads or writes are addressed to the high nibble of the modified byte counter, MBC, register. When a transfer or select command is issued, the transfer byte count, or TWAIT, should be placed in the high nibble of the MBC register rather than the TCH, TCM, and TCL registers. Bit 0 of the TMOD register equals 0, the transfer byte counter is not expanded to 28 bits, hence, reading the high nibble of MBC yields a 0 even though some particular value is written into the register. In this case, TWAIT, or the transfer byte count, is based on a 24-bit transfer byte counter, identical to the MB87030/MB87031. During read-write access of an internal register, the following rules are invoked. Internal registers include only those registers identified in Table 2. A write command to a read-only register is ignored. For write operations, all bit positions with a dash, blank, designator can be written as 0 or 1. All bit positions with an assigned 0 are always read as a 0, 0. 160. Fast track to SCSI M8870338. Table 2. Bit assignments for internal registers. Register RIW. Hex and OPER 765432210 parity. Address mnemonic Atlan, MSB, LSB. Bus R number 7. 1 hashtag 6 I number 5 I number 4 I number 3 I number 2 I number 1 I number 0 0. 0 device 10. Bold, WG, 1. Bus PCITCE 19D1. SBCR reset cont diagram arbit parity select resol int. 1 control and disroll ECTP. SCTL, W able reset mode enable. Command R. RST intertransfer modif term. SCMD, command code sept PRG mode P. 2. W outs for 0. Transfer rsync. Mode. Max. Transfer min. Transfer. Sphere. P. 3, TMOD, W sphere. Offset period. Count. EKPank. 421210. Interrupt rselic resol disconcom ser time SBC reset. Sense tednect MAND device rehard kindi. P. 4. Ints, ected comp quired out errortion. Plit. W reset interrupt. Phase R Rio AKDN cell BSV message C/O110P. Sense. PSNS. 5. SBC diagram. Control W diagram. SDGCJ Rio AC. BSV message C/O110. SBC are connected SBC XFER SCSI TC equals ODREG, tattoos. Status. INITLTARG. In Pro P. 6, SSTS, BSV Gress RST full empty. W. SBC data error 00 DC. 7 error R. SCSI. I. SBC parity phase short offset P. Status error period error. SER. W. 161. MB87033B fast track to SCSI. Table 2. Bit assignments for internal registers, continued. Register RFW. Hex and OPER 765432210 parity. Address mnemonic Atlan, MSB, LSB. Bus arbitra attentier reset. Phase Frischen kindi transfer phase. Control interfilenchen incheneln 0. PCTL, W rup terrup message 1C/D1/0P. 8 out. Enable mask. Modified. R extended transfer counter MBC. Byte. 9 counter. Bit 2. I. Bit 26. I. Bit 25. I. Bit 24. I. J. Bit 1 I bit G, MBC, bit 3 bit 2. Data R internal data register, 8-byte FIFO. Register P. A, DREG, W bit. I bit 4 I bit 31 bit 2 I bit 1 I. Bit C. Temporary R. Bit. I bits I. Temporary DAR, input, from SCSI, P. B register bit 5 BLT 4 bit 3 I bit 2 I bit 1 I bit C. Temp, W temporary DAR, output, to SCSI, P. Bit. 1 bits, bit 5 bit 4 bit 3 1 bit 2 I bit 1 I bit C. I. Transfer R. C counter transfer counter high, MSB, P. High. TCH, W bit 23, bit 22, bit 21, bit 20, bit 1 underscore 18 bit 1, bit L6 ET. I. Transfer R. D counter transfer counter high, second byte, P. Mid. TCM, W bit 15 I 14 bit 13 bit 12 bit 11 bit 10 bit 9 bit ISBI. I. Transfer R. E counter transfer counter high, LSB, P. Low. TCL, W bit 6 bit 5 bit 4 bit 3 bit 2 bit 1 bit OB. External R external buffer. F buffer P. EXBF, W bit. I6 bit I5 bit T4 bit I3 bit J2 bit I1 bit I. OB. 162. Fast track to SCSI M88703338. DC characteristics. Recommended operating conditions unless otherwise specified. SCSI bus pins. Values. Parameter designator condition. Min. Tip. Max. Unit. Input voltage VIH 2.05.25 V. VIL 0.00.8 V. Input current IIH VIH equals 5.25 V 10 mA. IL-VIL equals O.OV minus 10 mA. Output voltage VOLVU equals 4.75 V 0.5 V. IOL equals 48 mA. Input hysteresis with VHW 0.2 V. Other than SCSI bus pins. Values. Parameter designator condition. Min. Tip. Max. Unit. Input voltage VIH 2.2 V plus 0.3 V. VIL VSS dash 30.8 V. Output voltage VOH equals dash 0.4 mA 4.2 V. Vol IOL equals 3.2 mA VSS 0.4. Input leakage current ILN VIH equals 5.25 V 10 mA. ILN VIL equals O.OV minus 10 mA. Input/output ILN VIH equals S.2 SV 10 mA. Leakage current ILIN VIL equals O.OV minus 10 mA. Supply current 110 MHz clock 30 mA. Outputs open. Ta equals 0-70 degrees Celsius, VU plus SV. S%. 163. M88703338 Fast track to SCSI. DC characteristics, continued. Recommended operating conditions unless otherwise specified. Capacitance. Parameter designator condition. Min. Values. Tip. Max. Unit. Input pin capacitance Cn Ta equals 25 C, VU equals V equals OV, 9 pi. F1 MHz. Output capacitance call Ta equals 25 C, VU equals V equals OV, 9 pi. F1 MHz. 1/0 pin capacitance asterisk 2 Clio Ta equals 25 C, VU V equals OV, 11 pi. F1 MHz. 1/0 pin capacitance asterisk 3 Clio Ta equals 25 C, VU equals V equals OV, 30 pi. F1 MHz. Notes, 1. SCSI bus pins are UB7 UBO, USB, RST, SAR, 170, CLO, message, 1 MIR, RIO, 1 MK, and BSY. 2-4 ALI 1/0 pins except SCSI bus pins. 3-4 SCSI bus pins only, see note 1. 164. Fast track to SCSI M8870338. AC characteristics. SCSI signal timing chart is described as follows. SCSI /CDI /at. R. Notes, 1. Output KL. 2. No device is outputting L. 3. The other device is outputting KL. CLK. TBN. ELF. L. TCLCH. Parameter. Clock cycle time TCL F100 200 ns. Clock H pulse width TCHCL 50 ns. Clock L pulse width TCLCH 40. TRSTW 165 M8870338. AC characteristics, continued. Register write, except EXBF. A30. I. WT. WLG. D7P. DPO. FTDWS, -.1. \I. Top. Note, greater than 1 WTG is input at the same timing as WT or held to H. 166. Fast track to SCSI. Fast track to SCSI. AC characteristics, continued. Register write, EXBF. A3-0. TAWSE. Cs. TERS. WT. WTG1. TWLHD. 1. D7-P. 2HD. DPO 1,1111.T11I111, -. II011, I. Till 2I dash, TTLTI1 WNLL dash plus DMA pulse FWTHD. Output valid. WNLH dash plus DMA pulse TWHHD10. Output invalid. MPU data bus dash plus DMA bus. Delay. Note, *1 WTG is input at the same timing as WT or held to H. MB87038. LAWH. E. TWHHD. LTEHD. /1. 1. 55 NS. NS. 50 NS. 167. MB87033B. AC characteristics, continued. Register read, except EXBF. A3-0. Fast track to SCSI. OTTTARH. -TRO dash. Plus dash dash, TCRH. TRHHZ. TRH04OTT. D7OP. Parameter. Address hold LARH5OS. OS. Data bus. TRLNZ1040 OS. RIMH data bus TRHHZ1040 OS. Our per valid. RDL data valid ERLO 70 OS. ESOS. TRHO10 OS. 40 OS. 168. Fast track to SCSI. AC characteristics, continued. Register read, EXBF. A3-0. TARSE. 1 \. E. D7OP. TARHE. TCRHE. V. I \. J, though. TRHHZ14. TRLNZ. DPO. QJ. Note, 1, RU is input at the same timing as RU or held to H. DMA bus MPU data. Bus. HOD 50. M8870338. NS 169. M8870338 Fast Track to SCSI. AC characteristics, continued. DREG access cycle time. WTOR-RU. DREG access cycle time, 1, TOCY23 TCLF. WT. Parameter. \t. Underscore 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 underscore. Underscore LTCMCV underscore 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 / underscore dash. Values. Designator comma dash dash, comma dash dash \. Min. Tip. Max. SCMD register access cycle TCMCY. Time. 170. NS. Unit. NS. Fast track to SCSI. AC characteristics, continued. WT. INTR. Int2. Parameter. WTH interrupt. INTR.int2, L. Ints register access. Cycle time. \, comma dash underscore underscore pound underscore underscore underscore. L underscore LTL RY. Dash underscore \, colon colon colon, 1. TWHIR. 1. Dash. TWHR. TL RY4 TCLF. MB87033B. Unit. NS. NS. 171. M8870338 Fast Track to SCSI. AC characteristics, continued. DMA access cycle time. DREQJ. LDRRP LRPORI old. DRISP. LRPSW. IRCYL. DREQL DRISP LTOLRP. Dash. RIALRP. LRCY2. Note, *1, this parameter is applicable when the data buffer hold function or the transfer pause. NS. Command is used and DREQ goes low asynchronously to DRISP. Under these conditions, data cannot be written to the data buffer until TDLRP and TRPSW are satisfied. 172. Fast track to SCSI MB87033B. AC characteristics, continued. HIN. TTQ. LHLHO. HDB7-0P. Parameter. Values. Designator -RT. Min tip max. HIN WDMA bus output TH105 CLF40. HIN LDMA bus high ZTHIHZ5 CLF40. DMA transfer, 1, data input from SCSI. DREQ. DRISP. HDB7-0P. Output. To RDB. ILFL LLLLTTLTLLLIII colon colon colon, LTLILT1 2LL colon III colon 111I. Dash 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 dash. Note, *1, this parameter is applied when the internal data buffer goes not empty. From empty. Unit. NS. NS. 173. M8870338 Fast Track to SCSI. AC characteristics, continued. 174. DRISP. HDB7-0P. Input. Underscore 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 G. TJ. Underscore 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 underscore. K underscore underscore D underscore BS. Underscore underscore underscore. underscore 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 dash. Fast track to SCSI M8870338. June 5, 14 selection, 1, initiator, with arbitration. BSY. TBFBL. TBLSL. SLSH. TLOBH. SEC. TBLO underscore 14 TSIOA. UB70PIK. C equals 1 ITF1. Item symbol min. Tip. Max. Unit. Bus free BSYL1 TBFBL, 6 plus N, ELF, 7 plus N, ICLF plus ADNS. BSYL, sends its own, SLLO 1060 NS. 10-bit. BSYL cell LTBLSL 32 TCLF-40 32 TCLF plus 30 N6. SECL 10, 1 ITF1 TSIOA 11, ELF-30 11, ELF-60 NS. Send. 10 send BSYHTLOBH2 ICLF 62, ELF-30 NS. BSYLSECH. 10 TBLSH2 LCLF3 TCLF plus 120 NS. Hold. Note 1, N equals tel register setting. 175. M8870338 fast track to SCSI. June 5, 15 selection, 1, initiator, with arbitration. Tal SH. Item symbol min. Tip. Max. Unit. Bus free 10 send LIFRID, 6 plus N, ELF, 7 plus N, TCLF plus 100 NS. 10 send BL, JITNLTLDSL 11, ELF-60 11, ELF plus 40 NS. 8 SYLSEIH.IO hold TBLSH 21 CLF3, ELF plus 120 NS. Note, LN equals tel register setting. 176. Fast track to SCSI M8870338. June 5, 16 selection, 3, target, with arbitration. BSY. /V. TSLBH TSLBH ISLSH. SEC, dash. V. / TLOBH. Dash IJO. OB7-0P, K. TSHPH. 170, C7, / Item symbol min. Tip. Max. Unit. Set LBSYHTSLBH0NS. 10 confirmation BSYH. TLOBH0NS. IOHBSYHTLOHB0NS. LRNYHBSYI, TBHBL4 TCLF5 TCLF plus ADNS. BSYLSEHTBLSH0NS. BSYL10 hold IJO. 30 NS. Set H phase signal output TSHPH3 TCLF4 TCLF plus 100 NS. 177. M8870338 fast track to SCSI. June 5, 17 selection, 4, target, without arbitration. TSLBLT, dash. Item symbol min. Tip. Max. Unit. 10 confirmation cell L. TLDSL0NS. 1/0HSEILTLOHS0NS. SEILBSYLTSLBL2 TCLF3 TCLF plus 100 NS. 8 SVL-CEL-H-LA-LSH-NS. 8 SVL10 hold TBLID-NS. Cell H phase signal output TSHPH3 TCLF4 TCLF plus 120 NS. 178. Fast track to SCSI M8870338. June 5, 18 reselection, 1, target. J. Dash, dash. BSY/V. 1 plus TBFBLTSLSLI. Set. TLKBHTBIBOTSOSH/ TSUD. / TSIDP. UB7-0F. / 110. CU. / Item symbol min tip max. Unit. Bus free BSYL *1 TSFBL, 6 plus N, ICLF, 7 plus N, TCLF plus 80 NS. BSYL, sends its own ID bit TBUD10 NS. BSYL SELTSLSL 32 TCLF 40 32 TCLF plus 30 NS. SELID, phase signal. SLOP 11 TCLF 30 11 TCLF plus 60 NS. Send. ID send BSYHTLDBH 21 CLF 62 TCLF plus 30 NS. BSYL BSVL send TSLBO2 TCLF 3 TCLF plus 90 NS. BSYL send solid hold TSOSH TCLF, 20 TCLF plus 60 NS. Note, *1, N equals tel register setting. 179. MBB 7033B fast track to SCSI. June 5, 19 reselection, 2, initiator. V \SSI. ITSLBHTEHBLTELSH. TSHBB. SIT. / TLOBHTBUO. UBIOPK. K. / TB. ITBLIO. I. 170V. / Item symbol min. Tip. Max. Unit. SIT L4 SSIH TSLBH0 NS. 10 confirmation for SSIH. TLOBH0 NS. 1/0 L4 SSIH TOLB0 NS. SSIH 48 SYLTEHBL4 TCLF5 TCLF plus 80 NS. BSVL4 cell HTELSH. 0 NS. BSYT4M hold TE Leo. 30 NS. SSIL4 1/0 signal hold TUO. 20 NS. Set H4 BSYL send stop TSHBO2 TCLF3 TCLF plus 100 NS. 180. Fast track to SCSI MB87033B. June 5, 20 asynchronous transfer initiator, 1, REQAC timing. Track 1. Rio. / Drake. ITTRAOL, TAOLR AC. / V. / Track 2. Item symbol min. Tip. Max. Unit. *3 Rio LJIXRLTRAOL 1590 NS. JIXRL Rio HTAOLR0 NS. *3 Rio LJIXRH Trake 15100 NS. AC H Rio LTAOHR 10 NS. *1:3 Rio HAC L Track 1. 2 TCLF 3 TCLF plus 120 NS. *1:3 Rio HAC H Track 2. 2 TCLF 3 TCLF plus 130 NS. Notes, *1, the time for Rio HACL is determined by the longer of, Trake plus TACHR plus IRAOD and Track 1. Asterisk 2, apply for input operations. The time of REOL ACH is determined by the longer of TRAOL plus TAOLR plus Drake, and IRAC1. Asterisk 3 The times assigned in this section do not apply in the following cases. 1. For output operations, if the data buffer is empty. 2. For input operations, if the data buffer is full. 3. During transfer of the first or last byte. 4. During input operations, when the SBC automatically sends the trill signal. 181. M8870338 Fast Track to SCSI. June 5, 21 Asynchronous Transfer Initiator, 2, Output Operation. REO \v /ACR v /RDVLDRDIVDRAHPHJ R RPHRL UB7-0PKV /3 TL/TII2 I //1111,1 Tude 170 // J // CLD NLSG /J/L Item symbol min tip max unit 170H data bus output 210 NS phase designation REO LTPHRL 100 NS data bus output TOVLO 2 LCLF80 NS confirmation 7 CKL REO H data bus hold TDIVD 15 NS 1 \CKH phase change TAHPH 10 NS 182 Fast Track to SCSI MB87033B June 5, 22 Asynchronous Transfer Initiator, 3, Input Operation REO \AC/ TAHPH I TLLDUTDTSU I TDHLD UB7-0 P /K/V //TPHRL I 170 \V /M mu \V V J/IL item symbol min tip max unit 170 L data bus output stop LJLDD 110 NS phase designation REO LTPHRL 100 NS data bus confirmation REO LTDTSU 10 NS AC L data bus hold TDHLD 15 NS AC H phase change TAHPH 10 NS 183 MB87033B Fast Track to SCSI June 5, 23 Asynchronous Transfer Target 1 REQ AC Timing REO \V / TROHA ITROLA TROLA TROLA ACR / Tracy item symbol min tip max unit REO L ACRL TROLA 0 NS AC L REO HTAROH 1090 NS REO H AC H TROHA 0 NS AC H REO L2 TAROL 10 70 NS AC H REO L1 2 Tracy 21 CLF 3 TCLF plus 110 NS. Notes, 1. The time for JMKLREQL is determined by the longer of YARO plus TROHA plus TAROD and 184. Tracy. 2. The times assigned in this section do not apply in the following. 1. For output operations. If the data buffer is empty. 2. For input operations, if the data buffer is full. Fast track to SCSI MB87033B. June 5, 24 Asynchronous transfer, 2, output operation. To VLD. Toll VD. US 7-0F. Item symbol min. Tip. Max. Unit. 170I-4 data bus output TODE 7 TCLF 8 TCLF plus 110 NS. Data bus output. To VLD 2 TCLF, 80. NS. Confirmation-4 AML. ACL-4 data bus hold toll VD. 15 NS. 185. M8870338 fast track to SCSI. June 5, 25 Asynchronous transfer target, 3, input operation. TOHLO. Item symbol min. Tip. Max. Unit. 170H data bus output stop TTOOD 60 NS. Data bus confirmation 7/CKL torso 10 NS. Rio H data hold TOHLO 15 NS. 186. Fast track to SCSI MB87033B. June 5, 26 Synchronous transfer initiator, 1, REQ/ACK cycle. TROF2. TROF1. TROAR. TRNAP. Rio. V/R. /ACK//. TAKAP TANAP. Item symbol min. Tip. Max. Unit. Rio assertion period TROAP 50 NS. Rio non-assertion period TRNAP 50 NS. Rio cycle time TROF1, ELF NS. Rio cycle time TROF2 3, ELF NS. ACK assertion period TAKAP, ELF, 10 NS. 1 ACK non-assertion period TANAPN. ELF, 30 NS. Note, 1N depends on the TMOD register setting. TMOD register. BLT 3 bit 2N. 001. 012. 103. 114. 187. MB87033B fast track to SCSI. June 5, 27 Synchronous transfer initiator, 2, Rekiak timing C2. DREO underscore 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 DRISP. Item symbol min. Tip. Max. Unit. ARN assertion delay time, 1L * 1 TAOLL 3 TCLF 4 TCLF plus 100 NS. L1EOLDREOH2 TRLOR TCLF plus 53 TCLF plus 60 NS. ACK assertion delay time, 2, * 3 TAOL2 3 TCLF 4 TCLF plus 120 NS. Notes 1, apply to output operations and to input operations when the maximum offset value is 4 or less. * 2, apply to input operations. * 3 apply to input operations when the maximum offset value is 5.8. This is the minimum time after receiving the DRISP of byte n, until the ACK of byte n is transferred. In this case, the minimum time required from receiving the REO of byte n until transferring the ACK of Byte N is, TORESP plus, DRISP assertion time XL plus TALO 2L. 188. Fast track to SCSI MB87033B. June 5, 28 Synchronous Transfer Initiator, 3, Output Operation. 189. M8870338 Fast Track to SCSI. June 5, 28 Synchronous Transfer Initiator, 3, Output Operation, continued. Item symbol min. Tip. Max. Unit. 170H Data Bus Output TLLOE 10110NS. Phase Designation RRNLLPHRQ 100NS. Data Bus Output 1 TOVA 12 TCLF, 70. NS. Confirmation ACL2 IOVA2N.LCLF, 60. ACL Data Bus Hold IACO ICLF, 20 NS. ACH Phase Change TAHPH 10 NS. Notes, 1 N depends on the TMOD register setting. 2 The time from data bus output confirmation to ACL is set by the shorter of TOVA 1 and IOVA2. TMOD register. Bit 3 Bit 2 N. 001. 012. 103. 114. 190. Fast track to SCSI MB87033B. June 5, 29 Synchronous Transfer Initiator, 4, Input Operation. 14-TPHRO Tool. TOTSUTOHLO. Item symbol min. Tip. Max. Unit. 170H Data Bus Output Stop TLLOO 110 NS. Phase Designation REALTPHRO 100 NS. Data Bus Confirmation REAL to TSU 10 NS. ACL Data Bus Hold TDHLO 40 NS. ACH Phase Change TAHPH 10 NS. 191. MB8703338. Package dimensions. 80 lead plastic flat package. FPT 80 PM01. 192. Fast track to SCSI. Fast track to SCSI. Men's ions in. 0.077 plus 0.008. 1.95 plus 0.20. I has, MEM 1 ERS. MB8703338. So lead plastic flat package. Case no, FPT SOP mole. 0.705 plus 0.016. 17.90. 0.40. Max max. LR. 0.016, 0.40. RLI. T3. F. 0.031 plus 0.008. 0.80 plus 0.20. View 193. MB87033B. Package dimensions, continued. 84 lead plastic leaded chip carrier. 194. TBD. LCC 84 PM01. 84 lead plastic leaded chip carrier. Case no, LCC 84 PM01. TBD. Fast track to SCSI. General description. MB89351. SCSI Protocol Controller. The Fujitsu MB89351 Small Computer System Interface, SCSI, is a system protocol controller, SPC, specifically designed to implement a SCSI bus to CPU/DMAC interface. Except for SCSI synchronous mode transfers, the MB89351 can handle virtually all interface control procedures of the SCSI bus, and the SPC is adaptable to either an 8-bit or a 16-bit. CPU. To optimize efficiency and reduce CPU overhead, the MB89351 uses an 8-byte FIFO data buffer register and a 24-bit transfer byte counter. The SBC serves a wide range of applications, acting as an initiator or target device for the SCSI. Thus, the device can be used as an I/O controller or as a host adapter. The MB89351 SBC is fabricated in silicon gate CMOS and housed in a 64-pin plastic shrink dip or a 64-pin plastic flat package. SCSI compatibility serves as either initiator or target. DMA interface and parity check. Data transfer rate / byte counter. Up to 2.5 megabytes per second. 8-byte FIFO data buffer. 24-bit transfer byte counter. Drive options. Single-ended. Differential. Selectable transfer mode. DMA interface. Program transfer. Manual transfer. Clock requirements. 8 MHz clock with 33% to 66% duty cycle. Technology / power requirements. Silicon gate CMOS. Single plus 5V power supply. Available packaging. 64-pin plastic shrink dip, suffix PSH. 64-pin plastic flat package, suffix PF. 195. M889351 Fast Track to SCSI. Absolute maximum ratings 1. Values. Rating designator unit. Min. Max. Supply voltage VVSS-05 VSS plus 7.0 V. Input voltage 2 VEN VSS-05 VSS plus 7.0 V. Output voltage 2 VOUT VSS-03 VSS plus 7.0 V. Operating ambient temperature TA 0 plus 70 degrees C. Storage temperature TSTG minus 55 plus 150 degrees C. Notes. 1. Permanent device damage may occur if the above absolute maximum ratings are exceeded. Functional operation should be restricted to the conditions as detailed in the operational sections of this datasheet. Exposure to absolute maximum rating conditions for extended periods may affect device reliability. 2. Should not exceed V plus 0.5 V. Recommended operating conditions. Values. Parameter designator unit remarks. Min. Tip. Max. V 4.755.05.25 V. Supply voltage. VSS 0 V. Operating ambient temperature TA 0 plus 70 OC. 196. Fast track to SCSI MB89351. MB89351 block diagram. D7 do equals DP. AC. ADN. VO. CLD. Message. RSTO. .opo. RSTILJ-.j:\LT equals 1. Cell MM RP. CR RST plus R___intr address decode and MPU interface interrupt N status 197 MB89351 pin assignments and interface diagram SOBI 710 VCC VSS SOBI 62 CLK0 AC SOBI 53 RST ARIA SOBI 44 CSINTR, SOBI 35A3WR, SOBI 26 VSSAD, NC 7, NC, OPO, SOBI 18A2 OP, SOBI 09A1 DO, SOBIP AD01, SOB 070702, SOB 060S03, SOB 0505D4, SOB 04D405, SOB 0303OS, SOB 0202, SOB 0101, SOBA2A1, SOBOP A2, RSTO20 OPO, RSTI21 RO, Cello 22 \VA SCSI bus, plus 5V, Cell 23 INTR interface, BSYO24 ARIA, BSYI25 I5 AC, SOBI 7-50 BIP, IO26 VSS, V, C/027, NC, SOB 07-5 DBOP, Message 28, NC, Rio 29 Init RSTI, 30 Targ RSTO, 31 Input 2 Cell MB89351, VSS 32 Input 1 SELD, BSYI, BSYO, IO, C/O, Message, Rio, Init, Targ, Input 1, Input 2, AC, ADN, 198, Fast Track to SCSI, BSYI, BSYO, Cell, Cello, RSTI, RSTO, SOBOP, SOBOP, SOB 01, SOB 02, SOB 03, SOB 04, SOBOS, SOB 06, SDB 07, STBIP, SOBIO, SOBI 1, NC, CPLOMAC, Interface, 07DP, ARIA, 5ACI, INTR, OPO, Fast Track to SCSI MB89351. Pin descriptions. Pin no. Designator function. DIP FPT. V. 6425 plus 5V power supply. VSS 3239, 59 1, 20, 59 circuit ground. CIK 6324. Clock input for controlling internal operation and data trans. For speed of the SBC. FIS 6223, asynchronous reset signal used to clear all internal circuits of the SBC. 6122, input selection enable signal for accessing an internal regis. ES-tar. When active low, the following input/output signals are valid, RO, WR, AOA3, OPODP7 and up. A 36021 address input signals for selecting an internal register in a 25719 SBC. MSB is A3, LSB is AO. A 15618. AO 5517 when CS is active low, read. Write is enabled for an internal register selected by these address inputs via data bus lines 00-07 and up. The red strobe, RO, input is used to read out the contents of an internal SBC register and is asserted only if CS is active low. The register to be read is specified by AOA3, the input add RU 446. Address data is input via 00-07 and up. In the program transfer mode, the falling edge of RU termi Natees the data read cycle. The write strobe, WR, input is used to write into an internal SBC register and is asserted only if CS is active low. On the falling edge of WR, the data present on 00-07 and up is loaded into the internal register specified by AOA3, X. WR435. Except when AO equals A1 equals A2 equals A3 equals H. In the program transfer mode, the falling edge of WR indicates a data-ready condition to the MPU. 199. MB89351 Fast Track to SCSI. Pin descriptions, continued. Pin no. Designator function. DipFPT. Used to write/read data toll from an internal register in the SBC. The data bus is 3-state and bidirectional. The MSB is 07 and the LSB is 2, DP is an odd parity bit. D7 DP 54 to 45 16 to 8 when both CS and RIG inputs are active low, read operation. The contents of a selected internal register are output to the data bus. In operations other than read, the data bus is kept at a high impedance level. DPO 45-7 outputs an odd parity for 00-07. If parity bit is not generated for external memory, DPO can be used as an input parity bit for DP. The INTR output signal is issued by the SBC and requests an interrupt to indicate completion of an internal operation or the occurrence of an error, except for an interrupt caused by the RSTI input reset condition in SCSI. Interrupt masking is allowed. INTR 42 for when an interrupt request is granted. The INTR signal remains active until the interrupt is cleared. In the program transfer mode, the INTR signal can be used as a data request signal instead of reading internal registers of the SBC. The data request function is enabled by proper settings of the appropriate registers. The INTR signal is automatically disabled when interrupt conditions are not present. When the MB89351 is operating in the DMA mode and the data request, DREO, output signal is active high. Data is DREO 41-3. Transferred between external memory and the SBC or vice versa. During output operations, DREO is active when the data buffers in the SBC are not full. During input operations, DREO is active when valid data is present in the buffers. In either case, DMA transfers can occur and DREO is asserted. An active low response signal to the DREO which request data transfer between SBC and the external memory in the DMA mode. This signal, in DMA mode, functions similarly to UACL \. The signal combination of CS equals low, A3 equals high, A2 equals low, 42A1 equals high, and AO equals low, selection of DREG, in the program transfer mode. Since the DREG is selected by this UACL \. signal in the DMA mode instead of the address input from A3AO, data transfer between DREG of SBC and external memory is possible. 200. Fast Track to SCSI MBB 9351. Pin descriptions, continued. Pin no. Designator function. DipFPT. SOBI 7 SOBI 61, 227, 28 inputs from the SCSI data bus. The MSB is SOBI 7, the LSB SOBI 5 SOBI 43, 429, 30 is SOBIO. SOBIP is an odd parity bit parity checking for the SOBI 3 SOBI 25, 631, 32. SCSI data bus is programmable. SOBI 1 SOBI 08, 934, 35. SOBIP 1036. SOB 07 1137 outputs to the SCSI data bus. The MSB is SOB 07, the LSB. SOB 06 1238 is SOBOP. SOBOP is an odd parity bit. An open collector. SOB 05 1339. SOB 04 1440 bus driver is used to connect the SCSI bus. SOB 03 1541. Note, for the SOBI and SOSO pin groupings, only one. SOB 02 1642. SOB 01 1743 pin is used for output and the other pins are used for SOBO 1844 input during arbitration. During selection, are elect LON. SOBOP 1945. And normal data transfers, all pins are used for outputs. Typical system connections are shown in the pin as assignments and interface diagram. RSTI is a reset input from other SCSI devices. RSTO is a RSTO, RSTI 20, 2146, 47. Reset output to other SCSI devices. Both signals are active, high and can be masked. Cello is an output that corresponds to the initiator or Cello SELI. Target device, cell inputs the response to the SBC dir. 22, 2348, 49ing the selection or reselection phase. Both signals are AC. TIV high. BSYO indicates the SCSI bus is in the output mode of op. Eration, whereas BSYI indicates the bus is operating in the BSYO BSYI 24, 25 so 51 input mode. One or the other of these signals is active high during arbitration and in the connected status mode of operation. During the data transfer phase, the \0 signal indicates the \0 2652 transfer direction. When 110 is high, data is transferred from the target to the initiator. When \0 is low, data is transferred from the initiator to the target. During the data transfer phase, the C/O signal is set high. C/O 2753 during the command dash, status dash, and message phases of operation. In the data transfer phase, the message signal is set high only. Message 2854 during the message phase. 201. MB89351 Fast Track to SCSI. Pin descriptions, continued. Pin no. Designator function. DIP FPT. In the data transfer phase, the RIO signal is used to notify RIO 2955 the initiator that the target is ready to receive or send data. The RIO input is used as a timing control signal in the data transfer sequence. These two output signals indicate the operational status of the SBC. The init and targ outputs can also be used as SCSI driver circuit control signals. Init targ SPC status. init.targ 363563,62 logically disconnected from the SCSI. LH executing the reselection phase or operating as a target. HL executing the selection phase or operating as an initiator. These two outputs are directly related to the preceding init and targ signals. Input 1 corresponds to init and in. Input 1 input 2 33 34 60, 61 put 2 corresponds to targ. However, unlike init and targ, input 1 and input 2 are set high when the SBC is not logically connected to the SCSI. In the data transfer phase, the acknowledge signal is in R and ACK 3056. Response to a transfer request, REO, signal from the target. In the same way as REO, an ACK input is used as a timing signal in the data transfer sequence. Except during arbitration and during the bus-free phase, the ATN 3157 ATN signal is used to notify the target that the initiator has a prepared message. NC 737, 33,64. No connection. 38,58. Open, 26,58. 202. Fast track to SCSI MB 89351. Addressing of internal registers. SBC has internal registers consisting of 17 bytes that are accessible from an external circuit. These internal registers are used for controlling SBC internal operation and indicating SBC processing status/result status. A unique address is assigned to each internal register, and a particular register is identified by address bits A3 to A0. The following table shows internal register addressing. Internal register addressing. CSA3A2A1A0 operation register name ABBR 00000 read/write bus device 10 bold 00001 read/write SBC control SCTL 00010 read/write command SCMD 00011 open read interrupt sense 00100 ints write reset interrupt read phase sense PSNS 00101 write SBC diagnostic control SDGC read SBC status 00110 SSTS write read SBC error status 00111 SER write 01000 read/write phase control PCTL read modified byte counter 01001 MBC write 01010 read/write data register DREG 01011 read/write temporary register temp 01100 read/write transfer counter high TCH 01101 read/write transfer counter middle TCM 01110 read/write transfer counter low TCL 203 MB 89351 fast track to SCSI bit assignments. The following table shows the bit assignments to each internal register. When accessing an internal register, in read/write, remember the following. 1. The internal register block includes the read-only/write-only register and those having different meanings in read and write operations. 2. A write command to a read-only register is ignored. 3. If the write-only register is read out, the data and parity bit are undefined. 4. At bit positions indicating _ for a write in table 3.2.2, either one of 0, or may be written. Bit assignments for internal registers. Register RIW. Hex and OPER 765432210 parity. Address mnemonic alien, MSB, LSB. Bus R number 71 #61 number 5. 1 number 4. 1 number 3 1 number 2. I. Number 1 I number 00. 0 device 10. Bold, WGJI BUSPSELC D1. SBC reset con diagram. Arbit parity select resel int. 1 control al W and distrol EETP. SCTL, able reset mode enable. Command. RST inter transfer modifier term. SCMD, AIW command code. Sept PRGI mode P. 2 outs first for 0. 3. R. W. Interrupt select resol discon sevas time SBC reset. Sense. R. MAND re hard kindi. P. 4. Ins, ted ected necht comp quired out errortion. Plit. W reset interrupt. Phase. Sense. R Rio AKDN cell BSY message C/0110p. PSNS. 5. SBC diagrams for control. Diagram. 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 SOGC, W Rio. ACK enable BSY message C/0110. SBC R converted SBC XFER SCSI DC equals ODREG Aritus. Status in Pro P. 6, SSTS, init targ BSY gress RST full empty. 204. Fast track to SCSI MB89351. Bit assignments for internal registers, continued. Register RFW. Hex and OPER 765432210 parity. Address mnemonication, MSB, LSB. SBC data errors for TC short. Error R0 parity 00. P. Status. SIR. SCSI SBC out error period. Bus. Phase free transfer phase. Control R, W inter. 0. PCTL. Message. I. C/O. 1. 1/0. P. 8 rupt. Enable out. Modified MBC. Byte. R0. P. 9 counter. MBC. Bit 3 I bit 2. I bit libito. Data internal data register, S byte FIFO. Register. Bit 7 I bits. I. Bits. I. Bit 4. I. Bit 31 bit 2 I bit li A, DREG, R, W bito P. Temporary R temporary data, input, from SCSI. B register bit. I bit 4 J bit 3 I bit 2 I bit libito P. Temporary data, output, from SCSI. Temp, W bit. I bit 4 I bit 3 I bit 2 I bit libito P. Transfer. C counter R, W transfer counter high, MSB. High. Bit 231 bit 221 bit 2 LL bit 20 I bitl bitless I bitl, 1 bit 16, TCH, P. Transfer. 0 counter AI transfer counter high, second byte. Mid W. Bitless I bit 141 bit 131 bit 12 I bitl bit 101 bit 9 I bits, TCM, P. Transfer. E counter R, W transfer counter high, LSB. Low. Bit. I. Bits. I. Bits I bit 4 I bit 31 bit 2 I 1 bit I, TCL, bito P. Extemal R. F buffer. Bit. I bit 6 I bits. I. Bit 4 I bit 31 bit 2. I. Bill I, EXBF, W bito P. 205. MB89351 fast track to SCSI. DC characteristics. Recommended operating conditions unless otherwise specified. Values. Parameter designator conditions unit. Min. Tip. Max. Input high voltage VIH 2.2 VCC plus O.SV. Input low voltage VIL VSSO.S 0.8 V. Output high voltage VOH equals 04 RNA 4.0 VCCV. Output low voltage VOL IOL equals plus 3.2 Ma VSS 0.4 V. Input leakage current ILVN equals OV to S.2 SV minus 1020 RNA. Output leakage current is N equals OV to S.2 SV minus 4040 RNA. Active supply current ICC. FC equals 8 MHz. 10 RNA. All outputs open. FC equals 8 MHz. Standby supply current ICS all outputs open. Inputs fixed, RST active. 40 RNA. 206. Fast track to SCSI MB89351. AC characteristics. Recommended operating conditions unless otherwise noted. CPLD-MAC interface. Values. Parameter designator unit. Min. Tip. Max. CTK cycle time TCLF 125 200 OS. CTK high time TCHCL 44 OS. CTK low time TCLCH 44 OS. CTK rise time T 10 OS. CTK fall time T 10 NS. CJ input timing 14 1. TCHCL I 11. CTK 2.4 V Y 2.4 V 0.45 V 11 0.45 V 1111 I 14 HCH I 11 14 HF I 207 MB89351 fast track to SCSI. AC characteristics, continued. Parameter designator TT-T. Min. Tip. Max. Unit. RST pulse width 100 ns. AST input timing 0.45. Underscore dash IO 45V 14 dash TRSNW TJLI1 208 Fast track to SCSI MBs 9351 AC characteristics, continued. Address setup time TARS 40 ns. Address hold time TARH 10 ns. CS setup time TCRS 25 ns. CS hold time TCRH 10 ns. Data valid time, from AD low, TRLOCL equals ADPF 90 ns. Data hold time, from AD high, TRHOCL equals 20 PF 1060 ns. AD pulse width TRO 120 ns. Register read timing. AOA3I2-4V-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2-2- underscore 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 ITII Rs I TARH II 0.45 T.45b LCRSI TRO dash dash plus L 1 LCRH underscore 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 IIIIRL 2.4 IL T 2.4 V 0.45 V 0.45 V I low I dash 2 dash point 4 V dash 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 dot 1 2.4 V dash valid dash 0.45v 0.45v. Do D7 DP 209 MB89351 Fast Track to SCSI. AC Characteristics, continued. Parameter Designator Test Conditions Unit. Min. Tip. Max. Address Setup Time TAWS 40 ns. Address Hold Time TAWH 10 ns. ES Setup Time TCWS 25 ns. CS Hold Time TCWH 10 ns. Data Valid Time, from WR Low, TOS 30 ns. Data Hold Time, from WR High, to WH 20 ns. WR Pulse Width Tau 100 ns. Register Write Timing. ______ -I. Backslash, F2.4v 2.4vv. ____ J. A. 0.45v 0.45vf backslash, _________________ IT 14. AWS. Point 1. TA. ADA 3. I11. 0.45. 45 VI. III. ICOS 1. 4-WR-.1 ICOH. 1I. 2.4 1. 1. 2.4v. 0.45v1 backslash, I 0.45v. TID. 14 AUS 14 DWH. 1. WR. 1I. Do D7 DP ______________________________________________________________________________________________________________________ _______________________________________________________________________________ 0.45v 0.4s slash 210. Fast Track to SCSI MB89351. AC Characteristics, continued. Values. Parameter Test Conditions I plus -2 I unit. Min. Tip. Max. OPO Valid Time, from 07-0010 OPO Valid, IDCL equals 30 PF 60 NS. OPO Output Timing. 00-07 \::yen 2.4v. ___________________ I 0.45v. 14 low PVDI. _______________________________________________________________________________________________________________________ _______________________________________________________________________________________ MB89351 Fast Track to SCSI. AC Characteristics, continued. Values. Parameter Designator Test Conditions Unit. Min. Tip. Max. WR Service Time, from INTR high to 0. NS. WR high, TLAWL. INTR Release Time, from WR high to interlow. TWHIR. CL, 10 PFBLF2 TCLFI 100 NS. INTR Reset Cycle Time TWRCY4 TCLFNS. Note, applicable only when interrupt reset is executed. INTR Output Timing. I 0.45 \:1. 2.4v. INTR 14. TLRWL. 114 2. I IWR. 0.2.4v. J2.4v. /4 TWRCY. 212. Parameter Designator Test Conditions Unit. Min. Tip. Max. DAC Service Time TOHAL0NS. From DREO high to OACR low. WR and RU service time. TARWL40NS. From OACR low to WR or RU low. DREO release time. CL equals 30 PF 35 150, from WR or RU low to DREO low, TAWOLNS. OACK hold time. TAWAH 10NS. From WR or RU high to OACK high. DREQ interval. JOLD 0NS. From DREO low to DREO high. DREG access cycle time, 1, TAWCY2 TCLFNS. DREG access cycle time, 2, TDMCY3 TCLFNS. When data buffer register will be full, the M parameter is applicable. Be empty. DMA access timing. I. R. Low LOH dash underscore 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 TRL 2.4 V backslash E 24 V slash 0.45 V1 Ali I 14 TAWOL I DREO dash dash 11 0.4 T dash underscore 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 slash T 4 underscore 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 backslash underscore dash underscore 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 TARWL I 0.45 VWR RU 1 underscore 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 dash yen 2.4 V backslash 2 backslash F 0.45 V backslash dot underscore dot equals equals R 0.45 V 0.45 TRWCY underscore I 14 to MCY dash dash 1 213 MB89351 Fast Track to SCSI. AC Characteristics, continued. Parameter Designator Test Conditions Unit. Min. Tip. Max. RU Service Time, IHRL0NS. From INTR high 10 RU low. INTR Release Time. TRHILCL equals 20 PF 35 150 NS. From RU high 10 INTR low. INTR Recovery Time. From INTR low 10 INTR high, TLLIH. 0 NS. RU Recovery Time. TRHRL 50 NS. From RU high 10 RU low. DREG Access Input. 1 dash dash 14 I.1 dash underscore 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 T2.4 V backslash dot LLIH if 2.4 V INTR dash dot slash II0 45 V LG IRLI plus dash plus II 0.45 V 214 Fast Track to SCSI. AC Characteristics, continued. Parameter. WR Service Time. From INTR high to WR low. INTR Release Time. From WR low to INTR low. INTR Recovery Time. From INTR low to INTR high. WR Cycle Time. Designator Test Conditions. TLHWL. TWLILCL equals 20 PF. TLLLH. TWRCY. DREG Access, Output. I plus TLL1H2. MB89351. Unit. Min. Max. 0 NS. 35150 NS. 0 NS. 2 TCLF NS. INTRI. IR. 2 4V. 0.45. II. II. WR. I. TWLLLI4TI. I. X.0.45V. I plus T. IHWL. Plus. I. X45V. Underscore. O:4:5V equals dot X45V. 141-T. WRCYI. 215. MB89351 Fast Track to SCSI. AC Characteristics, continued. Parameter Designator Test Conditions Unit. Min. Max. Input to valid time. TLH2LCL equals 30 PF020 NS. From init high to input to low. Input to invalid time. CL equals 30 PF minus 2020 NS. From init low to input to high. TLL2H. Input 1 valid time. From targ high to input 1 low, TTH1L. CL equals 40 PF020 NS. Input 1 invalid time. CL equals 40 PF minus 2020 NS. From targ low to input 1 high. TTLTH. Init targ and input 111 NPUT2 output timing. INIT and INPUT2 output timing. Init. Dash dot. IJ. Input 2. In init mode in targ mode. Targ and input 1 output timing. Targ Y dash, 0.45V. HTTHILJE.ITTLIH. II. I.4V. 0.45V. I. Input 1. In init mode in targ mode. 216. Fast Track to SCSI M889351. AC Characteristics, continued. SCSI Bus Interface, Selection Phase Timing. Values. Parameter Designator Test Conditions Unit. Min. Tip. Max. Bus free time to IBFR 41 CLF plus 50 NS. From BSYI low to BSYO high if BO CL equals 10 PF. CL. X1, L, 60. NS. From BSYO high 10 device 10 out TBHID CL equals 30 PF 060 NS. From BSYO high 10 prioritize TARB 32 TCLF minus 60 NS. From DAM bus valid 10 prioritize TAIOV 100 NS. RTGG8SH permission gran led TAWSOCL equals 10 PF 050 NS. WePut. High to select 10 TSOIOCL equals 30 PF 11 TCLF 30 NS. From Cello high I init high XOR CL.10 PF 111 CLF. From init high to ant high TRRATCL equals 10 PF 060 NS. From select 10 output to BSYO low IIDBLCL equals 10 PF 2 TCLF minus 80 NS. From BSYO low I BSYI low I, CL 10 PF 0 INS. From BSYI high to BSYO low I by SOCL equals 10 PF 21 CLF 31 CLF plus 60 NS. From BSYI high to so low IBIT CL equals 10 PF 21 CLF NS. From SOW low 10 INTR high is RCL equals 30 PF 60 NS. CL equals 30 PF, BSYO. From cell high to BSYO low, 10-bit low ISRCL equals 3031 M plus 100 NS. BUSOB 07. OBOP. CL equals 30 PF, BSYO. From priority judge to BSYO and 10 IPRCL equals 30 TS80 NS. Below BUSOB 07. OBOP. Notes, 1 N equals value of tel register. 2 The bus free time is the minimum time interval until the book select command is executed. 217. MB89351 Fast Track to SCSI. AC characteristics, continued. BSYI. BSYO. Cell. Cello. I. Initiator with arbitration timing. IBFA. \YIJ. TSBCR \2. ITBOBI.AI -- plus -IBFBORH111. Underscore 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 JF -- colon -L colon -dash I. 3 PBCI2. 20 BL. III. 1-II/RT1-T-- I. T. 1 TBISO. III. 1 underscore TIITAWSOI, 1. Rs I. III plus I plus I, 2 comma dot I. ILFI I. I2II. I2II. I2IITSOIOII. TSHIO1 plus 1 III. ITBIOLTOL T1. SPO SDB07, underscore 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 dash, I. IRT. SPOP. Asterisk. 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 L. SBOSDBI7. SBIP. IO. Init. ATN. ITAIDV. III. Dash comma asterisk. X. II. Input state, II. Underscore 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 plus underscore 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 J underscore 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 I. 14 TSOIT. J. Underscore 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 on R dash. TLTAT. I.T dash dot I. JN.PS underscore 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 I dash dash dot dash I TSCIR 14 plus 1 underscore 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 on RLLINTR, command complete, underscore 218. Fast track to SCSI MB89351. AC characteristics, continued. Parameter designator test conditions unit. From BSYI low to select 10 output TFRIOCL equals 30 PF. 7 plus N. NS. XTCLF plus 60. From 10 output to cello high TLOSOCL equals 10 PFNS. From 10 output to init high TULI TCL equals 10 PFNS. From init high to ADN high TLTAACL equals 10 PF060NS. From BSYI high to cello low TBISOCL equals 10 PF2TCLFNS. From BSYI high to select 10 hold TSIDHCL equals 30 PF2TCLFNS. From cello low to INTR high TSCIR60NS. Note, and value of tel register. 219. MB89351 Fast Track to SCSI. AC characteristics, continued. BSYI. BSYO. Cell. Cello. Initiator without arbitration timing. IF. _____ dash I. TTLO so _F. TBIOH. T. Free 0.14. Plus. JL SBO SDB07, A, temp register, 7 / SBOP _________________ J. Dash. 1/0. Init. ADN. AC. 14 + plus J. Dash. TITM. ILPU _________________________________________________ ILPU. T. TL _____________________________________________________________________________________________________________________TSCIR1++1. JI. INTR, command complete, J. 220. Fast track to SCSI MBs 9351. AC characteristics, continued. Parameter designator test conditions unit. Min tip max. From cell high to BSYI low ISABI 0 NS. From data bus, 10, valid 10 BSYI low ID by 0 NS. From VO low 10 BSYI low in BI 0 NS. From BSYI 10 BSYO high IBABO CL equals 30 PF 41 CLF 51 CLF plus NS. From BSYO high 10 10 hold I bold 60 NS. From BSYO high 10 cell low LBOSI 0 NS. From cell low 10 targ high TSLTG3 TCLF 41 CLF plus NS. From targ high 10 phase signal O ulpol TTGPH 050 NS. From VO high to data bus enable load 7 TCLF NS. From cell low to INTR high TSUR3 TCLF plus NS. 221. MB89351 Fast Track to SCSI. AC characteristics, continued. 222. BSYI. BSYO. Cell. 1. _OJ. Target with arbitration timing. 11 TBOSI. 114 / I1I. IDBITBOID. SBOSDBI7, 111. SBIP. -- 1. TRRI, X _____________. Rio. I. /1, input state, 11. -- IJ. I1I. -- ... targ. Till. 1 if sltg.if.1ttgph dash dash lj dash l dash t dash 111 1i1 message c/d underscore 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 dash dash tl asterisk /4 dash plus 1 tllbi io dash 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 j dash spo sdb07 1 dash sbop dash r underscore j dash iiiiil f dash 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 1 tslir underscore 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 on dot jl intr selected dot j fast track to SCSI MB89351 AC characteristics continued parameter designator test conditions unit min tip max from data bus id valid 10 cell high IDC 0 ns from 1/0 low 10 cell high 11151 0 ns from cell high to bsyo high isu ocl equals 30 pf2 tl 31 clf plus ns from bsyo high 10 id hold I bolo 60 ns from bsyo high 10 cell low liacell 0 ns from cell low to targ high isult cl equals 30 pf 31 elf 41 clf plus ns from targ high 10 phase signal outpool at cl equals 30 pf 0 50 ns from 110 high 10 dollar bus enable I load cl equals 30 pf 71 elf ns from cell low to intr high ILR cl equals 30 pf 3 tclf plus ns 223 mbb 9351 fast track to SCSI AC characteristics continued 224 target without arbitration timing bsyi slash bsyo t 14 slbo.1 r dash comma dash 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 itbo si cell underscore 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 1 jl dash backslash sbosdbi7 underscore underscore dash dash fj tldsi avoid sbip underscore equals equals r underscore 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 j asterisk equals colon equals 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 underscore 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 9 underscore 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 backslash 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 input state t dash comma dash j rio rr dash t sltg tgph j slash r underscore 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 colon underscore je ej underscore 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 j dash r underscore 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 l underscore underscore tt dot comma colon dash underscore asterisk dash ilazy r dash q tjj dash ior targ message sid 110 spo sdb07 sbop ih41 dash dash imisur intr selic underscore te underscore d colon f fast track to SCSI MB89351 AC characteristics continued SCSI bus interface reselection phase timing comma dot comma colon values 1 parameter designator test conditions min tip max unit. Bus free time 2 TBFR4 TCLF plus 50 NS. From BSYI low to BSYO high TBFBOCL equals 10 PF. L, 7N, IXTCLF plus 60. NS. From BSYO high to device 10 out TBHIDCL equals 30 PF060 NS. From BSYO high to prioritize TARB 321 CLF, 60 NS. From data bus valid to prioritize TLDV 100 NS. 10 SHS, GE permission granted TAWSOCL equals 10 PF050 NS. From Cello high to reselect 10 output TSOID 111 CLF, 30 NS. From Cello high to Targ high TSOTG 111 CLF, 50 NS. From Targ high to phase signal output TMPHCL equals 3 op F050 NS. From IO high to BSYO low TL08 LCL equals 10 PF21 CLF, 80 NS. From reselect 10 output to BSYO low TIDBLCL equals 10 PF21 CLF, 80 NS. From BSYO low to BSYI low TBOBICL equals 10 PF0 TELF NS. From BSYI high to Cello low TBLSOCL equals 10 PF3 TCLF NS. From BSYI high to reselect 10 hold TBLDHCL equals 10 PF21 CLF NS. From Cello low to INTR high TSCIRCL equals 30 PF80 NS. From Cell high to BSYO and 10-bit low TSSCR. CL dot, BSYO. CL, and T comma dot, 3 TCLF plus 80 NS. 50 BOP. CL equals 3 OP, equals, BSYO. From Prioritza to BSYO and 10-bit low TPBCRCL equals 3. Degree TS. 60 NS. Baud Sob 07. OOOP. From BSYI high to BSYI high CL equals 10 PF21 CLF plus 23 TCLF plus 60 NS. TBLBO. Notes, 1N equals value of TCL register. 2. The bus free time is the minimum time interval until the book select command is executed. 225. MB89351 Fast Track to SCSI. AC characteristics, continued. Target timing. TBFR. 14.3. T. IL. TSBCR. F. TTBOBIT BIBO. BFB0LLL, dash colon dash dash J, dash 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 dot comma, dash, comma dot dash dash. J slash TRU. F. G, ITPBCRI. Plus dash 1. TLDBL. BSYI. BSYO. II dash colon, J colon dash dash colon TBL dash dash. III, ITBISO. KTARB1.LTAWOR dash plus I. F colon, L, dash dash III. ITSOIDI. Cell. Cello. TBHID 14 to plus 1 I3 TBIDH. AIISDBOSDBO7, underscore 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 R dash STBOP dash J asterisk comma dash dash dot comma L dot comma dot dash comma star dot dash I asterisk dash plus L TAIDBH SBOSDBI7 II SBIP-1 underscore 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 J M dash 226 Targ message C/D 110 dash 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 ITSOTGB. Underscore 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 I dash 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 TTGP high plus I IR underscore 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 dash plus underscore 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 L underscore 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 dash 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 underscore 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 QL underscore 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 dash 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 underscore 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 Q L underscore 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 F underscore 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 dot I underscore 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 TSCIRTT plus I INTR command complete R Fast track to SCSI MB89351. AC characteristics, continued. Values. Parameter designator test conditions unit. Min tip max. From cell high 10 BSYI low ISABI 0 NS. From data bus, ID, valid 10 BSYI low ILOBI 0 NS. From 110 high to BSYI low TLLBI 0 NS. From BSYI low 10 BSYO high ISLBOCL equals 30 PF 41 ELF 51 ELF plus 60 NS. From BSYO high 10 ID hold I bold 60 NS. From BSYO high to cell low LLLOSL 0 NS. From cell low 10 BSYO low ISABO CL equals 30 PF2 T ELF 31 ELF plus 60 NS. From cell low to 110 hold ISLIH 100 NS. From cell low to INTR high ISLIRCL equals 30 PF3 T ELF plus 80 NS. From cell low to init high TSLITCL equals 30 PF31 ELF plus 34 T ELF plus 80 NS. From init high 10 data bus enable. When 110 is low. TDECL equals 30 PF50 NS. 227. MB89351 fast track to SCSI. AC characteristics, continued. Initiator timing. BSYI. T/1. 1. 14 TSIBIT. TSLBO. Backslash. 1. BSYO 1. 1. 11. 11. 11. 14. TBOSI 14. TSIBO 1I. JII. II. Cell II. I1. II1. TBOI. 1. 1. SBOSDBI7, 11. 1. SBIP asterisk I asterisk. T by TSH. F. 11 dash 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 dash. IOTI. Init. Star. 1 TLTDE. JI. SBO SDB07. I. SBOP. TSLLRI4 plus backslash. I. INTR, command complete. J. 228. Fast track to SCSI MB89351. AC characteristics, continued. SCSI bus interface, transfer phase timing. Values. Parameter designator test conditions unit. Min. Tip. Max. From 110 low to data bus enable ~CL, 10pf10. From phase specify to Rio high tphrq 100. From AC low to phase change TALPH1CL, 10pf10. From Rio high to ATN low TRATL22TCLF. From ATN low to AC high TATLA2TCLP20. From data bus valid to AC high TOV AKCL, 10pf2CLP80. From Rio low to data bus hold TRLDVCL, 10pf15. From Rio high to AC high TRHAHCL, 10pf20. From AC high to Rio low TAHRL0. From Rio low to AC low TRLALCL, 10pf10. From AC low to Rio high TALRH10. From Rio low to AC high TRLNACL, 10pf2TCLF. From Rio high to phase change TRHPH13TCLF. Notes: 1. Phase change must satisfy both TALPH and TRHPH specifications. 2. This specification is applicable only when the last byte of the message transfer phase is transferred using the hardware transfer mode. NS. 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 229. M889351 Fast Track to SCSI. AC characteristics, continued. 230. Asynchronous transfer output, initiator, timing. Rio I_-.1. IPHRQ. 1414. AC. _____:JJT equals. Thiridi I1DVAKI. LL. SOBO SDB07. SOBOP ++. ADN. Message. C/O. IO. Iridali. 14.4i. TLA. L-:_ plus or minus. --. TALPH. 14. =***. Equals L ________________________ T dash I dash 1 dash dash dash. Fast track to SCSI MB89351. AC characteristics, continued. 1.p.iy1yt.i9r.i 9. h.p_tl, I. ::::au, : Parameter LIU, test conditions unit. Min tip max. From IO high to data bus enable TLODECL equals 10pf7 TCLFNS. From data bus valid to Rio high TDVRQCL equals 10pf2 TCLF80NS. From AC high to data bus hold TAKDVCL equals 10pf15NS. From Rio high to AC high TRHAH20NS. From AC high to Rio low TAHRLCL equals 30pf10 100NS. From Rio low to AC low TRLL0NS. From AC low to Rio high TLRHCL equals 10pf10NS. From AC high to Rio high TAHRHCL equals 10pf2 TCLFNS. 231. MB89351 Fast Track to SCSI. AC characteristics, continued. Asynchronous transfer output, target, timing. TAHRH. 14.1. F. I/F. I. REQI. I. TRHAH I TAHRLITRLALTALRHI 14 F. 14.141 backslash AC TOVRQI 114 TAKOV 14 II 8 so underscore B underscore O underscore 7 underscore 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 message CIO 1/0 232 I dash equals asterisk dash I IR underscore 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 underrun J. Fast track to SCSI MB89351. AC characteristics, continued. Parameter designator test conditions unit. Min. Tip. Max. From 1/0 high to data bus disable TLLOOCL equals 30 PF60. From phase specify to RIO high TPHRO 100. From AC low to phase change TALPH 110. From data bus valid to RIO high TOVRO 10. From AC high to data bus hold TAKOV 15. From RIO high to AC high TRHAHCL equals 10 PF 20. From AC high to RIO low TAHRL 0. From RIO low to AC low TRLALCL equals 10 PF 20. From AC low to RIO high TALRH 10. From RIO low to AC high TRLNACL equals 10 PF TCLF. From ATN high to AC low TATAL2CL equals 10 PF TCLF 20. From RIO high to phase change TRHPH13 TCLF. Notes, 1. Phase change must satisfy both TALPH and TRHPH specifications. 2. Based on this timing parameter, the ATN signal is transferred only when parity check function is enabled and a parity error is detected on the input data. NS 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 233 MB89351 fast track to SCSI. AC characteristics, continued. Asynchronous transfer input, initiator, timing. ATN, 1. Underscore dash, 1 dash 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 ITALPH. Underscore I. TRHPH dash T. 14.1. Message. Equals dash. II. C/O. 3. Asterisk. Dash colon dash. I. R1 dash I. Backslash underscore, I. IO. TLLOO. Sobosob 07, 14.1. Sobop. Underscore 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 run. 234. Fast track to SCSI MB89351. AC characteristics, continued. Parameter designator test conditions unit. Min. Tip. Max. From 110 low to data bus disable TLODDCL equals 30 PF30 NS. From data bus valid to AC high TDVAK10 NS. From Riolo to data bus hold TRLDVCL equals 10 PF15 NS. From Rio high to AC high TRHAH 20 NS. From AC high to Rio low TAHRLCL equals 30 PF10 100 NS. From Rio low to AC low TRLAL 0 NS. From AC low to Rio high TALRHCL equals 10 PF10 NS. From AC high to Rio high TAHRHCL equals 10 PF2 TCLFNS. 235. MB89351 Fast Track to SCSI. AC characteristics, continued. 236. Asynchronous transfer input, target, timing. I. TAHRH. I. Rio. I. F. I. TRHAH. TAHRL1. TRLAL.1. TALRH.1. Comma. I. FI backslash. IIRLD1 LTDVAK. AC. Asterisk asterisk. I. SBOSDBI7. SBIP dash comma. Message underscore 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 on 3 C/D L //0 backslash dash I TOD.1 SBO SDB07 SBOP dash backslash dash dash Fast Track to SCSI MB89351. AC characteristics, continued. Parameter test conditions T.TT designator. Min. Max. Tip. Unit. From WR high to message, C/O, 1/0 CL equals 30 PF10 100 NS. Transfer phase change, target, timing. I. WR backslash dash. I. TPHCH. Point 1. I. Message. Asterisk. I. C/O. Asterisk. I. 1/0. Asterisk. 237. MB89351 Fast Track to SCSI. AC characteristics, continued. Parameter designator test conditions. From WR high to data bus valid for TWTOVCL equals 30 PF temp register. From WR high to Rio high, AC high. TSRRACL equals 30 PF for set Acurio command. From WR high to Rio low, AC low. TRTRACL equals 30 PF for reset Acurio command. Note, timing sequences not shown are the same as those for asynchronous transfers. Manual transfer timing. ITI. Temp, 1L1 Levy, SCMD, ISA. WR. Min. 2 TCLF. 2 TCLF. 100. 3 TCLF plus 60. 3 TCLF plus 60. I. SCMD, RT, T. Unit. NS. 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 II. Rio, target, underscore 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 and dot underscore L underscore 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 F, II, comma, underscore underscore AC, initiator, R underscore I, T, I, JXMT. 1 dash 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 colon underscore 1 dash 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 underscore underscore SPO 7P 238. Fast Track to SCSI. AC characteristics, continued. SCSI bus interface, attention condition. Parameter designator test conditions. From WR high 10 ATN high, ATN low 4. Set, reset ATN command. CL equals 30 PF. MB 89351. Unit. Min. Tip. Max. 2 TCLF 31 CLF plus 60 NS. Attention condition, initiator, timing. IIR. Underscore 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 OJ. I. T. ATNO. 4I. I. ATNT dot comma dash. Underscore 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 underscore. J underscore I backslash underscore 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 239 MB 89351 fast track to SCSI. AC characteristics, continued. SCSI bus interface, bus free. Parameter designator test conditions unit. Min tip max. From BSYI low to init low low TCL equals 30 PF 51 CLF plus 60 NS. From init low to bus clear ear CRCL equals 30 PF 80 NS. From BSYI low to INTR high IELI RCL equals 30 PF 61 CLF plus 80 NS. Initiator, disconnected, timing. I. BSYI, dash dash. 240. Init. ATN. AC. LI. Dash, dash 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 dash. L dash dash I. TTCR. II. 2 underscore 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 F underscore 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 I dash 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 NPUTSMTE dash underscore 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 I underscore 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 dash dash comma dash dash LNPUTSMTE dash underscore underscore I T SPO SDB07 underscore 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 dash dash STBOP I 14th SLA INTR Fast track to SCSI MB 89351 AC characteristics, continued. Parameter designator test conditions unit. Max. From WR high, SCMD register, to TWRL SCL equals 30 PF3 TCLF plus 60 NSBSYO low. From WR high, SCMD register, to TWRGLCL equals 40 PF3 TCLF plus 60 NS targ low. From targ low to bus clear to CL equals 30 PF 80 NS. WR. Targ. BSYO. Message. CIO. 1/0. Rio. Sobosob 07. Sobop. Target, bus release command, timing. I/IR. SCMO, TWRGL. ITWRLS. C. Dash. If dash plus. Tgr. I. Dash JLI. Dash, backslash, input state. I, dash dash, dash dash. Dash, input state. Dash, dash dash, dash dash. Li underscore 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 1, input state. Dash Li underscore 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 backslash input state I dash 1c underscore 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 241 MB89351 fast track to SCSI. AC characteristics continued. Values. Parameter designator test conditions unit. Min. Tip. Max. From WR high, ints register, to cello low TWSL. CL equals 30 PF3 TCLF plus 60 NS. From WR high, ints register, to data IWOBL CL equals 30 PF. Bus disable 3 TCLF plus 1 NS. From WR high, ints register, to targ TWTIL. 3 TCLF plus 60 low or init low NS. From targ low to IO high ZTTGIOCL equals 30 PF. 50 NS. From WR high, ints register, to data twirl CL equals 30 PF. Bus disable 31 CLF plus 60 NS. Termination, timeout, selection and reselection phases timing. I. WR backslash dash. Ints, 14 TWSL.1. Cello II. BSYI. 14 TWOBL, IST bus. STBOP. 14 TWTIL dash plus I. Target I. Init I. 14 TTGIO. 1/0L. Input state, dash. JTWLRL.J. INTR, timeout. 242. Fast track to SCSI MB89351. AC characteristics, continued. SCSI bus interface, reset condition. Designator test conditions. Min. Max. Parameter unit. RSTI pulse width TSRIN 3 TCLFNS. Reset delay CL equals 30 PF4 TCLF plus 110 NS. RST linput timing. RSTI underscore 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 J dot L dash 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 underscore 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 on. Init, targ, BSYO. Cello, Rio, AC. Message, C/O. IOADN. STBO SDB07. STBOP. Dash dash. 243. MBB 9351 fast track to SCSI. AC characteristics, continued. Parameter designator test conditions unit. Min. Tip. Max. From WR high, SCMD registers bit 4. TRSTOCL equals 30 PF1080 NS to RSTO high. Reset delay TRSODCL equals 30 PF110 NS. RSTO output timing. WR. VTRSTOF. RSTO. underscore 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 JR 244 init targ bsyo cello rio ac message c/o 1/0 atn sobosob 07 sobop -i -dash fast track to SCSI MB89351 AC characteristics continued AC test conditions input logical 1 equals 2.4 VDC logical 0 equals 0.45 VDC AC test conditions output logical 1 equals 2.4 VDC logical 0 equals 0.45 VDC input/output pins unit min tip max 0007 op 80 pf OPO 1030 pf INTR 1030 pf ARIA 1030 pf targ input 12040 pf init input 21030 pf sobo sob 07 sobop 1030 pf rsto cello bsyo 1030 pf message sid 110 pf rio ac and 1030 pf 245 MB89351 DIP 64 PM01 64 lead plastic dual inline package case no DIP 64 PM01 57.45 2.262 58.20 2.291 fast track to SCSI T 16.75 0.659 1 dash dot 15 underscore max 0.30 0.012 colon 222 R IIL2 N 118 14.1 778 4 degree point 18 dash dot J 2 0.35 01410.51.020 min 0.070 007 1.5 0.059 0.55.022 dimensions in inches millimeters 246 55.118 2.170 ref 064001S1 fast track to SCSI TBD FPT 64 PM01 00 LJ L 0394 plus 0.0059 I 0.016 plus 0.004 1.00 0.15 minus 11 0.40 0.10 0.972 0.016 24.70 0.40 Dimensional \$ in Filches, millimeters MB89351 02510.63 Max F6400 247 MB89351 Fast Track to SCSI 248 MB89352 SCSI Protocol Controller, SBC with on-chip drivers/receivers. General description: the MB89352 CMOS LSI SBC, SCSI Protocol Controller, is a circuit designed to make control of the small computer system interface, SCSI, easier. The MB89352 can be used as a peripheral LSI circuit for an 8 or 16-bit MPU to realize high-level SCSI control. The SPC can control all the SCSI interface signals, handle almost all the interface control procedures, and the on-chip driver/receivers allow for direct connection to the SCSI bus. This LSI circuit has an 8-byte FIFO data buffer register and a transfer byte counter that is 24 bits long. Furthermore, the MB89352 can serve as either an initiator or a target device for the SCSI, and can therefore be used for either an I/O controller or a host adapter. SCSI compatibility. Full support for SCSI control, ANSI. X3.131S.1986 specification, except for synchronized transfer mode. Serves as either initiator or target. Data transfer rate/byte counter. 8-byte FIFO data timing control. 24-bit transfer byte counter. Drive options, on-chip. Driver/receiver. Single-ended. Selectable transfer modes. DMA transfer. Program transfer. Manual transfer. Clock requirements. 8 MHz clock. Technology/power requirements. Silicon gate CMOS. Single plus 5V power supply. Available packaging. 48-pin dip or flat plastic packages. 249. MB89352 Fast Track to SCSI. Absolute maximum ratings 1. Values. Rating designator unit. Min. Max. Supply voltage VVSS-037.0 V. Input voltage 6 VSS-037.3 V. Output voltage 2 VOVSS-03 VSS plus 7.3 V. Operating ambient. Ta 070 degrees Celsius temperature. Storage. Temperature TSTG. Minus 55 150 degrees Celsius. Notes. 1 permanent device damage may occur if the above absolute maximum ratings are exceeded. Functional O-irration should be restricted to the conditions as detailed in the operational sections of this datasheet. Exposure to absolute maximum rating conditions for extended periods may affect device reliability. 2 should not exceed V plus 0.5 V. Recommended operating conditions. Values. Parameter designator unit. Min. Tip. Max. Supply voltage V 4.755.05.25 V. Operating ambient temperature Ta 0 plus 70 DC. 250. Fast track to SCSI. MB89352 block diagram. SUP. M88932. DREQ. 5AC. T dash 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 equals dash underscore 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 equals underscore 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 dash colon dash dash DPO J. Arbitration and selection. Logic. Address. Decode. And MPU. Interface. 251. MB89352. Pin assignments. 48 PLN DIP. 252. List. AO. A1. A2. A3. MJ1. SI56. OG. SJJS. NC. SM. SL52. MRR. OG. SCO. SOL. OPO. OP. DO. 01. 02. VSS. 48, 247, 46, 45, 44, 43, 742, 841, 940, 1039, 1138, 12, 1336, 14, 15, 1633, 1732, 1831, 19, 20, 21, 22, 23, 24, DIP 48 PM02. Fast track to SCSI. V. CTR. NM. OREQ. RO. AM. AC. OG. LML. NC. 1I. SET. OG. BSV. INTR. 07. 06. 05. 04. 03. Fast track to SCSI. Pin assignments, continued. 48 pin DIP. 48 PLN plastic flat package. 1M. WT, F. OREQ. OTR. V. RST. AO. A1. A2. A3. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. GGI. FPT 48 PM02. MB 89352. 36 INTR. 3507. 3406. 3305. 3204. 3103. 30 VSS. 2902. 2801. 2700. 26 up. 25 OPO. 253. MB 89352 Fast track to SCSI. Pin descriptions. Pin no. Decilnalar 1/0 function. DIP FPT. V486, plus 5V power supply. VSS 2430. Circuit ground. OG 915 ground, OV, for Intimal drivers. The SCSI bus drivers can sync 1622, up to 48 mA each. Up to 16 drivers can be active at once. We 3339 recommend a good solid ground plane. 4046. CR. Clock input for controlling Intimal operation and data transfer. 47.5 speed of the SBC. RST. Asynchronous reset signal used to clear all Intimal circuits of 17i. The SPC. Input selection enables signal for accessing an Intimal register. Cs28. When active low, the following input/output signals are valid. IRO, WR, A3 A.0, OP7-0 PO and OP. Address input signals for selecting an Intimal register in SBC. A039. MSB is A3, LSB is AO. A1410. I. When Cs is active, read. Write is enabled for an Intimal register. A 2511 selected by these address inputs via data bus lines 00-07 and a 3612. OP. This strobe input is used for reading out the contents of the SBC Intimal register, and is effective only when C's input is active. RO431I. While RO is active, the contents of an Intimal register selected by A0 to A3 inputs are placed on data bus lines 07 to do, OP. For a data transfer cycle in the program transfer mode, The RIS ing edge of RO is used as a timing signal indicating the end of data read. The strobe input is used for writing data into an SBC in TML WR44-2I register, and is effective only when C's input is active. On the rising edge of the signal, data placed on data bus lines due to 07 op are loaded into an internal register selected by AutoIt. Inputs for a data transfer cycle in the program transfer mode. The rising edge of the signal is used as a timing signal indicating data ready status. Do 2127 IO. Used to write/read data toll from an TML register in the SPO. The data bus is 3-state and bidirectional. The MSB is 07 and the 012228. LSB is do, op is an odd parity bit. 022329. 032531. When both Cs and RO inputs are active, the contents of a SE042632. 052733 lect and TML register are output to the data bus. In operations 062834 other than read-write, the data bus is kept at a high Z level. 072935. 254. Fast track to SCSI MB89352. Pin descriptions, continued. Pin no. Designator 110 function. DIP FPT. DPO 19250 outputs an odd parity of D0-07. If parity bit is not generated lore. External memory, DPO can be used as an input parity bit for DP. The INTR output signal is issued by the SBC and requests an interrupt to indicate completion of an TML operation or the INTR 30360. Occurrence of an error. Except for an interrupt caused by the RSTI input, reset condition in SCSI. When an interrupt request is granted, the INTR signal remains active until the interrupt is cleared. For a data transfer cycle in DM mode, this signal is used to indicate a request for data transfer between the SBC and the external buffer memory. In an output operation, this signal becomes active to request a data transfer from the external buffer memory. DREO 4530. When the SBC in TML data buffer register has free space available. In an input operation, it becomes active to request data transfer to the external buffer memory when the SBC in TML data buffer register contains valid data. An active low response signal to the DREO which requests data transfer in between SBC and the external memory in the DMA mode. This signal in DMA mode functions similarly to the signal combination of CS equals low, A3 equals high, A2 equals low, A1 high, and AO equals low, selection of DREG, in the program transfer mode. Since the DREG is selected by the signal in the DMA RNSCK464I mode instead of the address input from A3AO, data transfer in between DREG of SBC and external memory is possible. Active local directional SCSI data bus. SRM 1723. SOL MSB, SU7, LSB, SUO. SM 1521. 1420 odd parity bit SDP. 1318. S0411 17110. Parity check for the SCSI data bus is programmable. S051016. SM814. SU7713. SOP 1824. SET 3441/0. A signal to issue or detect selection or reselection phase. In SE lection phase, an initiator asserts the signal, and in reselection phase the signal is asserted by the target. This signal indicates the SCSI bus use condition. The signal 32381/0 goes L when SBC is in arbitration phase or working as a target. Also, this signal is used to detect bus free phase with SEI SIG. NAL 255 MB89352 fast track to SCSI. Pin descriptions, continued. Pin no. Designator 110 function. DIP FPT 170.38.4. Signals to indicate actual phase of information transfer phase. M as follows. Message. Message C/O110 phase name. 1/0. 000 data out phase. 001 data in phase. 010 command phase. 011 status phase. 100 reserved. 101 reserved. 110 message out phase. 111 message in phase. These signals are output from the target and initiator receives them always. In the data transfer phase, the RIO signal is used to notify the RIO 39451/0 initiator that the target is ready to receive or send data. The RIO input is used as a timing control signal in the data transfer sequence. In the data transfer phase, the acknowledge signal is in RI 1 MK4147 IO Sponsito, a transfer request, RIO, signal from the target. In the same way as RIO, an ACK input is used as a timing signal in the data transfer sequence. JITN 4248-110 a signal to indicate attention condition. This signal is only output from an initiator. SRST 3137 IO. SCSI reset signal to be enabled by register setting. SCSI input from other SCSI devices is non-maskable. NC RNC 1237-19,43, no connectors. 256. Fast track to SCSI MB89352. Addressing of internal registers. SBC has internal registers consisting of 15 bytes that are accessible from an external circuit. These internal registers are used for controlling SBC internal operation and indicating SBC processing status/result status. A unique address is assigned to each internal register, and a particular register is identified by address bits A3 to A0. The following table shows internal register addressing. Internal register addressing. CSA3 A2 A1 A0 operation register name ABBR 00000 read write bus device 10 bold 00001 read write SBC control SCTL 00010 read write command SCMD 00011 open read interrupt sense 00100 ints write reset interrupt read phase sense PSNS 00101 write SBC diagnostic control SDGC read SBC status 00110 SSTS write read SBC error status 00111 SER write 01000 read write phase control PCTL read modified byte count 01001 MBC write 01010 read write data register DREG 01011 read write temporary register temp 01100 read write transfer counter high TCH 01101 read write transfer counter middle TCM 01110 read-write transfer counter, low, tel. 257. MB89352 fast track to SCSI. Bit assignments. The following table shows the bit assignments to each internal register. When accessing an internal register, in read-write, remember the following. 1. The internal register block includes the read-only/write-only register and those having different meanings in read and write operations. 2. A write command to a read-only register is ignored. 3. If the write-only register is read out, the data and parity bit are undefined. 4. At bit positions indicating _ for a write in either 1 or 0 may be written. Bit assignments for internal registers. Register RIW. Hex and OPER 765432210 parity. Address mnemonication, MSB, LSB. Bus R number 7 number 6 number 5 hashtag 4 number 3 number 2 number 1 number 00. 0 device 10. Bold, W. 104 102 101. SBC reset conoyag arbit parity select resel int. 1 control RIW and OIS drawl ECTP. SCTL, able reset mode enable. Command RRST inter. Transfer modifier. SCMO, sept. PRG term P. 2. W. Command code. Outsfer, 0 mode. 3. R. W. Interrupt select resel oiscan com ser lime SBC reset. Sense. RMAN device rehard kin DP. 4 TED ected nect comp quired out errortion. Plit. Ser, W reset interrupt. Phase. R Rio AKDN cell BSY message C/01/0P. Sense. PSNS. 5. SBC diagram. 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 Sphere diagram. 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 Control. SDGC, W. Rio AC enable BSY message C/D1/0. SBC are connected SBC XFER SCSI DREG status. Status. In editarg. In pro TC equals OJ. Empty. P. 6, SSTS, BSY gress RST full. W. 258. Fast track to SCSI MB89352. Bit assignments for internal registers, continued. Register RRW. Hex and OPER 765432210 parity. Address mnemonic Atlan, MSB, LSB. SBC data errors for TC short. 7 error R. 0 parity 00P. Status SCSI SBC out error period. Ser. Bus. Phase free transfer phase. Control R/W inter. 0. Message \C/O. \0. P. 8. PCTL, rupt. Out. Enable. Modified MBC. Byte. R0. P. 9 counter. I. Bit 2. I. Bit 1. I. Below, MBC, bit 3. Data internal data register, 8-byte FIFO. Register. Bit 7 I bits. I. Bit 5. I. Bit 4. I bit 31 bit 2 I. Bit 1 I. P. A. DREG, R/W below. Temporary data, input, from SCSI, P. B register bit 7 I bits I bits I bit 4 I bit 3 I bit 2 I bit 1 I below. Temp, W temporary data, output, to SCSI. Bit 7 I bits J bit 4 I bit 3 1 bit 2 I bit 1 I below P. Transfer counter high, MSB. C counter. High R/W. Bit 231 bit 221 bit 211 bit 20 I bit 1 bit 181 bit 171, TCH, bit P. Transfer counter high, second byte. 0 counter RI. Mid W. TCM, bit 15 I bit 141 bit 131 bit 12 I bit 111 bit 101 bit 9 I bits P. Transfer. E counter R/W transfer counter high, LSB. Low. TCL, bit 7 I bits. I bits J bit 4 I bit 3 J bit 2 I. Bit 1 I below P. External R external buffer. F buffer. EXBF, W bit 7 I bits. I bits I bit 4 I bit 31 bit 2 I bit 1 I. Below P. These bit assignments for intemal registers are identical to those in the MB87030, MB87031, and MB89351. Therefore, SBC replacement from them to this MB89352 is very easy and it does not require any new software design. 259. MB89352. DC characteristics. Ta equals 0-70 degree C, VCC equals 5V, dot : 5%. Recommended operating conditions unless otherwise specified. SCSI bus signal pins. Values. Parameter designator conditions. Min. Tip. Input high voltage VIH 2.0. Input low voltage VIL 0. Input high current VIH equals 5.25 V, 100. Input low current VIL equals OV, minus 100. Output voltage VOL V equals 4.75 V. IOL equals 48 mA. Input hysteresis width VHM, 0.20.4. 260. Fast track to SCSI. Unit. Max. 5.25 V. 0.8 V. 400 RNA. Minus 400 RNA. 0.5 V. V. Fast track to SCSI MB89352. DC characteristics, continued. MPU bus signal pins. Values. Parameter designator conditions unit. Min. Tip. Max. Input high voltage VIH 202, V plus 003 V. Input low voltage VIL VAS 003, 008 V. Output high voltage VOH equals -0.4 mA 400 VV. Output low voltage VOL IOL equals plus 302 mA VAS 004 V. Input leakage current. ILLH VIH equals 50-25-20 mA. ILLH VIL equals 000 minus 10 mA. Input/output leakage ILZH VIH equals 50-25-40 mA. Current. ILZH VIL equals 000 minus 40 mA. Power supply current ICC in-rut clock equals 8 MHz 10. AI output pins open. 261. MB89352 fast track to SCSI. AC characteristics. Recommended operating conditions unless otherwise noted. Parameter designator. Min. Tip. Max. CRR cycle Lime TCLF 125 200 NS. CRR high Lime TCHCL 44 NS. CRR pulse width TCLCH 44 NS. CRR rising skew Lime TL 10 NS. CRR falling skew time T, 10 ns. Clock signal timing. 14, ICHCLI. CRR 20V. 4 Yen 2.0V. 10.8V 0.8Vi. 14 TR11 TF plus 114 equals. I14, ILK, I1. .114, ELF. 262. Fast track to SCSI MB89352. AC characteristics, continued. Parameter designator TRRT. Min. Tip. Max. Unit. Fist pulse width 100 ns. Reset input timing. 0.8 v1 J108v. 1. 4 TRSTW. I. 263. MB89352 fast track to SCSI. AC characteristics, continued. Parameter unit. Min. Tip. Max. Address setup time TARS 40 ns. Address hold time TARH 10 ns. CS setup time TCAS 25 ns. CS hold time TCAH 10 ns. Data valid time, from RLY low, CL equals 8 UPF, TRLD 90 ns. Data valid time, from RLY high GH, equals 2 UPF, TRHO 1060 ns. RLY pulse width IRD 120 ns. Register read timing. I-I2.0v2.ov-vih -.ao.svo.svf /vil 11 14 tars tarh AOA3 I1 /i/o.sv underscore 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 f TCRSI J14TRD.T1 I.TCRH underscore dash 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 underscore 1I 2.0 I J J2.0V O.SVIN O.SV 14 LD.1 1I do D7DP underscore 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 dash 2 dash point 0 V dash VALID dash dash JT2 dash point 0 V dash 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 underscore underscore O.SVFO.SV 264. Fast track to SCSI. AC characteristics, continued. Parameter. Address setup time. Address hold line. CS setup time. CS hold time. Data bus setup time. Data bus hold time. WR pulse width. AOA3 dash. I2.0V 0.8V 0.8V Min Tip TAWS 40 TAWH 10 TCWS 25 TCWH 10 TOWS 30 TOWH 20 TOW 100 Register write timing 2.0V 0.8 VI J.IT II 0.8 V I dash FLI TCWSL +/1 144 TWR1 TCWH WR 2.0 V 0.8 VI 0.8 V dash TLIT 14 hours 14 OI. II. MB89352. Unit. Max. NS. 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 00-07, DP12-.0V-2-0V. _J_I. 0.8V 0.8V. 265. MBs 9352 Fast Track to SCSI. AC characteristics, continued. Parameter test C conditions ERRT unit. Min. Max. Data bus, do, 07, valid to OPOTDPVDCL equals 30 PF60NS. DPOTLMing. 00-07 /I 2.0V. Underscore 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 dot underscore 0 underscore 8V underscore 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 on IT 14 DPVDI OPO -2-V underscore 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 dot 08V dash 266. Fast track to SCSI MB89352. AC characteristics, continued. Parameter designator test conditions. Min. WR high to INTR low, interrupt reset, TWHIRCL, LAP. TCLF2 TCLF plus loons. INTR high to WR high TLRWLNS. INTR reset cycle time TWRCY4 TCLFNS. Note, applicable only when interrupt reset is executed. Interrupt output timing. I. 2.0 VI. IT. IIWHI 0.8 VIRWL underscore 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 underscore. Underscore underscore. Underscore 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 INTR. I. WR. I-IR. Backslash underscore 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 slash 0.2.0V. Backslash equals slash dash dot LHLL. 2.0V. Slash 4 IWRCY. 267. MB89352 Fast Track to SCSI. AC characteristics, continued. Parameter designator TESL conditions unit. Min. Tip. Max. DREQ high to low TDHL. 0 NS. WRNO service time. TARM 40 NS. From D7 IC low to WR or 1M low. DREQ release time. From WR or 1M low to DREQ low, note, TRWDLCL equals 30 PF 35 150. NS. DAC hold time. TRWAH 10 NS. From WR or O high to low. DREO interval. TDLDH 0 NS. From DREO low to DREQ. DREG access cycle time, 1, TRWCY2 TCLFNS. DREG access cycle time, 2, TDMCY3 TCLFNS. Applicable when data buffer register will be full. The 1M parameter is applicable when the data buffer. DMA access timing. 1 dot dash underscore 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 dash dash dot. R. I old. TT 2.0 V backslash dot. Underscore 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 R. L. R2 dash. 0 V. DREQJ, O.SV4 backslash. Slash 1. TDHAL.1 I.1. TRWOL. 11. Dash. 1 IO.SVI. Underscore 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 underscore. Slash. Dash 20 dash 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 underscore 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 underscore. I. TARWL. Dot. TI. TRWAH. II underscore 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 underscore. Backslash dot. 1 yen 2.0 V backslash. I slash backslash. O.SV dash, if O.SV O.SV O.SV. IIIRWCY1. WRRD. M dash dash dot I. 268. Fast track to SCSI MB89352. AC characteristics, continued. Values. Parameter designator test conditions on. Min. Tip. Max. R. J service time. TLHRL0, from INTR high to 110 low, NS. INTR release time. TRHILCL equals 20 PF35 150 NS. From RU high to INTR low, node. INTR recovery time. From INTR low to INTR high. TLUH0 NS. R. J recovery time. TRHRL 50 NS, from 110 high. To R. J low. DREG access timing, input operation. 14t.1 dot dash underscore 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 underscore. Dash 1. 1.2 dash 0 V dash 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 1 I LHI 2.0 V. I0.8 VI. IHTRHIL. INTF. II. 110.2.0 V. Note, this parameter is applicable when the data buffer register will be full in the output operation and empty in the input operation. 269. MB89352 Fast Track to SCSI. AC characteristics, continued. Parameter designator test conditions unit. Min. Tip. Max. WR service time. EOL0 NS, from INM high. 10 WR low. INM release time. IWLCL equals 20 PF35 150 NS. From WR high 10 INM low, null. INM recovery time. 0. From INM low to INTR high, TLUH. NS. WR cycle time TWRCY2 TCLFNS. DREG access timing, output operations. 14-J. I2-.0 V dash 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 O.SVII I INTR II WLIL plus TIIFDOL plus J II backslash O.SV .fo.sv10.sv 14 WRCY WR. Note, this parameter is applicable when the data buffer register will be full in the output operation and empty in the input operation. 270. Fast track to SCSI MB89352. AC characteristics, continued. SCSI bus interface selection phase timing. Designator. Min. Unit. TBFBL, 6 plus N, 1 XTCLF, 7 plus N, XTCLF plus 60. Data bus valid to prioritize TLOV200. Bus usage permission granted TAWSL080. To SEC low. SEC low to data bus ID output, TSLOA11 TCLF30NS. ATN low. Select LD hashtag output to BSY high BOBH2 TCLF80. Peer 110. Asterisk 1N, TCL register value. Asterisk 2 bus free time, the minimum time until the book select command will be executed. All SCSI timing signals. Note, all SCSI timing signals are defined according to the following rules. SCST signals, dash. Active low, 1 backslash. I backslash I. 1, 2, 3. 1. The SBC outputs low-level signal to the bus. 2. All devices hooked up to the bus do not output low-level signals. 3. Other devices hooked up to the bus outputs low-level signal. 271. MB89352 Fast Track to SCSI. AC characteristics, continued. SCSI bus interface selection phase timing. Initiator with arbitration timing. TBFR. TSBCR TPBCR. BSY-1V. VI//. TBFBL. TLDBH TBLSH. I. TAWSL. I. SE. I/J. TARB. TBIH. I. W111/V2V. SD70L. 1/I. TAIDV. TSIDA. UN1/. TSHIR. F. INTR. Command complete. 272. Fast track to SCSI MBs 9352. AC characteristics, continued. Designator on. Min. Tip. Max. BSYH to select 10 hashtag output TFRLD, 6 plus N, XTCLF, 7 plus N, XTCLF plus 140. 10 hashtag output to set, low BDSL11 TCU equals AO. NS. TAL DH2 TCLF. TSHIR. Initiator without arbitration timing. V backslash. TBLSF. I. 1/J. TTFRID TLDSL, FOITBIDH. W. TSLAT. R. 1/. TSHIR. INTR. I. 273. MB89352 Fast Track to SCSI. AC characteristics, continued. Values. Parameter designator. Min. Tip. Max. Unit. Data bus valid, 10 hashtag, to BSY high TLLLBHO. Tau D60NS. 170 low to data bus output Bode 7 TCLF. M high to INTR high. Target with arbitration timing. SSVV. FITSLBH. FOITBHBL14 TBLSH. SE. Backslash. J. TLDBH14. TBLID14. SU7UP. V2IR. G/JL/. 1 equals. TLOHB14 ITSHPHTLODH. 170. C70. J1 / message. Underscore HH. T. INTR. Selected. 274. Fast track to SCSI MB89352. AC characteristics, continued. Values. Parameter designator. Min. Tip. Max. Unit. Data bus valid to SE low BDSL0. 170 high to SEC low BOHS0. TSLBL2 TCLF. TSLSH0NS. TSHIR3 TCLF plus 130. Target without arbitration timing. R / TSLBL. F4 TBLSH. 1 / I. TIDSL. TBLIO. / R. J / J == TLOHSIE, TSHPH TLOOE. J. INTR. TSHIR. Underscore I. Selected. 275. MB89352 Fast Track to SCSI. AC characteristics, continued. SCSI bus interface, residential election phase timing. Designator. Min. Unit. Tip. Max. 7 plus N, XTCLF plus 140. NS. 40. TSHIR. TPLLCR 110. 276. Fast track to SCSI MB89352. AC characteristics, continued. Reselect LAN timing, target. TBFR. T. TSBCR TPBCR BIBO. IJVV. / -11 / TBFBL RTIB. TBLSH. TAWSL. 1 - 1 / J. TARB14 TBIDH. TBLID. F. WL/WW1/V. II / T. TSIDP. 1 / TSHIR. INM. __F. Command complete. 277. MB89352 Fast Track to SCSI. AC characteristics, continued. Designator. Min. Max. On. TLDBH0. Tau D60. NS. TSHBO2 TCLF STCLF plus 140. TSHDES TCLF plus 34 TCLF plus 160. TSHIO 200. M high to INTR high TSHIR STCLF plus 130. Reselection timing, initiator. TBLSH. BSYI / I. TSLBH, TBHBL. TSHBOI. SE, / J. :1, TLDBH. TBLLC TSHDE. SIJ7U, L. K. V. JTLOLBITTSHIO. 1/0I. TRI. INTR. Reselect. 278. Fast track to SCSI MBB9352. AC characteristics, continued. SCSI bus interface, information transfer phase timing. Values. Parameter designator unit. Min. Tip. Max. M high to data. Phase set to RECR low LPHRL 100. TAOLR0. NS. TAOHR0. TRATH2TCLF. Asterisk 1. This spec is applicable to the last byte transfer of message out phase in hardware transfer mode. Asterisk 2. When the transfer phase is changed, both TRLPH and TAHPH should be specified. 279. MB89352 Fast Track to SCSI. AC characteristics, continued. Asynchronous transfer output timing, initiator. Tracy. /J1 F4 TPHRL. TRAOL. OITAOLR. TRAOH. TAOHR. 1 /JI equals. Tilde, dash. Taflow F4 TOIVO. R. NV. WW. W. TRATH. A. J. TAHPH. R. TRLPH. 170J. 1 /I. J // 2. JR dash. Lee / 280. Fast track to SCSI MB89352. AC characteristics, continued. Values. Parameter designator unit. Min. Tip. Max. Bode. To VLD2 TCLF80. NS. Large 10180. Asynchronous transfer output timing, target. Rio. J. / equals. TROLA. TAROH. TROHAITAROL. ACR / J. Tracy. Ofloy TOIVO. S07. P2. 170. _ITLOOE. 1 / 2 equals R. V. Equals. 281. MB89352 Fast track to SCSI. AC characteristics, continued. High to phase CI1 Ang2 TAHPH10. Notes. 1 applicable to the last byte transfer of message out phase in hardware transfer mode. 2 Ocean the transfer phase is changed, both TRLPH and 1 AHPH should be specified. 282. Fast track to SCSI MB89352. AC characteristics, continued. Asynchronous transfer input timing, initiator. Tracy. /I / TPHRL -- TRAOL TAOLA. TRAOH. TAOHR. /JL. To H low. To STU. HV / equals. I equals. -1 /J F4. TATAH. I. Talo. I / TAHPH. TRLPH. Dash. 1 /J. 1/2. JJ / 2. 2. JJ / 283. MB89352 Fast track to SCSI. AC characteristics, continued. Values. Designator unit. Min. Tip. Max. 10. NS. TAROH 10180. TAROL 10. Tracy 2 TCLF. Asynchronous transfer input timing, target. Rio. 1 backslash I. TROLA. TAROH, I plus TROHAI TAROL. 7 backslash CKF backslash. Tracy. TOSTU. TOHLOI. S07U.P. 222. 1 backslash, 1 backslash. TIOOD. 170. Equals. C70. Equals. 2. Mu. Equals. 284. Fast track to SCSI MB89352. AC characteristics, continued. Parameter designator on. Min. Tip. Max. From WR high to message, 00, 170 change TPHCH 10 130 NS. Transfer phase change timing, target. I. WR backslash dash. I. TPHCHI 4. I. Message. Asterisk. I. Co. T. I-70. Asterisk. 285. MBB 9352. AC characteristics, continued. Parameter designator. Min. From WR high to data bus valid for. TWRDV temp register. From WR high to REQ low, AC low. TSTRA2 TCLF. For set Acurio command. From WR high to Rio high, AC high. TRTRA21 CLF for reset Acurio command. Manual transfer timing. WR. J. Temp, TWRDV, SCMD, TSTRA. 1++1 Tip. Fast track to SCSI. Max. 130. 31 CLF plus 90. 31 CLF plus 90. Dash. SCMD, IRT. Unit. NS. 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 Rio, target. JMK, Iniator, dash 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 I, equals. 286. I. 9 FJJ. T equals. 1 Fast track to SCSI. AC characteristics, continued. SCSI bus interface, attention condition. Parameter. From WR high to AM change. Set, reset ATN command. Designator. TWATN. Min. 2 TCLF. Tip. Attention condition timing, initiator. I. MB89352. Max. 3 TCLF plus 90 NS. WR. IR. 2. TWATN. 4.1. I. Dash R. 287. MB89352 fast track to SCSI. AC characteristics, continued. SCSI bus interface, bus free. Parameter designator unit. Min. Tip. Max. BSY high to. BSY high to INTR high TBHIRSTCLF plus 80 NS. Initiator disconnected timing. I. TSHCR. I. J. V. INTR. Bus free. 288. Fast track to SCSI. AC characteristics, continued. Parameter. WR high to bus clear. Bus release command. WR. BSY. SD70. J. S. Rio. T70. C70. Backslash. Designator. Min. TSRCR. Bus release timing, target. T. TBRCR.1. J. W. I. M889352. Unit. Tip. Max. 3 TCLF plus 100 NS. 289. MB89352 Fast Track to SCSI. AC characteristics, continued. Parameter designator unit. Min. Tip. Max. WR high to SEJ, S07. P170 high TBRCR3 TCLF plus 100. Reset timeout interruption, NS. WR high to INTR low TWRLR3 TCLF plus 60. Timeout timing, selection/reselection phases. WR. J. TBRCR. J. S07OP. 1/ V. 170. J. F4TWRIRJ. INTR. Timeout. Dash. 290. Fast track to SCSI MB89352. AC characteristics, continued. SCSI bus interface, reset condition. Values. Unit parameter designator. Min tip max. WR high to SRSTLDW. Write I to SCMD bit 4, TWRST10 110. NS. Reset delay trdod 140. SRST signal transfer timing. WR. I. TWRST. SRST. Backslash. ITRTOD. All SCSI. Signals. Except SRST. 291. M889352. AC characteristics, continued. SCSI bus interface, reset condition. Reset delay. 292. All SCSI. Signals. Except SRST. Designator. Min. SRST signal acceptance timing. Dash, TRSTW. 1 \__. ___________. 11. ___t_rt_id_______ ___. X. Fast track to SCSI. Unit. Max. NS. 4 TCLP, 200. Fast track to SCSI. AC characteristics, continued. The AC characteristics of all SCSI bus signal pins are measured on the following test circuit. MB89352. Test point. TP. V. 1100. Signal pin. 1 --... DG 1650. MB89352. CL equals 300 PF. Including testers. Capacitance. 293. MB89352. Package dimensions. DIP 48 PM02. 48 lead plastic dual in L1NE package. Case no, DIP 48 PM02. 0.034 plus 0.020, 0.87 plus 0.50, plus it, minus 0, t. 0.543 plus 0.010, 13.80 plus 0.25, ____ dash dot t. II. 14 2.372 plus, 60.25 plus. 0080.20. 0.0120.30. Fast track to SCSI. J5L::::. Tip, 127, G.50, 0.46. 0.08. PNNSFMMT8. 294. Fast track to SCSI. Package dimensions, continued. 48 lead plastic flat package. Dimensions in inches, millimeters. FPT 48 PM02. 48 lead plastic flat package. Case no, FPT 48 PM02. View A. 0.094, 2.40. Max. 0.15 plus 0.05. Minus 0.01. MBs 9352. 0.071. 012. 1.800.30. F480028 SC. 295. MB 89352 Fast track to SCSI. 296. Appendix 1. SBC driver examples in 8086 assembly language. The following code is a group of routines, written in 8086 assembly language, that demonstrate the essential elements necessary for the implementation of a SCSI driver, using Fujitsu's family of SCSI controllers. These routines make certain assumptions about the hardware interface, but are software compatible with all the Fujitsu SCSI controllers. For this example, the controller is memory mapped somewhere in the 1 MB address space of the 8086. This example assumes that the controller will be used in a polled environment, not interrupt-driven, using programmed I/O, no DMA. Using the device in this mode requires much more code than an interrupt-driven /DMA environment, but the code will be less dependent on system hardware. At the end of this example is a rewrite of the data transfer routine using DMA transfers instead or programmed I/O. As can be seen, the code is considerably smaller and simpler. These routines use short, 16-bit, pointers to keep the code relatively simple, but this limits the size of the transfer buffers to 64 KB, due to the 8086 family's segmentation limitation. Even though the transfer routines and the SBC will take up to a 24-bit, 28-bit MB87033 transfer length, allowing transfers up to 16 MB, this size cannot be accommodated without rewriting the transfer routines to support segmented, 20-bit, or 80,386 extended, 32-bit, pointers. This code is intended to show the programming and operation of the major functions of the Fujitsu family of SCSI controllers. It is not intended as a tutorial of the SCSI protocol, or to show the construction of a driver for an SCSI host adapter. This code was tested for syntax errors under the following assemblers, using the small model Borland TASM 1.0, Microsoft MASM 5.1, 297, Appendix 1, Fast Track to SCSI. For detailed information on the SCSI protocol, see the spec entitled ANSI Small Computer System Interface, SCSI. ANSI X 3.131-1986. American National Standards Institute Incorporated. 1430 Broadway, New York, New York, 10018. For information on Fujitsu SCSI controllers, contact Fujitsu Microelectronics Incorporated. 3545 North 1st Street, San Jose, CA.95134-1804. 408-922-9000. Or your local Fujitsu representative. I. Copyright, C. 1989 Fujitsu Microelectronics Inc. Copyright, C. 1989 Galbo and Associates Incorporated. 298. Fast Track to SCSI Appendix 1. Model small. Code. Equates. SBC memory mapped register addresses. BDID EQ bus ID. SCTL EQ SBC control. SCMD EQ SBC command. TMOD EQ transfer mode. INS EQ interrupt sense. PSNS EQ phase sense. SDGC EQ SBC diagnostic control. SSTS EQ SBC status. SIR EQ SBC error status. PCTL EQ phase control. MEC EQ modified byte counter. DREG EQ data register, FIFO. Temp EQ temp register. TCH EQ transfer counter high. TCM EQ transfer counter middle. TCL EQ transfer counter low. EXBF EQ external buffer register. SBC_offset HFO assume SBC is memory mapped. SBC segment equals ODCOO at this address 9 seg OFSO. Data transfer mode. Read. Write. SCSI timeout values. Selection timeout. Bus delay. 1. 4400. 4. Read mode for data transfer routines. Write mode for data transfer routines. 275 millisecond. At SM Hertz clock. 1200 nsec. At SM Hertz clock. 299. Appendix 1. Selection return values. Selected. Lost arbitration. Timeout. Error INTR. Equals 100. Minus 100. Minus 101. Equals minus 102. Data transfer return values. OK. OakPad. Service underscore required. Parity error. 200. 201. Minus 200. Equals minus 201. Fast track to SCSI. Target successfully selected. Lost control of SCSI bus to another. Initiator. Selected target did not respond. Hardware error occurred during selection. Transferred all bytes without error. Transferred all bytes plus padding. Early phase change, didn't transfer all. Parity error during transfer. Phase decoder return values. No phase requested. Illegal phase. 300. Minus 300. Targets REQ signal negated. Target requesting undefined phase. Fast track to SCSI Appendix 1. Constants. Data, data area. Address to ID DB1, 2, 4, 8, 16, 32, 64, 128. SBC pointer label D word. SBC OFSDW SBC offset. SBC _seg DW SBC segment. Global variables. Data. Unitialized data area. At data length label D word length of transfer for data. In/out phase. At data length underscore low DW0. At data length underscore high DW0. At data per DW0 pointer to byte buffer for data. In/out. At command length DW0 length of command block. At CMDB/LKDB12 dup 0 command block max equals 12. At misgout DB0 message out byte. At misgen DB0 message in byte. At status DB0 status in byte. External routines. Code. Extern setup DMA near, setup systems DMA. Controller. 301. Appendix 1, fast track to SCSI. Initialize SBC. Initialize the Fujitsu SBC. Entry, byte at BP plus 4, initiator's SCSI address. Exit, void. Init SPC record. Init address. Init SPC record. Init SPC. Init SPC. 302. Stroke. DW. DW. DB. Ends. PROC near. Push BP. MOV BP SP. BP. IP, return address. Initiator's SCSI address. LayBX SBC underscore pointer, point to SBC. MOV SCTLOCO, reset SBC. MOV AL, BP, dot init address, get initiator address. MOV BOIO AL write initiator's address. MOV TMOO. MOV SCTL ALA. MOV SOGCO. POP BP. RET. ENP. Into 10 reg. Clear reg. Enable arbitration, parity. And reselection. Clear diagnostics reg. Fast track to SCSI Appendix 1. Select target device. Select a target device on the SCSI bus with ATN line asserted. Check if the target responds to the ATN line with the message out phase. If so, send an identify message to the target. Entry, byte at BP plus 4J. Byte at BP plus 6J. Target SCSI address, 07. Target SCSI logical unit number, 0. 7. Exit, AX equals status message. Select record stroke. Targ address. Targ LUN. Select record. Select. DW. DW. DB, comma. DB, comma. Ends. PROC near. Push BP. MOV. Lay. MOV. MOV. Push. XOR. MOV. OR. BPSP. BXSBC underscore pointer. PCTLO. ALBDID. BX. BHBH. BL, BPJ. Targ address. AL address 2 ID BXJ. BP. IP, return address. Target address. Target LAN. Point to SBC. Phase control equals out indicates. Selection phase. Get initiators SCSI ID 1. 128. Save SBC PTR. Get target SCSI address, 0. 7. Convert to SCSI ID, 128. Or with initiators ID. For reselection, see spec. BXESBX-SBC pop. MOV. MOV. Temp I'll put arbitration IDs in temp reg. MOV. 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 TCH high, selection underscore me out, Load selection. Timeout. TCM low, selection underscore me out, value. TCL bus underscore delay load bus free delay timeout. SCTL 060H set ADN line, select with. Attention. SCTL 010H start selection operation. 303. Appendix 1. Select wait INTR. CMP INSO. Jane. Yes. Test SSTS 020H. Any INTR bit set? Select INTR. Fast track to SCSI. No, select operation still. Pending. Check for lost arbitration. JZ select wait INTR. Still pending. MOV ax lost underscore arbitration we've lost the arbitration. JMP select exit. Select LNTR. Select no message. Select timeout. Test in slow. JZ. No. MOV. And. CMP. No. MOV. Or. MOV. X or. Push. Call. Pop. Check timeout. AL PSNS. AL 087H. AL 086H. Jane. Skip message out phase. AL OCO. AI, BP, .targ LUN. At misgout AL. Ax. Message underscore out. CX. JMP select OK. Test. JZ. MOV. JMP. Select other INTR. INS 04H. Select other INTR. AX timeout. Select OK. Select exit. Select. 304. MOV. JMP select exit. MOV AX selected. Pop BP. RET. ENP. Command complete INTR. Select timeout. Yes, read phase. Check REQ and phase bits. Target requesting message out. Select no message. Yes, send identify message. With disconnect / reselect. And target LUN. Save in message out byte. Clear upper. Send AX message to target. Send message. Remove parameter from stack. Timeout INTR occurred? No, unexpected interrupt. Return timeout error. Select exit. Return error. Successful selection. Bits. Fast track to SCSI Appendix 1. T. Transfer data to / from SCSI bus. General data transfer for all data transfer phases. Read or write a stream of bytes to / from the SCSI bus and check. For the following conditions. 1. Hashtag of bytes requested == hashtag of bytes transferred, normal. 2. Hashtag of bytes requested hashtag of bytes transferred, pad. 3. Hashtag of bytes requested. This routine, and the SBC, will accept a 24-bit number as a transfer length, allowing up to 16 M bytes to be read or written to the SCSI device in one data phase transaction. Entry, word at BP +4. Long at BP +6. Byte at BP 10. Pointer to list of bytes. Length, number of bytes in list. Transfer type, read =O or write =L. Exit, AX, error status. AX. Degree. Transferred all bytes in list. AX. Degree. Transfer terminated early. Transfer record. Datator. Length _ low. length underscore high, direction, transfer record, transfer data, stroke, DW, 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 ends, PROC, push, near, BP, MOV BP, SP, BP, IP, PTR to byte to transfer, LSW length of transfer, MSW length of transfer, direction, read equals O, write L, CLD auto increment DSI, MOVSI, BP.datator, point to stream of bytes, MOVDSID also, for read operation, labx SBC underscore pointer point to SBC, MOVL byte PTR BP.length underscore high, get length MSW, MOVTCHL load counter high, MOVX, BP.length underscore low, get length MSW, MOVTCM load counter mid, load counter low MOV, MOV, TCLL, SCMD084H do programmed I/O transfer, 305, Appendix 1, SFR CMD wait, SFR loop, writing, reading, SFR check INTR, test error, test parity error, 306, MOV, and, CMP, ALSSTS, ALAVO, ALOBO, Janes for CMD wait, CMP INSO, fast track to SCSI, read status, wait for, transfer, operation to start, connected as init and, transfer in progress, bit set, no, wait for SBC to start, INTR occurred, Janes for check INTR yes, CMP BP, dot direction right, writing, Jane reading no, reading, test SSTS02H, Janes for loop, LODS, MOVDREGL, JMPs for deck, test, Jane, MOV, STAS, JMP, test, SSTSL, SFR loop, ALDREG, SFR deck, INSO SH, FIFO not full, no wait, FIFO is full, read byte, inc SI, write byte to FIFO, decrement and check count, FIFO not empty, no, wait for byte, get byte, write byte, inc did, decrement slash check count, service required INTR, JE, MOV, MOV, JMP, test error INTR no, CMP, JE, MOV, INSO SH yes, clear it, AX, service underscore required, exit with error, SFR exit, INSO, test parity error, AX error underscore INTR, any more INTR pending? No. Yes, exit with error, JMP SFR exit, test, JE, MOV, SER/OCO, SFR loop, AX, parity underscore error, JMP SFR exit, parity error? No, wait for bytes. Yes, exit with error, fast track to SCSI, SFR deck, SFR done, SFR pad, SFR exit, transfer data, Appendix 1, Sub, SBB, MOV, or, bpj.length underscore low, 1, decrement count. bpj.1 underscore high o, 32-bit count. Ax, bpj.length underscore low, get length. Ax, bpj.length underscore his, equals o. Janes for loop no, continue. Test. JE. MOV. MOV. And. Or. MOV. And. CMP. MOV. Jane. MOV. 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 And. In solo. SFR done. In solo. AL-PCTL. AL7. AL080H. DLPSNS. AL087H. ALDL. Ax OK. SFR exit. Temp. Degree. SCTL085H. ALINS. AL018H. CMPLOL8H. Janes for pad. MOV INS18H. MOV AX OAK pad. POP DIV. POP SI. POP BP. RET. ENP. Command complete INTR? No, wait. Yes, reset INTR. Read phase control. Get bus phase bits. Add REQ bit. Read phase sense reg. Mask phase bits and REQ. Are we in new phase? Assume good status. JMP if in new phase. No, load temp with padding. Value. Do padding transfer. To cause target to go to next phase. Wait for CMD complete and SVC. REQ. No, wait for pad to finish. Reset inters. Return good with pad status. 307. Aundix 1 fast track to SCSI. LMFMG. WT, WTG. I. Send command. Send a SCSI command block to the target device. Assume TCH, TCM, and TCL registers equals 0. Entry, word at BP plus 4 pointer to SCSI command block. Word at BP plus 6, length of command block, 6, 10, 12 byte. Exit, AX, transfer status. 0 transferred all bytes in list. Select record. CMD underscore PTR. CMD underscore inth. Select record. Send command. Send command. 308. Stroke. DW. 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 Ends. PROC near. Push BP. MOV. Lay. MOV. MOV. Push. XOR. Push. 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 Call. MOV. Pop. RET. ENP. BPSP. BXSBC underscore pointer. PCTL02H. Ax, right. Ax. 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 BP.cmd underscore inth. BP.cmd underscore PTR. Transfer data. SPBP. BP. BP. IP. PTR to CMD bytes. Length of CMD. Point to SBC. Set command out phase. Write to target for transfer. Put parameters on stack. MSW of length equals 0. LSW length of CMD. PTR to CMD bytes. Do SCSI transfer. AX has the transfer status. Fast track to SCSI Appendix 1. Read SCSI status. Read the 1-byte status code from the target. Entry, word at BP +4, pointer to byte to hold SCSI status. Exit, AX, transfer status. 0 transferred SCSI status to pointer location. Status record stroke. DW. BP. DW. IP. Status _ PTR DW. PTR to status byte. Status record ends. Status in PROC near. Push BP. MOV BP SP. LayBX SBC _ pointer point to SBC. MOV PCTL03H set phase to status in. MOV AX, read read mode. Push AX. X or XX. Push AX MSW of transfer length. Inc AX LSW of length equals 1 byte. Push AX. Push BP. Status _ PTR pointer to status byte. Call transfer data read 1 byte from SCSI target. MOV SPBP AX equals result code. Pop BP. RET. Status in ENP. 309. Appendix 1, fast track to SCSI. Send message out. Send a 1-byte message to the target device. When the SBC is in the initiator mode, it will automatically negate the ATN signal after the message byte has been successfully sent to the target device. This is in conformance with the SCSI spec. See spec for further details. Entry, word at BP +4, pointer to message byte to send. Exit, AX, transfer status. 0, transferred message byte to target device. Message _ rec stroke. DW. DW. Message _ PTR DW. Message _ rec ends. Message _ PROC. Push. MOV. Lay. MOV. MOV. Push. X or. Push. Inc. Push. Push. Call. MOV. Pop. RET. Message _ out enp. 310. Near. BP. BPSP. BXSBC _ pointer. PCTL06H. AX, right. AX. AX AX. 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 BP, dot message _ out PTR. Transfer data. SPBP. BP. BP. IP. PTR to message out byte. Point to SBC. Set desired phase to message out. Send byte to SCSI bus. Perms on stack. MSW of transfer count. LSW equals 1 byte transfer. Pointer to message byte to send. Send it. AX has transfer status. Fast track to SCSI Appendix 1. Read message in. Read a 1-byte message from the SCSI target device. When the SBC is in the initiator mode, it will automatically hold the ACK line active on the last byte of the message received from the target device. This is to allow the initiator to interpret the message and accept or, if necessary, reject it according to the SCSI protocol's message reject sequence. See spec for further details. Entry, word at BP +4, pointer to address to hold message BYTJ. Exit, AX, transfer status. 0, transferred SCSI message to pointer location. DW. DW. Message underscore in underscore PTR DW. Message underscore in underscore resends. Message underscore in proc near. Push. MOV. Lay. MOV. MOV. Pus. XOR. Push. Inc. Push. Push. Call. Add. Or. JL. Lay. MOV. MOV. Mirror. BP. BP, SP. BXSBC underscore pointer. PCTL06H. Ax, read. Hax. Ax, ax. 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 BP.message underscore in underscore PTR. Transfer data. SP6. Ax ax. Mirror. BXSBC underscore pointer. SCMOOCO. In solo. Pop BP. RET. NP. BP. IP. PTR to message in byte address. Point to SBC. Set desired phase to message in. Read byte from device. MSW of transfer length. LSW of length equals 1 byte. PTR to message byte. Read message. Remove params from stack. If. Error. No error, point to SBC. Manually negate the X signal. Reset command complete INTR. 311. Appendix 1, Fast Track to SCSI. Read data stream from SCSI device. Read up to 16 MB from the target device. Entry, word at BP plus 4J. Long at BP plus 6J. Pointer to data buffer. Length of transfer 24-bit. Exit, AX, transfer status. 0, read byte from SCSI device. Data in record. Data in underscore PTR. Data in len 10. Data in len high. Data in record. Data in. Data in. 312. Stroke. DW. BP. DW. IP. DW. PTR to byte to transfer. DW. Length of transfer. DW. Ends. PROC near. Push BP. MOV. Lay. MOV. MOV. Push. 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 Call. MOV. Pop. RET. NP. BPSP. BXSBC underscore pointer. PCTLOL. Ax, read. Ax. Point to SBC. Desired phase. Read bytes from. BPJ.data underscore in underscore len underscore high, MSW of length. Data in. Target device. BPJ.data underscore in underscore len underscore low, LSW of length. BPJ.data underscore in FTR, pointer to receive buffer. Transfer underscore data read bytes. SPBPAX has result code. BP. Fast track to SCSI Appendix 1. Write data stream to SCSI device. Write up to 16 MB to the target device. Entry, word at BP plus 4J. Long at BP plus 6J. Pointer to data buffer. Length of transfer, 24-bit. Exit, AX, transfer status. Degree. Wrote bytes to SCSI device. Data out record stroke. DW. BP. DW. IP. Data underscore out underscore PTR DW. PTR to byte to transfer. Data out len 10 DW. LSW length of transfer. Data out len high DW. MSW. Data out record ends. Data out PROC near. Push BP. Move SP. Point to SBC. Lay. MOV. MOV. Push. 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 Call. MOV. BXSBC underscore pointer. PCTLO. Ax write. Set desired phase to data out. Write bytes to target device. Data out. POP. RET. ENP. AX. BPJ.data underscore out underscore len underscore high, MSW of length. BPJ.data underscore out underscore len underscore low, LSW of length. BPJ.data underscore out underscore PTR, address of bytes to send. Transfer underscore data send bytes to target. SPBP, AX has result code. BP. 313. Appendix 1, Fast Track to SCSI. Decode SCSI bus phase. After selection, read target's requested SCSI bus phase. And go to the appropriate handler, continue calling this routine until the command complete message is sent from the target, indicating the end of the SCSI operation. Entry, void. Exit, 0 successful operation. Oh no phase requested, REQ signal not active. Decode phase PROC. Lay. MOV. And. Sub. CMP. Near. BXSBC underscore pointer. AL PSNS. AL 087H. AL 080H. DPA. JMP table. 314. AL 7. JBDPA. JMP no phase REQ. MOV. XOR. SHL. JRNP. BLL. BHBH. BXL. CSJMP table BXJ. Label word. DWP underscore data underscore out. DWP underscore data underscore in. DWP underscore send command. DWP underscore status underscore in. DWP underscore illegal. DWP underscore illegal. DWP underscore message underscore out. DWP underscore message underscore in. Push. 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 Call. Add. JMP. At data length underscore high. At data length underscore low. At data pr. Data out. SP6. Decode done. Point to SBC. Read phase sense. Mask REQ plus phase. Subtract bias. Decode 0. 7. Make index into table. 16-bit. Asterisk 2 equals jump table PTR. Go to routine. Target requesting data out phase. Target requesting data in phase. Target requesting command phase. Target requesting status phase. Reserved. Reserved. Target requesting message out phase. Target requesting message in phase. Send data to target device. MSW number of bytes to send. LSW. PTR 2 bytes to send. Write bytes. Remove stack parameters. Return with AX equals transfer status. Fast track to SCSI. P data in. P send command. P status in. P underscore illegal. P underscore message underscore out. No phase REQ. Decode done. Push. 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 Call. Add. JMP. Push. MOV. Push. Call. Add. JMP. MOV. Push. Call. Pop. JMP. MOV. JMP. MOV. Push. Call. Pop. JMP. MOV. Push. Call. Pop. JMP. XOR. RET. Appendix 1. At data length underscore high. At data length underscore low. At data per. Data in. SP6. Decode done. Receive data from target device. MSW number of bytes to receive. LSW. PTR to byte buffer. Read bytes. Remove stack parameters. AX equals transfer status. Send SCSI command block to target. At length number of bytes in CMDBLK. AX, offset at CMDBLK, PTR to CMDBLK. AX stack it. Send underscore command send bytes. SP6. Decode done. Remove stack params. AX equals status. Read SCSI status from target. AX, offset at status, PTR to status bytes. AX stack it. Status in. CX. Decode done. Read status byte. Remove stack params. AX equals status. Undefined / reserved SCSI phases. AX, illegal underscore phase, AX equals error. Decode done. Send message to target. AX, offset at miscout, PTR to message byte. AX stack it. Message underscore out send it. CX. Decode done. Remove params. AX equals status. Read message from target. AX, offset at misgen, PTR to message byte. AX stack it. Message underscore in read it. CX. Decode done. AX. Remove params. AX equals status. Target not requesting, REQ. Negated. Return to caller, AX equals transfer. Status. 315. Appendix 1, Fast Track to SCSI. Manually transfer data to / from SCSI bus. Read or write a stream of bytes to / from the SCSI bus and check for completion. This example illustrates the use of the manual transfer mode of the SBC. This mode is useful for spoon-feeding each byte to a target device. This could be helpful when debugging SCSI software step-by-step or testing the behavior of a SCSI peripheral under certain conditions. This mode of operation does not use the transfer counter of the SBC. The transfer size is limited only by the size of the transfer length parameter passed to this routine. Entry, word at BP plus 4J. Long at BP plus 6J. Byte at BP LOJ. Pointer to list of bytes. Length, number of bytes in list. Transfer type, read equals O or write equals L. Exit, AX error status. AX0, transferred all bytes in list. AX. Manuals for rec-stroke. Man underscore dataver. Man underscore length underscore low. Man underscore length underscore high. Man direction. Manuals for rec. Mans for data. Mansfer 316. DW 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 ends PROC push MOV CLD MOV MOV lay CMP JE near BP BP SP BP IP PTR to byte to transfer. Length of transfer, up to 4 GB. 32 bits. Direction, read equals O, write equals L. Auto increment DSI. SI, bpj.dataadr, point to stream of bytes. DSID also, for read operation. bxSBC underscore pointer, point to SBC. bpj man underscore direction, read reading. Man read yes. Fast track to SCSI. Man write. MW no REQ. Man read. MR no REQ. Man deck. Mansfer exit. Mansfer data. Test. JZ. LODS. MOV. MOV. Test. JNZ. MOV. JMP. Test. JZ. MOV. Test. JNZ. MOV. STASB. MOV. Sub. SBB. MOV. Or. Jane. PSNSADH. Man write. Temp al. SCMDOEO. PSNSADH. MW no REQ. SCMDOCO. Mandec. PSNSADH. Man read. SCMDOEO. PSNSADH. MR no REQ. Altemp. SCMDOCO. Wait for REQ asserted. Not yet. Appendix 1. Read byte from buffer, inc SI. Load byte into temp register. Assert ACK. Wait for REQ negated. Indicating byte accepted. Not yet. Negate ACK. Decrement count. Wait for REQ asserted. Not yet. Assert ACK. Wait for REQ negated. Indicating byte sent. Not yet. Read byte from temp. Write to buffer, inc did. Negate ACK. bpj.man underscore length underscore low l. bpj.man underscore length underscore high o. Ax, bpj.man underscore length underscore low. Ax, bpj.man underscore length underscore high. Mansfer. Decrement count. 32-bit count. Get length. Equals O. Not done. MOV Ax, OK. Pop BP. RET. ENP. 317. Appendix 1, Fast Track to SCSI. DMA transfer data to / from SCSI bus. Read or write a stream of bytes to the SCSI bus using DMA. And check for the following conditions. 1. Hashtag of. 2. Hashtag of. 3. Hashtag of. Entry. Exit. Bytes requested equals hashtag of bytes transferred, normal. Bytes requested hashtag of bytes transferred, pad. Bytes requested. Word at BP plus 4J, pointer to list of bytes. Long at BP plus 6J, length, number of bytes in list. Byte at BP 10J transfer type, read equals O or write equals L. AX error status. AX0, transferred all bytes in list. AX. Note, if the SBC is interrupt driven along with using DMA, the code below becomes even smaller since it is not necessary to test the ints register within a loop. In fact, the overhead to start a data transfer in the SBC takes only 3 steps. 1. Write desired phase to PCTL register. 2. Write 1 to 3 bytes to the transfer counters, TCH/M/L. 3. Write the DMA transfer CMD to SCMD register, AUX80. DMAs for record stroke. DW. BP. DW. IP. DMA _data _PTR DW. PTR to byte to transfer. DMA _length _low DW. LSW length of transfer. DMA _length _high DW. MSW length of transfer. DMA direction DW. Direction, read equals O, write equals L. DMAs for record ends. DMA transfer data PROC near. Push BP. MOV BP, SP. Push BPJ.DMA _direction get direction. Push BPJ.DMA _length _high length. Push BPJ.DMA _length _low. Push BPJ.DMA _data PTR and address. 318. Fast track to SCSI Appendix 1. Call set up the system's DMA controller. MOV SPBP remove stack params. LabX SBC _pointer point to SBC. MOV al byte PTR BP, .DMA _length _high, MSWOF. Transfer size. MOV TCH al, store in counter high. MOV X, BP, .DMA _length _low, LSW of transfer size. No CMD CMP. Complete. DMA done. DMA transfer data. MOV TCM A store in counter mid. MOV TCL AL store in counter low. MOV SCTL 080H start DMA transfer. CMP. JE. Test. JE. MOV. JMP. MOV. JMP. POP. RET. ENP. INTS. O. NOLTR. INTS O low. No CMD CMP. AX OK. DMA done. AX error _. DMA done. BP. INTR. Wait for INTR, signaling. The end of the DMA. Transfer. No INTR yet. CMD complete INTR? No, transfer error. Transfer successful. Transfer didn't properly. 319. Appendix 1, Fast Track to SCSI. 320. Appendix 2. SBC driver examples. In C language, the following code is a group of routines that demonstrate the essential elements necessary for the implementation of a SCSI driver using Fujitsu's family of controllers. These routines make certain assumptions about the hardware interface, but are software compatible with all the Fujitsu SCSI control. For this example, the controller is memory mapped somewhere in the address space of the host CPU. This example assumes that the controller will be used in a polled environment, not interrupt-driven, using programmed I/O, no DMA. Using the device in this mode requires much more code than an interrupt-driven/DMA environment, but the code will be less dependent on system hardware. At the end of this example is a rewrite of the data transfer routine. DMA transfers instead or Programmed I/O. As can be seen, the code is considerably smaller and simpler. This code is intended to show the programming and operation of the major functions of the Fujitsu family of SCSI controllers. It is not intended as a tutorial of the SCSI protocol or to show the construction of a driver for an SCSI host adapter. This code was tested for syntax errors under the following compilers: Borland Turbo C 2.0, 321, AOpenDix 2, Fast Track to SCSI, / 1 star, 1 star, 1 star, 1 star, /*, 1 star, 1 star, 1 star, 1 star, /*. For detailed information on the SCSI protocol, see the spec entitled ANSI Small Computer System Interface, SCSI. ANSI X 3.131-1986. American National Standards Institute Incorporated. 1430 Broadway, New York, New York, 10018. Asterisk 1. 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 1. /* for information on Fujitsu SCSI controllers * 1. 1 * contact, * 1. 1 ** I. / 1 star. 1 star. 1 star. 1 star. 1 star. 1 star. Fujitsu Microelectronics Incorporated. 3545 North 1st Street, San Jose, CA.95134-1804. 408-922-9000. Or your local Fujitsu representative. Asterisk 1. 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 /*1. 1 ** I. / 1 star. 1 star. Copyright, C. 1989 Fujitsu Microelectronics Inc. Copyright, C. 1989 Galbo and Associates Incorporated. Asterisk 1. Asterisk 1. Asterisk 1. 1. 322. Fast Track to SCSI Appendix 2. 1. I * Constants * 1. 1 / I * selection timeout delays. Hashtag define selection timeout 4400L. Hashtag define bus delay 4. / 275 millisecond at 8 MHz / / 1200 nsec at 8 MHz / data transfer direction * hashtag define read. Hashtag define write. 1. / read from SCSI bus * / write to SCSI bus * 1 * selection return values * hashtag define selected 100 / target successfully selected * hashtag define lost arbitration -100 / selection failed * hashtag define timeout -101 / selection failed * hashtag define error intr -102 * unexpected interrupt occurred * 1 * data transfer return values * hashtag define OK 200 / transfer complete * Hashtag define okpad 201 / transfer complete with padding */. Hashtag define service _ required -200 * early phase change */. Hashtag define parity error -201 * read parity error */. / phase decoder return values */. Hashtag define no _ phase _ requested 0. Hashtag define illegal phase -300 * illegal SCSI phase requested */. Hashtag define default SBC address oxt colfa all. */ 323. Appendix 2 Fast track to SCSI. /1. / all Fujitsu SCSI controllers contain the following 16 *1. / 8-bit registers. This structure assumes the compiler that can *1. / pack bytes within structures. *1. /1. Struct SPCREGPACK. Volatile unsigned char. _BDID, 1 * bus device ID *1. SCTL, 1 * SBC control *1. SCMD, 1 * SBC command *1. TMOD, 1 * transfer mode *1. INS, 1 star. Interrupt sense *1. _PSNS, 1 * phase sense *1. SSTS, 1 * SBC status *1. SIR, 1 * SBC error status *1. _PCTL, 1 * phase control *1. _MBC, 1 * modified byte counter *1. DREG, 1 * FIFO data register *1. _temp, 1 * temporary register *1. _TCH, 1 * transfer counter high *1. _TCM, 1 * transfer counter mid *1. _TCL, 1 * transfer counter low *1. _EXBF, 1 * external buffer *1. Far *SBC equals, struct spraypack far *, default _SBC _address. /1. / assume the Fujitsu SCSI protocol controller is accessed via *1. / memory mapped addressing, the following constants are used *1. 1 * to read and write to the registers. *1. 1. Hashtag define BDID SBC _BDID. Hashtag define SCTL SBC _SCTL. Hashtag define SCMD SBC _SCMD. Hashtag define TMOD SBC _TMOD. J/define ints SBC _ints. Hashtag define PSNS SBC _PSNS. Hashtag define SSTS SBC _SSTS. Hashtag define SIR SBC _SIR. Hashtag define PCTL SBC _PCTL. Hashtag define MBC SBC _MBC. Hashtag define DREG SBC _DREG. Hashtag define temp SBC _temp. Hashtag define TCH SBC _TCH. 324. Fast track to SCSI Appendix 2. Hashtag define TCM SBC _TCM. Hashtag define TCL SBC _TCL. Hashtag define EXBF SBC _EXBF. Hashtag define SDGC SBC _PSNS, /*. The SDGC reg has the */. Same address as PSNS */. 1 / array to convert SCSI addresses to SCSI IDs, For arbitration asterisk slash. Unsigned char address to ID aux0l, aux02, aux04, aux08. aux.lo, aux20, aux40, aux80. /1. ** variables needed for this example. */ Unsigned char. Int. Unsigned char. Misgen, misgout, status. Length, data length. CMDPTR, data pr. Extern void setup underscore DMA, unsigned char asterisk, unsigned long, int. // asterisk function prototypes asterisk 1. // void. Int. 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 Init underscore SPC, int. Select, int, int. Transfer underscore data, unsigned char asterisk, unsigned. Send underscore command, unsigned char asterisk, int. Status underscore in, unsigned char asterisk. Long, int. Long. Long. Message underscore in, unsigned char asterisk. Message underscore out, unsigned char asterisk. Data underscore in, unsigned char asterisk, unsigned. Data underscore out, unsigned char asterisk, unsigned. Decode fhase, void. Manual underscore transfer underscore data, unsigned char. DMA underscore transfer underscore data, unsigned char star. Asterisk, unsigned long, int. Unsigned long, int. 325. AOpenDix2 fast track to SCSI. // 1 asterisk initialize SBC asterisk 1. 1 asterisk initialize SCSI controller. Asterisk 1. 1 asterisk asterisk 1. 1 asterisk entry init underscore address, SCSI address of initiator D. 7 asterisk 1. 1 asterisk exit void asterisk 1. /1. Vold. LNT. 1 star. 1 star. / 1 star. SCTL. BDLD. TMOD. SCTL. SDGC. Init underscore SPC init underscore address. Init underscore address, 1 asterisk this initiator's SCSI address, D7 asterisk 1. DXCD. Init underscore address. DXDD. 1 asterisk reset controller asterisk 1. Release reset with arbitration on, parity checking on. Reselection on, initiator, hardware interrupts disabled. XLA. DXDD. Asterisk 1. 1 asterisk nos for INTR for 89,352. Asterisk 1. Asterisk 1. Asterisk 1. Asterisk 1. 1 1. I select target I. 1 star. I. 1 star. 1 star. 1 star. 1 star. Arbitrate for the SCSI bus and select a target device. Asterisk 1. Entry. Exit. Targ underscore address, target SCSI bus address, D7. Targ underscore LUN, target's LUN, logical unit number. D if successful selection. Asterisk 1. Asterisk 1. Asterisk 1. Asterisk 1. Asterisk 1. 1I. In select, targ underscore address, targ underscore LUN. In targ underscore address, 1 asterisk the selected target's SCSI address, 0. 7 asterisk 1. int 1 asterisk the selected target's logical unit number asterisk 1. PCTLDXDD, 1 asterisk phase control reg indicates selection phase asterisk 1. 1 star. 1 star. 1 star. 1 star. 1 star. 1 star. Asterisk 1. Set the temp register to the target's SCSI ID, not address, asterisk 1. ORed with the initiator's ID, in the BDID register. This asterisk 1 is done so that the target knows the ID of the initiator for asterisk 1. Reselection purposes. Asterisk 1. Asterisk 1. Temp equals BDID I address to ID targ underscore address. 1 asterisk asterisk 1. 1 asterisk the transfer counter registers double as selection timeout asterisk 1. 326. Fast track to SCSI appendix 2. Slash asterisk. Slash asterisk. Slash asterisk. Slash asterisk. TCH. TCM. TCL. Slash asterisk. 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 SCMD. Slash asterisk. Slash asterisk. Slash asterisk. SCMD. Slash asterisk. Slash asterisk. Slash asterisk. Slash asterisk. Slash asterisk. Registers during ARB slash selection. Set these registers to the asterisk slash. Desired value. The timeout values are dependent upon the asterisk slash. SBC's clock speed. Asterisk slash. Asterisk slash. Selection timeout 8, slash asterisk high byte of selection timeout asterisk slash. Selection timeout and oxf, slash asterisk low byte of selection timeout asterisk slash. Bus underscore delay, slash asterisk bus settle and bus free delay asterisk slash. Asterisk slash. Assert the SCSI attention signal during the selection phase, asterisk slash. This will notify the target that the initiator wants to send asterisk slash. An identify message after successful selection. The ATN asterisk slash. Signal will not be activated until after the selection asterisk slash. Phase has successfully completed. Equals aux 60, slash asterisk assert ATN signal. Start the arbitration and selection sequence. Equals aux slash asterisk send select command. Asterisk slash. 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 Wait for the interrupt register to signal the end of the asterisk slash. Selection phase or check if the SBC lost the bus arbitration asterisk slash. Phase. Asterisk slash. Asterisk slash. Slash asterisk wait for interrupt indicated asterisk slash while. Ints. Slash asterisk if no interrupt, check for lost arb asterisk slash. Slash asterisk. Slash asterisk. Slash asterisk. Slash asterisk. Slash asterisk. If. SSTS and aux20 slash asterisk test if arb slash selection still in. Progress asterisk slash. Slash asterisk arb slash selection finished, no. INTR pending asterisk slash. Return, lost underscore arbitration, slash asterisk indicate unsuccessful selection asterisk slash. An interrupt occurred, check if it's the command complete. Interrupt, indicating successful arb slash selection. If, ints and aux slash asterisk command complete intr bit set. Asterisk slash. Asterisk slash. Asterisk slash. Asterisk slash. Asterisk slash. Asterisk slash. Slash asterisk command complete interrupt indicated. Asterisk slash. Slash asterisk arb slash selection was successful, check if target is requesting asterisk slash. Slash asterisk a message out, if so, send the identify message with the asterisk slash. Slash asterisk disconnection and reselection supported bit set and an asterisk slash. Slash asterisk initiator Lenovo. Asterisk slash. Slash asterisk slash. 327. Appendix 2 Fast track to SCSI. If PSNS and AUX87 equals AUX86 if target requesting message out asterisk slash. Slash asterisk phase after selection asterisk slash. Slash asterisk. I star. Misgout equals auxgo I targ underscore lun, slash asterisk support disconnect slash reselect asterisk slash. Message underscore out, and misgout, slash asterisk send message asterisk slash. Slash asterisk, and select the target lun asterisk slash. Else slash asterisk no command complete intr asterisk slash. An interrupt occurred but it was not command complete, indicating that the arb slash selection was not successful. If, ints and aux04, slash asterisk timeout interrupt. Asterisk slash. Return, timeout, slash asterisk indicate timeout asterisk slash. Else slash asterisk not timeout intr asterisk slash. Return, error underscore intr, slash asterisk must be a bus reset, disconnect. Slash asterisk, or SBC error intr. Or. Return, selected, slash asterisk indicate successful arb slash selection. Slash asterisk, we are connected to the target. Asterisk slash. 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 I slash. Slash asterisk transfer data to slash from SCSI bus asterisk slash. Slash asterisk read or write a stream of bytes to the SCSI bus and asterisk slash. Slash asterisk check for the following conditions, asterisk slash. 1 asterisk slash. 1 asterisk 1, hashtag of bytes requested equals hashtag of bytes transferred, normal asterisk slash. 1 asterisk 2, hashtag of bytes requested hashtag of bytes transferred pad asterisk slash. 1 asterisk 3, hashtag of bytes requested. 1 asterisk slash. Slash asterisk. Slash asterisk. 1 star. Slash asterisk. Slash asterisk. Entry. Exit. DP, pointer to list of bytes. Length, number of bytes in list. Transfer type, read or write. 0, transferred all bytes in list. Asterisk slash. Asterisk slash. Asterisk slash. Asterisk slash. Asterisk slash. 1 slash. Int transfer underscore data, DP. Unsigned char. Unsigned long. Int. Length 16. Length, IO. Asterisk DP. Length. IO, slash asterisk transfer type read or write asterisk slash. Slash asterisk high byte of transfer count asterisk slash TCH. TCM, length 8, and OXF, slash asterisk middle byte asterisk slash. 328. Fast track to SCSI appendix 2. Slash asterisk. Slash asterisk. Slash asterisk. Slash asterisk. Slash asterisk. Slash asterisk. TCL equals length and OXF, slash asterisk low byte. Start SCSI programmed IO transfer. SCMD equals AUX84. Wait for SBC to start processing the command. asterisk slash, 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 while SSTS and oxfo equals oxpo, slash asterisk asterisk slash, slash asterisk wait for an available location in the output FIFO, then asterisk slash, slash asterisk, 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 send byte, asterisk slash, while, length, if, ints, asterisk slash, slash asterisk while not finished sending asterisk slash, slash asterisk send while no interrupts pending asterisk slash, asterisk slash, read or write a byte to the SBC's FIFO, if, IO write, write a byte to the FIFO, if, SSTS and OX02, DREG equals asterisk DP plus plus, length, else, if, asterisk slash, the FIFO is not full, asterisk slash, slash asterisk if space in FIFO asterisk slash asterisk write byte to FIFO, bump PTR asterisk slash asterisk decrement byte count asterisk slash. Read a byte from the FIFO if the FIFO is not empty. Asterisk slash. Asterisk slash. Asterisk slash. If. SSTS and OXOL. Else. Asterisk DP plus plus equals DREG. Length. If, ints and OX08. Slash asterisk if space in FIFO asterisk slash. Slash asterisk read byte to FIFO, bump PTR asterisk slash. Slash asterisk decrement byte count asterisk slash. Slash asterisk an interrupt is pending asterisk slash. Slash asterisk, check type asterisk slash. Slash asterisk if SVCREQINTR asterisk slash. Asterisk slash. 329. Appendix 2, fast track to SCSI. 1 star. Slash asterisk. 1 star. Slash asterisk. 1 star. 1 star. 1 star. Slash asterisk. 1 star. 1 star. 1 star. Slash asterisk. Slash asterisk. Slash asterisk. Slash asterisk. 330. Ints equals aux08, slash asterisk reset service required asterisk slash. Return, service underscore required, slash asterisk exit early asterisk slash. Else if, ints. Slash asterisk if other intr asterisk slash. Return, error underscore intr, slash asterisk bus release, reset, SBC error intr asterisk slash. Else if, SIR and OXCO. Slash asterisk read parity error. Asterisk slash. Return, parity underscore error. Slash asterisk, process later asterisk slash. All bytes, length, in data stream have been transferred. Check for command complete interrupt after all data sent. While ints and oxelo. Ints equals oxelo. Slash asterisk wait for cmd complete asterisk slash. Slash asterisk reset cmd complete intr asterisk slash. If target has not changed phase after sending all bytes, then we should pad the transfer to let the target continue to the next phase. If PCTL and OX07 temp SCMD 0 OX8S IOX80 equals equals, PSNS and aux87, slash asterisk new phase. Asterisk slash. Slash asterisk same phase asterisk slash. Slash asterisk do pad transfer, pad with O's for write asterisk slash. Slash asterisk start program transfer pad out asterisk slash. T. The completion of the padding transfer is indicated by the command complete intr and the service required intr, since the target will normally change phase at the end of the transfer. While ints and aux18 equals aux18 slash asterisk wait for pad to complete asterisk slash. Ints equals aux18 slash asterisk reset intrs asterisk slash. Return, okpad. Else. Return, OK. Slash asterisk target has gone to next phase asterisk slash. Slash asterisk transfer completed normally asterisk slash. 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 Fast track to SCSI Appendix 2. Slash slash. Slash asterisk send command asterisk slash. Slash asterisk send a SCSI command to the target asterisk slash. Slash asterisk assume, tch, tcm, tcl regs equals 0 asterisk slash. Slash asterisk. Slash asterisk. Slash asterisk. Slash asterisk. Slash asterisk. Entry. Exit. Asterisk slash. CP, pointer to SCSI command stream asterisk slash. Length, length of the command, 6, 10, or 12 bytes asterisk slash. 0, transferred all bytes in list asterisk slash. Slash slash. Int send underscore command, CP, length. Unsigned char asterisk CP. Int length. Slash asterisk pointer to command stream asterisk slash. Slash asterisk length of command stream asterisk slash. PCTL equals aux02, slash asterisk indicate command phase asterisk slash. Slash asterisk. Slash asterisk. Slash asterisk. Start transfer. Return, transfer underscore data, CP, length, read. Asterisk slash. Asterisk slash. Asterisk slash. Slash slash. Slash asterisk read status in asterisk slash. Slash asterisk read the 1 byte status code from the target. Asterisk slash. Slash asterisk. Slash asterisk. Slash asterisk. Slash asterisk. Entry. Exit. SP, pointer to status byte. 0 successful read. Asterisk slash. Asterisk slash. Asterisk slash. Asterisk slash. Slash slash. Int status underscore in, SP. Unsigned char SP, slash pointer to status byte asterisk slash. PCTL equals aux03, slash asterisk indicate status phase asterisk slash. Return, transfer underscore data, SP, 1, read. 331. Appendix 2, fast track to SCSI. 1 slash. 1 star. Slash asterisk. I. 1 star. 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 Send message out asterisk slash. Send a 1 byte message to the target. Asterisk slash. When the SBC is in the initiator mode, it will automatically asterisk slash. Negate the ATN signal after the message byte has been asterisk slash. Successfully sent to the target device, this is in conformance *1. With the SCSI spec. See spec for further details, */ Entry. Exit. MP, pointer to message byte. 0 successful read. */ */ */ *1/ int message _out, MP. Unsigned char *MP. PCTL equals aux06, / indicate message phase */. Return, transfer _data, MP, 1, write. 1/ / read message in */. 1 * read a 1 byte message from the target */. 1 * when the SBC is in the initiator mode it will automatically */. 1 * hold the ACK line active on the last byte of the message */. 1 * received from the target device. This is to allow the */. 1 initiator to interpret the message and accept or, if */. 1 * necessary, rejected according to the SCSI protocols */. 1 * message reject sequence. See spec for further details, */. 1 * rejected according to the SCSI protocols message reject *// sequence. See spec for further details, *// 1 * 1 * 1 * Entry. Exit. MP, pointer to message byte. 0 successful read. *// *// *// *// 1/ int message _in, MP. Unsigned char *MP. 332. int RV. PCTL, aux06. RV equals transfer _data, MP. If, RV0. SCMD. Ints. Auxco. Auxelo. / indicate message phase */. 1, write, / save return value */. / if message read successfully *1. / manually negate the ACK signal */. / reset CMD complete intr */. Fast track to SCSI Appendix 2. Return, RV. / read SCSI data */ read up to 256 MB from the target device. */ entry, MP, pointer to byte stream *// length, number of bytes to read / int data _in, MP. Unsigned char. Unsigned long. Length. *MP. Length. PCTL equals aux/ol, / indicate data in phase */. Return, transfer _data, MP, length, read. / write SCSI data */ write up to 256 MB to the target device. */ entry, MP, pointer to byte stream *// length, number of bytes to write / int data _out, MP length. Unsigned char *MP. Unsigned long length. PCTL equals aux/o, / indicate data out phase */. Return, transfer _data, MP, length, write. 333. Unix 2 fast track to SCSI. 1 slash 1 asterisk decode SCSI bus phase asterisk slash 1 asterisk after selection, read targets requested SCSI bus phase asterisk slash 1 asterisk and go to the appropriate handler, continue calling this asterisk slash 1 asterisk routine until the command complete message is sent from the asterisk slash 1 asterisk target asterisk slash asterisk asterisk slash 1 star 1 star I exit 0 successful operation. Oh no, phase requested, REQ signal not active. Asterisk slash asterisk slash asterisk slash 1 slash LNT decode underscore phase 334 switch PSNS and aux87 case aux80 slash asterisk read phase sense reg asterisk slash asterisk REQ bit aux80 must be active asterisk slash return data underscore out data per data length case aux8L return data underscore in data per data length case aux82 return send underscore command cmdptr length case aux83 return status underscore in and status case aux84 case aux8s return illegal underscore phase case aux86 slash asterisk undefined SCSI phases asterisk 1 slash asterisk should never see these asterisk slash return message underscore out and misg out case aux87 return message underscore in and misgen default return no underscore phase underscore requested slash asterisk REQ bit is not active asterisk slash fast track to SCSI appendix 2 1 1 star 1 star 1 star manually transfer data to slash from SCSI bus read or write a stream of bytes to slash from the SCSI bus and check for completion asterisk slash asterisk slash asterisk 1 1 asterisk asterisk 1 1 asterisk this example illustrates the use of the manual transfer mode asterisk 1 1 asterisk of the SBC. This mode is useful for spoon feeding each asterisk slash 1 asterisk byte to a target device. This could be helpful when debugging asterisk 1 asterisk SCSI software step by step or testing the behavior of a SCSI asterisk slash 1 star slash asterisk slash asterisk slash asterisk slash asterisk 1 star 1 star slash asterisk 1 star 1 star slash asterisk peripheral under certain conditions. This mode of operation does not use the transfer counter of the SBC. The transfer size is limited only by the size of the transfer length parameter passed to this routine. Entry DP, pointer to list of bytes. Length, number of bytes in list. Type, read or write. Exit, D, transferred all bytes in list. Asterisk slash. Asterisk slash. Asterisk 1. Asterisk 1. Asterisk slash. Asterisk 1. Asterisk slash. Asterisk slash. Asterisk 1. Asterisk 1. Asterisk 1. Slash 1. Int manual underscore transfer underscore data, DP, length, type. Unsigned char asterisk DP. Unsigned long length. Int eep. Do. If, type equals write. Slash asterisk write to SCSI asterisk slash. While. PSNS and DX8D slash asterisk wait for REQ asserted, indicating asterisk 1. Slash asterisk, target ready for byte asterisk slash. Temp equals asterisk DP plus plus. SCMD equals DXED. While, PSNS and OX8D. SCMD equals DXCD. Else. Slash asterisk write byte asterisk slash. Slash asterisk assert ACK, indicating byte on bus asterisk 1. Slash asterisk wait for REQ negated, indicating asterisk slash. Slash asterisk, target received byte asterisk slash. Slash asterisk negate ACK, indicating operation. Complete asterisk slash. Slash asterisk read from SCSI asterisk slash. While. PSNS and DX80 slash asterisk wait for REQ asserted, indicating asterisk 1. Slash star. Target placed byte on bus asterisk slash. SCMD equals OXO. While, PSNS and DX8D. Slash asterisk assert ACK, indicating init accepted byte asterisk 1. Slash asterisk wait for REQ negated, indicating asterisk slash. Slash asterisk, target finished driving bus asterisk slash. 335. Appendix 2, fast track to SCSI. 1 asterisk read byte asterisk 1 asterisk DP plus plus equals temp. SCMD equals OXCO, 1 asterisk negate ACK. Indicating operation complete asterisk I. While, dash length. Return, OK. 1 asterisk decrement slash test length asterisk 1. 1 asterisk exit asterisk 1. 1 I. 1 star. DMA transfer data to slash from SCSI. Read or write a stream of bytes to the SCSI bus using DMA. And check for the following conditions. Asterisk 1. Asterisk 1. Asterisk 1. 1 asterisk asterisk I. Slash asterisk 1, if of bytes transferred equals if of bytes requested, normal asterisk 1. 1 asterisk 2, if of bytes transferred if of bytes requested, pad asterisk 1. 1 asterisk 3, if of bytes transferred. 1 asterisk asterisk slash. 1 asterisk entry DP, pointer to list of bytes asterisk slash. 1 asterisk length, number of bytes in list asterisk slash. 1 asterisk type, read or write asterisk slash. I asterisk exit, 0, transferred all bytes in list asterisk slash. 1 asterisk. 1 asterisk asterisk slash. 1 star. 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 Note, if the SBC is interrupt driven along with using DMA asterisk slash. The code below becomes even smaller since it is not asterisk slash. Necessary to test the ints register within a loop. Asterisk slash. In fact, the overhead to start a data transfer in asterisk slash. The SBC takes only 3 steps, asterisk slash. 1. Write desired phase to PCTL register. 2. Write 1 to 3 bytes to the transfer counters. TCH/M/L. 3. Write the DMA transfer CMD to SCMD register. AUX80. Asterisk slash. Asterisk 1. Asterisk slash. Asterisk 1. Asterisk 1. Asterisk slash. 1 slash. Int DMA underscore transfer underscore data DP, length, type. Unsigned char asterisk DP. Unsigned long length. Int type. 336. Setup underscore DMA DP, length, type. TCH equals length 16. TCM equals, length 8, and oxf. TCL equals length and oxf. SCMD equals ox80. While ints. If, ints and oxl 0. Slash asterisk transfer type read or write asterisk slash. Slash asterisk set up the DMA controller asterisk 1. Slash asterisk high byte of transfer count asterisk slash. Slash asterisk middle byte asterisk slash. Slash asterisk low byte asterisk slash. Slash asterisk start DMA transfer asterisk slash. Slash asterisk wait for an interrupt asterisk 1. Slash asterisk if CMD complete INTR asterisk 1. Fast track to SCSI appendix 2. Return, OK, slash asterisk, done asterisk slash. Return, service underscore required, slash asterisk handle other interrupt later asterisk slash. Slash slash. Asterisk asterisk slash. Slash 1. 337. Appendix 2, fast track to SCSI. 338. Appendix 3. Control sequence. For SBC driver. The following examples show the essential elements necessary for the creation of a SCSI. Software driver using Fujitsu's family of SCSI controllers. Flowcharts are provided to outline the overall sequence of operation. Code that is dependent on the operating environment such as error processing, exception handling, and the operating system. Interface are not shown for the sake of brevity and clarity. This example assumes that the SCSI controller is accessible via memory-mapped I/O and is controlled by an 8086 family processor. This code will operate on any of the Fujitsu SCSI controllers. 339. Appendix 3. Initialize controller. Init address EQU7. Initialize. MOVSCTL, OCOH. MOVBDID, init address. MOVTMOD, 0. MOVSDGC, 0. MOVSCTL, a lot. RET. 340. Fast track to SCSI. Reset controller. Load init SCSI address, 0. 7. Async IO. Diagnostic mode off. Relay reset with arbitration on. Parity check on, reselect on. H/W interrupt off. Fast track to SCSI append, X3. Initialize controller. Initialize SBC. Plus. Reset SBC. Dash plus. Load initiator address. Plus. Clear registers. Plus. Enable arbitration. Parity checking and reselection. Plus. Disable hardware interrupts. Plus. Enable SBC operation. 341. Appendix 3, fast track to SCSI. Arbitrate and select phase. Entry, BL target bus ID, 1, 2, 4, 8, 16, 32, 64, 128. STD. BFD. Wait. EQU. EQU. MOV. Or. MOV. 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 CMP. JNZ. Test. JNZ. Lastarb. BH target LUN. 4400. 4. PCTLO. BLBDID. Temp BL. TCH high, STD. TCH low, STD. TCLBFD. SCMD 60H. SCMD 10H. INSO. INTR. SSTS20H. Wait. Process lost arbitration. 342. 275 millisecond. 1200 sec. Indicate selection phase, IO0. Or in initiator bus ID. So target can reselect. Set target and init bus ID. During selection. Set MSB of cell timeout value. Set LSB of cell timeout value. Set bus settle plus bus free delay. Assert ATN signal. Start ARB and selection sequence. INTR occur? Yes. Operation in progress? Yes. No, lost arbitration. Fast track to SCSI Appendix 3. Arbitrate and select phase, continued. INTR. Test. JNZ. Test. JNZ. JMP. Connected. Call. JC. MOV. Or. Call. Noident. RET. Other. INSLOW. Connected. INS04H. Timeout. Other. CheckMScout. Noident. ABH. AOCOH. MSCOUT. Selection successful? Yes, continue. Target, timeout error? Yes, process. Process error. Check for message out phase in order. To send identify message. Load desired target LUN. Send identify, with support for disconnection and reselection. Send message. Target successfully selected. Process unexpected condition. Bus reset or SBC hardware error. 343. Appendix 3. Arbitrate and select phase. 344. Load bus free plus. Bus settle delay. Process timeout. Fast track to SCSI. Fast track to SCSI. Command phase. Entry. Send command. Sync. COUD. Quate. ESSE, SCSI command. CL equals command length, 6,10 or 12. TCH, TCM, TCL equals 0. MOV TCL CL load transfer count. MOV PCTL02H command phase. MOV SCMD84H program transfer. MOV ALOFOH wait for SBC command. And ALSSTS check init and busy bit. CMP ALOBOH ready? JNE sync no, wait. Test SSTS02HFIFO full? JNE COUD yes, wait. LODS byte PTRES, SMED byte, INC PTR. MOVDREGAL send byte to SCSI. DECCL count done? JNZ COUD no. CMP INS OINTR occur? JZ quate no, wait. Test INS 10H command completed? JZCERR no, process error. 2. MOV INS 10H reset CMD complete INTR. RET finished. CERR. Process unexpected condition. Bus reset, disconnect or SBC hardware error. Appendix 3. Begin. 345. Appendix 3 fast track to SCSI. Command phase. Send command. Load transfer count. Phase equals command. Start program transfer. R. 346. Fast track to SCSI Appendix 3. Message out phase. Entry, A equals message byte. TCH, TCM, TCL, equals 0. ATN signal is asserted. Misgout. Sync. MOV. 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 N. CMP. JNE. MOV. MOUT. MERR. CMP. JZ. Test. JZ. MOV. RET. TCLL. PCTL06H. SCMD84H. AL of 1H. ALSSTS. ALOB1H. Sync. DREGA. INSO. MOUT. INSLO. MERR. INSLO. Process unexpected condition. Transfer 1 byte. Specify message out phase. Program transfer. Wait for SBC command to begin. Check init and busy bit. Ready and FIFO empty? No, wait. Send byte and automatically. Negate ATN signal. INTR. Not yet. Command completed? No, process error. Reset CMD complete INTR. Finished. Bus reset, disconnect or SBC hardware error. 347. Appendix 3, Fast Track to SCSI. Message out phase. Start program transfer. N. 348. Fast Track to SCSI Appendix 3. Data in phase. Entry, BX equals byte count. ESD equals data buffer pointer. Must handle 3 conditions. 1. Targets first exact byte count requested. 2. Targets first more bytes than requested, pad input. 3. Targets first less bytes than requested, phase change. Dayton. CLD. MOV. 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 Sync. MOV. N. CMP. JNE. Deloop. CMP. JNE. Test. JNZ. MOV. STOS. DEC. JNE. TCMBH. TCLBL. PCTLOLH. SCMD84H. ALOFOH. ALSSTS. ALOBOH. Sync. INSO. DISC. SSTSOLH. Deloop. ALDREG. Byte PTRESD. BX. Deloop. Clear direction flag. Load count, 0. 65,535. Data in phase. Program transfer. Wait for SBC command to begin. Check init and busy bit. Ready. No, wait. Any enters? Yes, process. FIFO empty? Yes, wait. Read byte. Store ending PTR. Done. 349. Appendix 3. Data in phase, continued. DICC. DIPAD. Test. JZ. MOV. MOV. N. CMP. JNE. INSLO. DICC. INSLO. AL87H. ALPSNS. AL81H. DIEXIT. SBC command complete? No, wait. Reset INTR. Target still in data in phase? Read phase sense register. REQ plus data in phase. Fast track to SCSI. MOV. Dijksr. Test. JZ. MOV. SCMD8SH. INS18H. Dijksr. No, exit normally, exact transfer. Target has more, pad input. Programmed for pad, long sphere. INS18H, command complete plus service required INTR. Die exit, no, wait for pad to finish. Reset INTR's RET. Disk. Test INS08H, done. JZD error. MOV INS08H, service REQINTR, phase change. Tests ROCOH no, process error INTR. JNZD error, yes, sphere halted, short sphere. Process phase chaj righty error? Yes. D error, no, short transfer. Process unexpected condition. Bus reset, disconnect, parity or SBC. Hardware error. 350. Fast track to SCSI Appendix 3. Data in phase. Error exit. 351. Appendix 3 Fast track to SCSI. Data out phase. Entry. Metadata out. Call. MOV. 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 May outwait. CMP. JE. Test. JZ. MOV. RET. 352. BX equals transfer count. ESSI equals data buffer address. Setma. TCMBH. TCLBL. PCTLO. SCMDADH. INSO. Mayout Y. T. INSLO. PUI. INSLO. Set up DMA controller. Load transfer count. Set data out phase. DMA transfer. Wait for DMA to complete. Command complete INTR. Process unexpected interrupt. Reset INTR. Exit. Fast track to SCSI Appendix 3. Data out phase, continued. DOCC. Test. JZ. MOV. MOV. N. CMP. JNE. DOPAD. MOV. MOV. DOCSR. Test. JZ. MOV. DOEXIT. RET. DOSC. Test. JZ. MOV. Process. DORER. INSLO. DOCC. INSLO. ALB7H. ALPSNS. ALBO. DOEXIT. Temp, 0. SCMDB5H. INSLBH. DOCSR. INSLBH. INSOBH. DORER. INSOBH. Phase change. SBC command complete? No, wait. Reset INTR. Target still in data out phase? Read phase sense register. REQ plus data in phase? No, exit normally, exact transfer. Target has more, pad output. Send OS. Program transfer pad. Command complete plus service required INTR? No, wait for pad to finish. Reset INTRs. Done. Service REQ INTR, phase change? No, process error INTR. Yes, sphere halted, short sphere. Process unexpected condition. Bus reset, disconnect or SBC hardware error. 353. Appendix 3, fast track to SCSI. Data out phase. Exit, process new phase. 354. Fast track to SCSI. Status phase. Entry. Status in. Sync. Swait. SIR. MOV. 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 N. CMP. JNE. MOV. CMP. JZ. Test. JZ. MOV. RET. TCH, TCM, TCL. TCLL. PCTL03H. SCMD84H. AL of 1H. ALSSTS. ALOBOH. Sync. AL, DREG. INSO. Swait. INSLOW. SIR. INSLOW. O. S for 1 byte. Status phase. Program transfer. Appendix 3. Wait for SBC command to begin. Check init, busy bit and empty bit. Ready and FIFO not empty? No, wait. Read status byte. INTR. No. Command completed? No, process error. Reset CMD complete INTR. Finished. Process unexpected condition. Bus reset, disconnect or SBC hardware error. 355. Appendix 3, fast track to SCSI. Status phase. Start program transfer. N. Y. 356. Fast track to SCSI Appendix 3. Message in phase. Entry. MXIN. MOV. 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 Sync. MOV. N. CMP. JNE. MOV. MyWait. CMP. JZ. Test. JZ. Test. MOV. JNZ. Call. MOV. JC. Mixit. MOV. MOV. RET. TCH, TCM, TCLO. TCLL. PCTL07H. SCMD84H. AL of 1H. ALSSTS. ALOBOH. Sync. ALDREG. INSO. MyWait. INSLOW. MIR. SIR080H. A09H. MISJect. ProcessSums. G. A07H. MISGreject. SCMDCOH. INSLOW. Read 1 byte. Message in phase. Program transfer. Wait for SBC command to begin. Check init and busy bit. Ready and FIFO not empty? No, wait. Read message byte and automatically hold. AC active for possible message reject. INTR. No. Command completed? No, process error. Message parity error? Parity error code. Yes, send message parity error message. Perform message action. Message reject code. Not valid message, reject it. Negate AC. Reset CMD complete INTR. Finished. 357. Appendix 3. Message in phase, can't. MISGreject. MOV SCMD 30H. MOV SCMD COH. MOV INSLO. Call CheckMSCU. JNET. Call Meexit. JMP Misgout. Mir, Meexit. Fast track to SCSI. Assert ATN, notify target that last message is rejected. Negate ACK. Reset CMD complete INTR. See if target supports message out. No, exit. Send message. Done. Process unexpected condition. Bus reset, disconnect or SBC hard. Where error. 358. Fast track to SCSI Appendix 3. Message in phase. Send message parity error. Y. 359. Appendix 3. 360. Phase decoder. Phase decode. MOV. Test. JZ. N. XOR. SHL. JMP. Phase table. BLPSNS. BLBO. Phase decode. BL07H. BHBH. BXL. CS phase table BX. DW data out. DW Dayton. DW send command. DW status in. DW phase decode. DW phase decode. DW misgout. DW misgen. Fast track to SCSI. Read phase sense regis the REQ asserted. No, wait. Mask out SCSI phase bits. Asterisk 2. Go to phase processing routine. 0 data out phase. 1 data in phase. 2 send command phase. 3 status phase. 4 reserved. 5 reserved. 6 message out phase. 7 message in phase. Fast track to SCSI. Phase decoder. Decode phase. Phase equals PSNS. Process requested. Phase. Appendix 3. 361. Appendix 3, Fast track to SCSI. 362. Appendix 4. Hardware schematic. For PC host adapter. 363. UHLKJ. RHL. .L. 1I. V3. 4LSCH. GL, -2. Underscore. 806-3. I. O, I dash, II. SCSI bus TE, E-hating resistors. 228/330 HTT. Pi all AI1. Dash equals I and as dash 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 2, IO. Pi AZ21, T18 3U4. Pi 1 AZ3 SA74 S3E. 4 to 5. IF. 03S. And I02-7. Plus 5. TI. C. Pi 1 AZ41, TIS 1B. E underscore 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 dash plus underscore 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 SL dot comma, EOL. Pi V311. 74 LSE4. I. A2 ISA4 S Pi. RT. Plus S underscore equals dash 10 KY, underscore underscore J. U3. 7. LS84. PLRSTDRV1. D equals colon dash underscore 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 LRE colon I SS dot ET comma colon U2 74 LS24S Pi AIZL-SLL5. I7-9I4A8B1107. W____ J. RH2. 22833E. 1R. I. SOP-I-I. RSTS, I-I. 9, IY6, I-I. Cell 7. I. Plus S. I. ___. RN3. 220/338R ___. I. T//2. C/1, -3I. Mag 4. Real SII. ACI, -6. I. ATN dash. Dot ___. JPI1A031 SLLG8A. BizLis 893527. Pi1A04 SRN, 713 OS. Pi1A0 SS046 S14 D429 SO. 507. S03511, D3D7, BF J.I equals J.N. .PPLL1A0604A194 is D2D6S06108-I_SDGF-132G. A07L.LC837OS805, L.8-4-SDSIR, : 501.3_BZ17DL. 154.2. Pi A88. 18 to IDD3 SOS043BL13 Foot RI3E.2. 1 foot 1 inch ISDA2 191. I. U29JL. OSNSI. 1 fa.ioe50817si18r : ____ 8 sdpjl e50 : 3l equals es dot dash : ____ I___ dp sopjl b pi sjl or dash q3rdrst-31 ____4 A 14 SLTIO-74 4WRBSY32, 43JL. B13 1 DAC 46, DFLICK cell 34 _G. B1S 47 CLK 11035 58.2. Re, FT1 reset C/036. 0.11. CE2 CS11 SG38. 46JL. REQ39 R pound QR dash equals ___, comma _1. 9.2. R dash equals SA. A3AC1, 144G. 1 foot 1 inch 1A28 SAZ5A280H 4280H.2. Dash plus. RRJL. TJL. 3JL. F4JL. JL. 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 9JL. IL. JL. JL. 12JL. WC, 13JL-DT. J. L1JL. JL. -4J1. Dash JJ. Dash JL. -120JL. I-JL. I-JL. JL, 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 36.11, IRJL, WCJL, 139.N, E48JL, JL, I, FUD, I, A, R, IDFEDL, 1 foot 1 inch 1 AZ91 SA, AL equals. Pi is at m#q4s dash underscore 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 pi dpo us xosci ruiegoc 8 r underscore he IHTR 3E01 dash 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 underscore 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 MGI L I underscore J O C B UI pi 1123 pi A underscore 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 A Galbo and Associates Inc. 811 Hz Asynchronous single-ended SCSI interface PLISPC/XL at EU's connector J1 ISS 8-pin external SCSI connector Board ISIO-I1 UPT at Hexado SLI to JEF uses DNA channel 3N hardware interrupt level S PO box 63 to 467 IRGate FL 33883 B89352 PC/XT/ at SCSI card. O. Date INOV 88. 2. Fast track to SCSI Appendix 5. Appendix 5. SCSI host adapter evaluation. BOA RD for the PC, XT, 0 RAT. 3.0 MB/second asynchronous transfer rate star. Supports up to 8 arbitrating SCSI devices and 64 LUNs. The Fujitsu PC to SCSI host adapter board is a complete solution to connecting the PC, XT, or AT to the SCSI. The board supports arbitration and disconnection. An optional ROM includes the interface common command set with extended commands and driver software to control the onboard Fujitsu SCSI protocol controller, SPC. The board and ROM is everything you need to thoroughly evaluate the operation of the Fujitsu SPC. It can also be used as a tool for debugging your own SCSI driver, by replacing the socketed ROM with a static RAM. Your code can then be downloaded directly from the PC to the RAM. The ROM or RAM may be located on any 8K boundary within the PC's 1 MB address range via a DIP switch included on the board. The PC will look between addresses C8000 and E0000 for the extended EIOs, so the board memory should realistically be located somewhere in this range. The 16 SBC registers are memory mapped for speed and flexibility. Memory mapping the registers eliminates I/O port contention and allows the controller to coexist with the standard disk controller. The DMA channel is selected via a jumper and can be located on channel 1, 2, or 3. Normally the disk controller uses CHAN I3. The interrupt level is also selectable via a jumper and can be set at levels 5, 6, or 7, normally the disk controller uses levels. Asterisk actual data transfer rate will be limited by the PCIO or DMA bandwidth. 365. Appendix 5 Fast Track to SCSI. Hardware. Half card for IBM PC, XT, AT and compatibles. Selectable SCSI 10, 0 to 7. Selectable PC wait state generator for PC data bus, 0 to 3 wait states. Programmable memory map decode and socket for 8K or 16K EPROM, EPROM. ROM and RAM. 32 selectable PC memory maps in 8K or 16K increments. External and internal SCSI connectors to interface with external or internally mounted SCSI peripherals. Odd parity generation for PC bus to SBC. PC DMA channel interface support. SBC interrupt mask register. Description. Software. Onboard 8086 code to drive an SCSI mass storage device which in turn can boot the PC at power up. Common command set accessed as either an independent PC DOS device driver or as a memory resident program via software interrupts. Direct disk I/O function available through standard MLUs interrupt 25H and 26H. Function calls. Contains all logic to interface to standard PC or at bus DMA control. 366. Fast Track to SCSI Appendix 5. Software layers. User interface layer, provides the computer user, programmer, a pseudo high-level support mechanism for supporting SCSI I/O functions. It executes commands via the 8080 SIXS software. Interrupt instructions in much the same way as PC DOS. Operating system calls. The SCSI instructions can be accessed from this layer using common 8086 languages such as an assembler, Pascal, and C. Machine interface layer, interface between PC/XT/at machine and layers 1 and 2. DMA, synchronous and asynchronous I/O are supported in this layer. Also, device driver and /or memory. Resident program support. SCSI layer supports the common command set and extended commands. Hardware I/O layer supports the low-level primitive I/O control between the computer and the SBC. 367. Appendix 5 Fast Track to SCSI. Feature list for the FM1030M SCSI host adapter. General. Interface. MS/DOS. BIOS ROM. CD-ROM. Diagnostics. Form factor. Protocol. Version. SCSI message support. Version. Mode. 368. PC/XF/AT. DOS driver for DOS 2.0 to 4.0. Partitioning software. User application interface. Available. Initiator or target. 1 internal standard 50-pin dual-row SCSI connector. 1 external standard 50-pin D-shell SCSI connector. Supports DMA or programmed I/O transfers. Supports hardware or pulled interrupts. Memory mapped I/O for increased performance. Low power CMOS controller. Half-size card. 8-bit bus interface. 8K ROM socket. EPROM configuration memory available. Address selectable on any 8K boundary. Jumperable DMA channel, 1-3. Jumperable interrupt request level, 2. 7. Removable termination resistors. Jumperable termination power. Fused termination power. On-chip. 5.75x 4.4x.7 ANSI SCSI I and SCSI 2. All non-extended messages. Common command set CCS4B. Hardware, initiator or target. Fast track to SCSI Appendix 5. Physical. Bus. Parity checking. Transfer type. Handshake. Electrical. Bus chip. Burst rate. Connector. Terminators. Termination power. Logical. Firmware. Initial configuration. Reset. Supports arbitration/disconnect/reselect. Yes. Asynchronous. Hardware controlled. Single-ended. Fujitsu MB87030. 0.3 to lol MB/s, dependent on PC speed/DMA controller. Standard SCSI 50-pin D-shell external. Standard SCSI 50-pin dual-row internal. Removable. Selectable. US driver or ROM or both. Automatic. Hard or soft. Contact your nearest Fujitsu sales office for information on demonstrations and loan. Agreements for the SCSI board. 369. Fast track to SCSI glossary. Glossary. SCSI terms. As with most advances in computer technology, SCSI brings new terms and new meanings to the area of system design. Terms and meanings directly related to SCSI are described in this section. Term. Asynchronous mode. Basis SCSI. Bus arbitration. Bus free phase. Command descriptor block, CDB. Command phase. Daisy chained. Direct memory access, DMA. Full SCSI. Meaning. SCSI operating mode where data transfers between initiator and target occurs at discrete rates without regard to specific amounts of time. SCSI product that does not support arbitration. In a SCSI system, the ability of both initiators and targets to compete and gain control of the SCSI bus for data transmissions. SCSI bus is idle. Series of bytes used to define and initiate a SCSI command. SCSI bus phase where initiator is sending CDB to target. A method of electrically connecting multiple devices together so all devices use a common set of command/data transfer signals. Method of data transfer to main memory without use of the CPU. SCSI product that supports arbitration and the reconnect/disconnect options. 371. Glossary. Term. Handshake. Host adapter. Initiator. Intelligent interface. Mandatory command. Message phase. Non-arbitrating. Optional command. 372. Fast track to SCSI. Meaning. Control signals that initiate an asynchronous data transfer between two devices. A handshake is required for each byte transferred and no specific response time is required for either the initiator or the target. Generally, the host adapter is a plug-in board that performs the host bus to SCSI conversion. SCSI device that is capable of beginning a data transfer operation. Usually, the initiator is the host computer, however, in systems with arbitration, the target can also serve as the initiator. Any interface, like SCSI, which can execute a high-level protocol and a supporting set of commands. SCSI command that must be supported by the products to remain compatible with the ANSI specifications. SCSI bus phase, at which time the initiator and target exchange information regarding recent transfers of data. A non-arbitrating SCSI configuration is made up of a single initiator and one or more targets. The initiator is the bus master and the targets are slave. Reselection is not supported since the reselection process requires the targets to arbitrate for the bus. In this basic SCSI configuration, the initiator selects a target and remains connected to the target until the transfer is complete. SCSI command, which may or may not be implemented in an SCSI product, the absence of such a command does not affect compatibility. Fast track to SCSI. Term: reconnect/disconnect. Reselection phase. Reserved. SCSI ID. Status phase. Synchronous. Target. Vendor unique. X3T 9.2. Glossary. Meaning: ability of SCSI device to disconnect from the SCSI bus before completion of certain commands and reconnect at a later time. SCSI bus phase, where a device has one arbitration and a connection between an initiator and a target is re-established. Command code or byte in SCSI protocol. Reserved for a future function. The use of reserved bytes violates the requirements for SCSI compatibility. A 1 of 8 code used to address a device connected to the SCSI bus. SCSI bus phase, where the target sends status information to the initiator. SCSI method of transferring data from initiator to target, or vice versa in a specified time interval. In synchronous mode, a data transfer rate of 4.0 megabytes per second is possible. Any SCSI device capable of receiving commands or data from another SCSI device. SCSI command codes which are undefined. The ANSI number designation for the Small Computer Systems Interface. 373.